Hello everyone, welcome back to another video of Automation Testing Insider, and I'm going to talk about the complete software testing course today. And in this 11 hours video I combine all the topics related to software testing in a single video. So this would be like 11 hours video, and you learn all the concepts of software testing from beginning, from scratch to the end. So like what is software testing, what is manual testing. So I have listed down all the topics step by step, like one by one, right? And uh, if your background is IT or non-IT, it doesn't matter. If you start from beginning, like what is software testing, what is manual testing, what is software development life cycle, so you learn all the concepts one by one. Even if you have experience, and if you want to learn any particular topic, so you can switch to that particular topic as well. So I have provided the timeline in the description box of this video. Suppose you want to if you already know software testing related some of the concepts, and suppose you want to switch to any particular topic, let's say you want to know about this integration testing, so you can just click the link on the timeline which I have given in the description box of this video. Suppose you want to know about traceability metrics, so you can directly switch to that one. If you want to know about test plan, right? So there are n number of topics I have listed down in this 11 hours video. So you can switch to any particular topic and you learn the software testing concept. So let's get started with this video. And if you're new to this channel, then please subscribe it, and please watch this video from the beginning till the end. Thank you. Hello friends, welcome back to automationtestinginsider.com. And from today onwards, I'm going to start a new series in software testing or manual testing, and we'll talk about different fundamentals of software testing or manual testing. Okay, so this particular series is very useful for the guys who have just passed out, and suppose someone is already working in somewhere and some other stream and they want to move to software testing. So this tutorial is very useful for them. So today we are going to talk about what is software testing, and in coming days we'll talk about different topics as well. So I'll show you what are the different topics which we are going to cover in a couple of minutes. Okay, but today let's talk about software testing. Okay, so what do you mean by software testing? So software testing is the process of evaluating or verifying that a software or application does what it is supposed to do. Okay, in simple words, what I would say, software testing is the process to test the application. As simple as that, right? Or in other words, I would say testing of an application to find the defects. Okay, and other definition might be maybe like what you can say is testing of an application as per the customer requirements, that it should meet the customer requirements. Okay, so in simple words, I would say that testing of an application is called the software testing. Okay, because developer develops the software. Now it is up to us to test the application, because every application has to follow the testing process. Every company or every application has to be followed with the testing process. Okay, so in simple words, testing of an application is called the software testing. Whether we are doing the manual testing or automation testing, it has to follow the software testing methodology. Okay, so in coming days, guys, we are going to talk about so many topics like software development life cycle, different kind of testing, different fundamentals of testing, manual testing. Okay, and we are going to cover software testing life cycle as well. So there are so many topics. So I'll take you to my PPT where I'll show you what are the different topics I'm going to cover. And yeah, let's see some the definition of software testing, which we have just talked about. Okay, and different topics which we are going to cover in coming days. So let me take you to my PPT, my system, and we'll see the PPT. Okay, complete course contents. What are the topics which we are going to cover as part of software testing or manual testing? So we are going to talk about like we have discussed what is software testing, and there are so many topics under software testing which we are going to cover. Like we'll discuss about the we need to understand when we talk about software testing, so basically we need to understand the software development life cycle as well. So we'll talk about SDLC in detail, and then we have different software development models. Okay, so software testing is the part of SDLC process. Okay, so and to follow to for the development life cycle, we need to follow certain development models. So we'll talk about different development models. Like we have waterfall model, which is old one, okay, and we'll talk about spiral model, and nowadays we are using the agile methodology, so we'll discuss about agile in detail. So we have different types of testing as well, so we'll talk about different types of testing, and then we'll talk about unit testing and techniques in detail, and then we have agile methodology. So separately I'll create a separate video on agile methodology. We'll discuss about agile, scrum, and all those stuff in detail. Talk about SDLC. Since we are going to discuss about the software testing, so we need to talk about software testing lifecycle. So we'll discuss each of the different testing life cycles in detail. Okay, so we'll talk about software testing life cycle, and then we have different test case design techniques. So the complete process, how to author the test cases, how to design the test cases, and what are the different techniques we are going to use for the which we are using for test design techniques. We'll discuss about that. I'll talk about test plan, okay, how to planning the your test. Okay, so we'll discuss about all these stuff. And defect life cycle is very important, so we'll discuss about defect life cycle. So these are the important reporting and test metrics as well. So this is some of the topics I have just listed down here. Many of the topics I have not listed down here, but these are the main topics which we are going to cover in coming days. So this tutorial would be very exciting and very important for all the QA engineers. So if you are beginner, then I think it's very good tutorial. Okay, so this is what we have discussed. What is software testing? You can see the definition over here. What software testing is conduct to verify the application is working correctly or not, which we have discussed at the beginning of this video. Testing is conduct to find the defects in the application, which is software testing. Okay, to validate the application is working as per the customer requirement or not. So these are the different points about software testing and types of software testing. So we have manual testing, okay, which we are going to discuss in the next video. So what it says, human perform the test step by step without test scripts. So that is manual testing, which we have discussed at the beginning of this video. And then we have automated testing. So tests are executed automatically via test automation frameworks. Okay, so we have different tools when tests are executed using different tools, so that is called the automation testing. Like in our channel I have talked a lot about Selenium automation tool. Okay, so similarly we have UFT, test complete, we have Tosca. So there are so many tools, automation tools in the market. Using them we used to do the automation testing. Okay, we have Catalani Studio. So there are so many tools, guys, in the market. So that is, so whenever we test the application using any automation tool, so that is called the automation testing. Okay, so or automated testing. So this topic I'll cover in the next video, what is manual testing. So thank you guys for watching, and if you are new to my channel, then please subscribe this channel and click the bell icon to get the notification for upcoming videos. So thank you guys, have a nice day, bye bye. Hello friends, welcome back to automationtestingside.com. So in the last video we talked about software testing. Now today we'll discuss about manual testing. So what do you mean by manual testing? So testing of an application to find out the defects and test the application manually is called the manual testing. So the name itself says right, manual testing. So testing of an application without any automation tool is called the manual testing. So take an example, suppose we have airlines website, airline application, okay, and we want to test it. So what we need to do, we have to manually involve, right, we have to involve physically we involve in the application. Like to test the application, we have to log in the application, we have to book the tickets, okay, we have to select the form date and to date to book the ticket, and this is how we have to test the different functionalities manually. So, and there is a certain process about the manual testing as well. So in couple of minutes I'll show you what are the different things in manual testing. So we'll discuss about what is manual testing and how to perform the manual testing, what are the different types of manual testing in couple of minutes, guys, in my PPT. and at last we'll discuss about some misconception about the manual testing. So let's get it started. The defects, bugs in a software program. We will defects, bugs, and error in detail in a separate video. So right now, what you can understand is if something is not working as expected, is called the defect. Okay. So manual testing is the process of finding out the defects, bugs in a software program. This is one of the definition of manual testing. A tester performs the end user rule and verifies if all the features are working properly or not. So this is called the manual testing. Okay, so if we need to act as end user, guys, end user, because we are delivering the application to the customer, so we need to act as a customer to verify the application whether it is working as per their needs or not. So that is manual testing. The tester performs the test step by step manually. During the testing, we can assess the quality of the application. So as long as we'll do the testing, definitely the quality of the software will be increased, because we will find so many defects, we'll raise them and get it fixed. So definitely the quality of the software will be increased by doing the software testing or manual testing. What are the different types of manual testing we can perform? We have unit testing. We can perform using we can do the unit testing and integration testing. We have black box testing, box testing, we have system testing, and we have acceptance testing. So these are the different testing, guys, and we have so many subtypes of all these testing types as well. So I'm not going to explain right now in detail, but we are going to talk about so many testing types in detail in coming days. So for your understanding, just understand like these are the different kind of testing which we can perform manually, which we can do manually. Okay, so these are the different types of testing and how to perform manual testing. Okay, so there is a certain process like SDLC process, software testing life cycle. Okay, so I'll talk about the brief about the testing life cycle. So understand the requirements from the software requirement specification document. So first thing is we need to understand the requirements. What is the customer requirement? And identify the scenario and create a clear test plan. So if you're not aware of this scenario or test plan, all these stuff, right? So we'll discuss them in detail. Do not worry about this. Okay, because we are going to discuss about a lot of topics in coming days. Design the test cases that cover all the requirements defined in the document. So third step is design the test cases which covers all the requirement defined in the document. Get the test cases reviewed. Okay, so we'll talk about test cases also. What is test cases, what is use cases. Okay, we'll talk about all these stuff as well. So design the test cases means authoring the test cases which covers all the requirements from the customer, and then we need to get it reviewed from the from our peer or from our lead. Okay, peer level review and then QA lead level review based on and update it based on the reviews, and execute the test cases and detect any defects, okay, or bugs. So whenever we get any defect, we have to log it, okay, and report the defects to developer and track the status. And at last, once bugs gets fixed, again execute the failing test cases to verify they are passed. So this is just kind of a brief about the steps, or I would say the complete testing process. But in coming days, we are going to talk about SDLC in detail and defect lifecycle as well, and we'll discuss about defect, error, all these terms we are going to discuss in detail, guys. Important about manual testing, like misconception or some myths about manual testing. So what is the first one? Anyone can do manual testing. So this is totally a misconception or myth, guys. Like anyone can do the software manual testing, okay, because it requires certain knowledge and you should have very good understanding about the software testing. There is certain process, certain methodology you need to follow to do the manual testing. So This is totally wrong that anyone can do the manual testing. It's not an easy job. The second myth is testing is just verifying the app from the UI. So again, one more myth about the testing, guys. Like anyone can, I mean, it just verify the UI. It's not like that, because we have to do lot of different testing. It's not just about the UI. Like by seeing the UI, we need to just do the UI level testing. It's not like that. We have to do a lot of other testing as well. Like we have to do the integration testing, system testing, and then database testing also involves. Okay, so there are so many kind of things involved in testing. It's not just like we need to just see the application. Let's say we have Facebook application, so we need to just see the application and do some testing. It's not like that, because we have to verify all those details, like whether let's say I'm entering the username, password, and then other details entering, right? So all those details should be captured in the database, and there are so many other factors as well. So we'll discuss about what are the different types of testing we can do. It's not just about the UI. Myth 3, number 3 is testing ensures 100% defect free product. It's totally wrong. So if you can do any kind of testing, whatever you'll do, it will not cover the 100% defect free product. So this is a myth about testing. Like whatever you do, if even if you are very intelligent or you are excellent, you cannot cover the 100% functionality of any application. Okay, so this is again a misconception about the testing or manual testing. Okay, another one is automated testing is more powerful than the manual testing. So this is totally wrong. So unless if your product is stable, okay, you cannot do automation testing first of all. Okay, so we need to perform the manual testing firstly, and then we need to ensure that it is good enough to do for I mean our application is good enough for the automation testing. Then only we have to go for automation testing. Okay, and it is more powerful. How can you ensure that, right? First we need to do the manual testing, and we need to see like what are the different I mean there might be so many defects, right? When we do the testing, so we say that manual testing is powerful or automation testing is powerful, because they have different uh, pros and cons of automation testing as well as manual testing. So we cannot say that automated testing is more powerful than the manual testing. And one is manual testing is non-technical and easy. So this is again a myth, guys. So as I have discussed earlier, like in point 1, like it's not easy, and we should have some kind of knowledge about the software testing process, the methodology, and the thinking is very important to do the software testing. Okay, so these are the different misconceptions about the manual testing. So thank you, guys. In the next video we'll discuss about probably software development life cycle. So if you are new to my channel, then please subscribe the channel and click the bell icon to get the notification for upcoming videos. Thank you, guys. Hello friends, welcome back to another video of automationtestingsider.com, and today I'm going to talk about SDLC. So SDLC stands for Software Development Life Cycle. So it is a process to build any software in a systematic way, and there are different stages are involved in software development life cycle. So what are those different stages? Like we have system investigation, we have requirement analysis, we have design, we have coding, we have testing, and at last we have release and maintenance of the product. So these are the 6 different stages of development life cycle. So do not worry about, guys. I'm going to talk about them in detail in a couple of minutes in my PPT. And there are different stakeholders are involved in any to build any software in any company. Like we have business analyst, we have product analyst, or subject matter experts. So these are the different, more or less the same designation, guys, we have. Like we used to call product analyst in product based companies, or we used to call business analyst in business in service based companies. So, and we have subject matter experts as well. So these are the expert guys in particular area. Like suppose we are going to build a software in finance domain, or e-commerce application, or any other domain. So these are the guys who understands the requirements from the client. And we have project manager to develop the complete project plan of the software or product. And then we have architects who builds the framework in the sense like designing of the complete architecture of the software, like high level design or low level design. So I'm going to talk about them in detail in my PPT. And then we have separate dev team for the programming to develop the software. We have development team, and we have testing team as well to test the software. And we have separate release team as well. In some companies we have separate release team, release engineers. They release the software, and then at last we have support guys. After the release we have to maintain the software, or the support of the software. We have separate support guys. So these are the different stakeholders are involved in any software development life cycle. And then we have of course we have finance team as well to discuss about the cost of the software, or the negotiation with the client. We have finance team. And then we have HR team as well for the recruitment of the new resources, or based on the desired skill sets. We have separate HR team, or development acquisition or talent development team. So these are the different stakeholders are involved in any to build any software, guys. And now let's talk about the different stages in detail in my PPT. So let's get started. So guys, let's talk about software development life cycle in detail. So as I have discussed earlier, like any project development has to follow below phases. Like we have system investigation, requirement analysis, design, coding, testing, and release and maintenance. So these are the different phases are involved to develop any project in the software development life cycle. Now let's talk about them in detail. So what is system investigation phase? So in this particular phase, BA are involved to get the current business scenario or current business process of the customer, to understand their pain points, their issues. So BA is involved in this particular phase. So let's see what it says. This is an important phase, necessary stage in software development life cycle. Understand the existing business process, as I have discussed earlier. Gather all the data, like what the customer wants to build, who will be the end user, what is the objective of the product. These are all done in this system investigation phase. It is business analyst, as I have discussed, and project organizer's responsibility. Basically, we used to connect with the client frequently with the help of business analyst. The higher management is also used to connect with them to understand their pain points, issues, like what are their expectations from the company. So these are all done in this system investigation phase. So next is requirement analysis. Again, BA will play an important role over here to get the requirement for the upcoming project, for the current project, for which we are developing the software development. We are following the software development life cycle to get the current requirements from the client. So the next stage is to certainly represent and document the software requirements. So this is accomplished through BRD, FRD, SRS, and FRS documents. So what are these documents? So we have BRD. BRD is business requirement document, and it is built by business analyst. We have FRD. It is functional requirement document. So this document tells us like what are the customer requirements to build any software. Okay, so what are the requirements from the customer is documented in business requirement document, and it is done by business analyst. And with the help of BA, we used to pass all this information. We used to give this to the technical team, where all the document will be uh, uh, document will be created in detail level by FRD document, functional requirement document. Like what are the customer requirements is captured in BRD document, and detail level information are captured in functional requirement document. And there is software requirement specification document, and it is developed by architect, system architect. Okay, like we have who is building the framework, define all the software required for the software for the product development or project development. And then we have functional requirement specification. So these are all different documents we have to capture all the requirements from the client. So this is accomplished through BRD FRD SRS document, which contains all the product requirements. The requirement collected two types. What are those two types? So we have functional requirements. It specify the behavior of the application is called the functional requirement, like how our product will behave is called the functional requirement, and non-functional requirements. So we have to capture both functional and non-functional requirements in our documents, like specify the characteristics and feature of the application, like performance, compatibility, and usability, or security. All will be done, all comes under non-functional requirement. We'll talk about them like performance testing, compatibility testing, usability testing going forward. Now here comes the design part. So here system architect or architect involved in this particular phase, and this phase is about to bring down all the knowledge of the requirements, all the documents which we have prepared, analysis and design of the software project. Okay, so we have to analyze it and we have to design the framework. Okay, so in this particular phase, this phase is the product of the last two. Like it is the combination of system investigation plus requirement analysis, like inputs from the customer and requirement gathering. So in this particular phase, we used to build uh, high level design and low level design. Low level design. So what do you mean by high level designs? So take an example. Suppose I'm a builder and I am constructing a community apartment. Okay, and so there in high level design, what I will do, I'll capture all the high level information, like how it should be, how the community should be, like uh, what are the different what is the high level architecture of the community basically. Like it should have a gym, it should have a community hall, it should have the play area, and it should have like number of flats. So these are all comes under high level design. Okay, and low level design is nothing but like in detail level, like in particular flat, how many rooms will be there, like we are we going to build 2 bhk, 3 bhk, all these information comes under low level design. So system architect divides the design into two parts, high level design and low level design. So these are all done in this designing part, software design part. Now here in this coding, developers are involved. In this phase, the actual development begins and the programming is built. It is the responsibility of the developers to write the coding based on design. Whatever the architects designed the uh, product, based on that, it's developers' responsibility to write the code. Developers have to follow the coding guidelines described by the management and the programming tools. Now here comes the testing. After the code is generated, it is tested against the requirements to make sure the products and solving the needs address and gather during the requirements stage. So we need to, in this particular phase, we have to create the, whenever we get the from the requirement phase itself, we used to create, the tester used to create the test cases, test plan and test cases, and based on that we used to make the changes when actual testing is happening. So in this particular phase, we execute all our test cases based on the customer requirements, like we have captured whatever we have captured in the test cases in the form of test cases. During these stage, unit testing, integration testing, system testing, and acceptance testing are done. So these are the different testing levels, guys. Unit testing is performed by the white box tester or developer, and then all these testing like integration testing, it is the integration of the different modules. We have system testing, acceptance testing are done in this particular phase. So all kind of testing are performed in this particular phase. And release and maintenance. So once the software is certified, if everything goes well and there are no bugs or errors are stated, then it is deployed into production. And if any issue in the software or any changes required, it comes under the maintenance part. So let's say suppose customer comes back with their further requirements, or they want to change something in the software, then that will be comes under maintenance part. So taking care of the developed product is known as maintenance. So that is maintenance, and the maintenance of the project can be taken place by supporting or post production team. So we have, as I have discussed earlier, we have support guys or post production team, who are taking care of this maintenance part. So this is all for today, guys, and please like, share, and if you have any question, then please comment your question in the comment box. And thank you for watching, and please subscribe this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Hello friends, welcome back to another video of automationtesting.com. So in the last video we talked about SDLC process, software development lifecycle. So in this particular video I'm going to talk about waterfall model. So there are different models in the industry to develop the software. Okay, so to follow the SDLC process, software development lifecycle process. So what are the different models we have in the industry? So we have waterfall model, we have iterative model, we have spiral model, we have agile model, we have derived model, we have prototype model, we have hybrid model. So these are the different models we have in the industry to develop any software. And waterfall model is the traditional model. And yeah, so in this particular video I'm going to talk about what is waterfall model, when to use waterfall model, and what are its advantage and disadvantages. Okay, so let's talk about like what is waterfall model. So waterfall model is a base model or basic model, and it's traditional model, and it's very old model. So it is also called linear sequential model. So if you have seen the last video, like we have certain phases in development, software development life cycle. Like we have requirement system investigation, we have requirement analysis, design, coding, testing, and release and maintenance. So in waterfall model we used to follow all these process, all these phases step by step in a linear sequential manner. So this is the reason it is called linear sequential model as well. So it's like waterfall, like from top to bottom, all the phases are in a linear sequential manner. So that's the reason it's like ladder. Okay, so once until unless if one first phase is not completed, we cannot jump to the next phase. So that is the important concept behind this waterfall model, and we cannot come back from the next step to the previous step as well. So we'll talk more about waterfall model in my PPT as well. So this is about the waterfall model and when to use. So when the project is very short, it's not complex, then we can go for waterfall model. And another thing is, if requirement is clear, then we should go for waterfall model. So I'll take you to my system and I'll show you in PPT like what are its advantages and disadvantages of waterfall model. So let's get started. So let's talk about what are the different software models we have in the industry. So any project development has to follow SDLC phases. So we talked about SDLC phases like requirement analysis, design, coding, testing, and release and maintenance. And based on the size of the project, cost, availability, we can implement different models as per SDLC phases. And each model has its different approach, guys. So let me talk about what are the different models we have. waterfall model, which is called linear sequential model, we'll discuss about today, and iterative model, spiral model, V model, agile development model. And agile development model is very frequently using nowadays, and it's very important. Prototype model, hybrid model, and derived model. So these are the different models we have in the industry to develop any software. And mainly today we'll focus on waterfall model. And in coming days, I'll explain each and every models, whatever we have listed down here. So let's get started with the waterfall model. So as I have discussed earlier, the waterfall model illustrates the software development process in a linear sequential flow. In the next slide, I'll show you like what do you mean by this linear sequential flow, because there are different phases in waterfall model like SDLC, and that is in linear sequential flow, linear sequential manner. This means that any phase in the development process begins only if the previous phase is complete. And waterfall model is sequential model that divides software development into predefined phases. Each phase must be completed before the next phase can begin with no overlap between the phases. Now let's understand with the help of representation, guys. So I'll draw a diagram so that you can understand it better. So as we have discussed, different phases are there in the software development life cycle. Like we have requirement analysis, design, yeah, so these are the different phases in waterfall model. Like we have requirement analysis, and you can say feasibility study as well. And we have design, coding, testing, and release and maintenance. So the flow is like once requirement analysis and feasibility study is done, so the requirements will be freezed. So the flow will be like this. Then only we can jump to the next part, design part. And once the design is done, design will be done by the architect who designs the complete framework architecture. And once design is done based on the requirements, then developers will start coding. Implementation or coding will be started at that time, and then once coding is done, then tester will perform the testing. And at this point we'll perform all kind of testing, all kind of system testing, all levels of testing. And then if anything, if we get any defects, then we'll revert it back to coding team, developers, and they will fix the defects. And then last is release and maintenance. Once testing is done, everything is done, if everything is working correctly, then we'll deploy the product. So this is how it looks like, the waterfall model, phase by phase. And it is linear sequential flow because from requirement analysis we are going to design, then coding, testing, and maintenance. So this is in a flow, right, in linear sequential flow. So if you see like waterfall, so waterfall looks like this. Water is flowing, it's flowing from the top to bottom like this in a linear sequential manner. So that's why waterfall diagram looks like this only, in this way. You don't see like this anywhere in the waterfall model. Okay, so it looks like this because of it represents the waterfall. And we cannot come back once our the phases are done, right? So suppose requirement is done, feasibility study is done, and we jump to the next phase, then we cannot come back and change the requirement. So this is not possible in waterfall model. Same thing over here, we cannot come back and design again from the implementation to the design part. Similarly for testing as well, we cannot ask the developers to start the new testing for the new functionalities. So this is also not happening, and the last as well. So this is useful for smaller projects. Will in the next slide will understand like what when we should use waterfall model. Yeah, and this is the oldest model, traditional model, and this is also called basic model as well. So let's have a look the next slide. So when to go for waterfall model? So when requirements are not changing frequently, then we should use waterfall model. Another thing is application is not complicated and big. As I have discussed earlier, like it should be small project, then we can go for waterfall model. Project is short and requirements is very much clear. Environment is stable and technology and tools used are not dynamic and stable. So these are the different uh, things for which we should go for waterfall model. Then what are the different advantages of waterfall model? So this model is easy to understand and easy to implement. It is suitable for small and medium sized projects. No change in the middle of the project. So there won't be any changes in the middle of the project. Suppose we want to change any requirement, then this model doesn't allow that. It is suitable for projects if requirements are finalized in the beginning. There are some disadvantages of waterfall model like no feedback path. So what do you mean by this? So in this model, it assumes that no error is ever committed by the developers during any phases. Therefore, it does not incorporate any mechanism for error correction. So once everything is done, we cannot come back in the phase of waterfall model. Once one phase is done, we cannot come back from the previous phase, next phase to previous phase. So there is no chance of feedback. Not a good model for complex and object-oriented projects. Poor model for long and ongoing projects, and cannot accommodate changing requirements. So it will not take the if requirements are changing frequently. So this is all for today, guys. So thank you for watching. Please like, share this video and comment if you have any questions. And please subscribe this channel and click the bell icon to get the notification for upcoming videos. In the next video, probably we'll discuss about iterative model. Thank you so much. Have a nice day. Bye-bye. Hello friends, welcome back to another video of automationtestinginsider.com. So in the last video we talked about waterfall model, and we have seen there are some drawbacks in waterfall model. Like if requirements are changing frequently, then we cannot go for waterfall model. And if project is big or complex, then we should not go for waterfall model. And another thing is, unless if our first phase is not done, then we cannot jump to the next phase, and also we cannot come back from the next phase to the first phase. So these are the main drawbacks of waterfall model. So to overcome all these drawbacks, here we go for iterative model. Okay, so what is iterative model? The name says iterative, so it works on the basis of iteration. Iteration is nothing but when we do something again and again, when we perform some task again and again, it's called iteration. So let me explain like what do you mean by iterative model. So take an example, we have some requirements from the customer. Let's say we have XYZ requirements from the customer. Now the first step in iterative model is we should prioritize our requirements. So take an example, in this case I'll first go for the requirement X, okay, and then we'll follow the complete SDLC process like requirement analysis, design, coding, testing, and release and maintenance. So I have picked one requirement at a time like X, and then we follow the waterfall, like what are the different SDLC phases we have: requirement analysis, design, coding, testing, and release and maintenance. Release. Okay, so we'll follow all those steps and we'll deliver the first build of software, working software. So this is first iteration. Now After getting the feedback from the customer, uh, getting the feedback and reviews from the customer will work for the requirement Y. Now again we'll perform the same task like requirement analysis, design, coding, testing and release. So this is iteration 2. Similarly for the third requirement, that is Z, X, Y, Z. So the Z, the last one is Z. So we'll work for the will follow the same process for requirement Z. So we'll follow the same procedure again and again till we gets the final build. So this is how iteration works. Okay, this is called the iterative model. So let me take you to my PPT where we'll discuss like some of the theoretical stuff of iterative model and also discuss about pros and cons of iterative model, and I'll explain you better with the help of diagram there. So let me take you to my PPT. Guys, let me just recap what we have discussed at the beginning of this video, some theoretical stuff so you can make a note of it, like what do you mean by iterative model, how it works. So we create rough product or product piece in one iteration, then review it and improve it in the next iteration and so on until it's finished. So we work on the basis of it works on the basis of module, like module wise, and then we'll get some reviews from the customer. So we'll work like module 1, module 1, 2, 3 and so on till we get the final build. And in the next slide I'll show you with the help of example whatever we have discussed at the beginning of this video. So the basic idea behind this method is to develop a system through repeated cycle. Iterative, and it is and in a smaller portion at a time, incremental. So this is also called incremental model. Okay, so this is the combination of iterative plus incremental. Why it is called incremental? Because it increments the requirements, like module 1, module 2, we got some other requirements, and then module 3. So we and incrementally adding all those requirements, those modules. So that's why it is called incremental module as well. Now let me explain with the help of an example. So suppose we got some requirements from the customer. Take an example. This is requirement x1, y1, z1, x2, y2, z2, and x3, y3, z3. So these are the requirements we got from the customer. Now we'll follow the SDLC process, the complete SDLC process to build the software. So in the previous slide we have seen like we have to deliver the first working piece of software. We'll follow the complete life cycle like requirement analysis, then design, then coding, plus testing, and then release and maintenance. And at last we get the feedback and reviews from the customer for this build. So this is complete one process, guys, and this is called build one. So do not worry about the build and release. I'll create a separate video. What do you mean by build and release? So we followed the first module. And this is consider this is module 1. Okay, consider this is module 1. This set of requirements under module 1. Now we followed the complete steps. So this is called iteration 1. Now we got some feedback from the customer and reviews, and we'll work based on those reviews and feedback. We'll work on module 2. We add those feedback and reviews in module 2. Okay, suppose they want to make some changes in module 1, so we'll make the correction and we'll integrate with module 2. Now we develop module 2 along with module 1. Now we'll follow the same procedure again and again, like requirement analysis, design, coding, testing, and release. So this is iteration 2. Now again we'll get feedback from the customer, reviews from the customer. Okay, now we'll develop module 3. So we'll keep adding module 1, 2, 3 and so on till we get our final build, final product. So this is how it works, the iterative model. It is called incremental. Why? Because we keep adding module 1 plus module 2 plus module 3 and so on. That's why it is incremental. And iterative because this is, we follow the same procedure again and again. Okay, so this is one SDLC process, iteration 1. This is again we followed the SDLC phase, iteration 2, and this is iteration 3. So this is about iterative model. And another thing is, like, module 2 can start parallelly as well. Suppose we have already working on module 1, now we can start module 2 as well at the same time. Maybe after it reached over here coding phase, then we can start parallelly module 2 as well from requirement analysis. So it can run parallelly as well, and it works for the project which has multiple modules. Like in this case we have divided into 3 different modules. So this is how it works, guys, iterative model. Now let's talk about some advantages and disadvantages of iterative model. So testing and debugging during smaller iteration is easy. We have divided into different modules, so debugging is easy in this case. It is easily acceptable to ever-changing needs of the project. So this is the biggest drawback in waterfall model. Like, we cannot change the requirements, we cannot come back and change the requirement, but here we can accept the requirements. Limited time spent on documentation and extra time on designing. So this is an important point. So we spent less time on documentation and extra time on designing. Risks are identified and resolved during iteration. So whatever risk we'll get, we'll talk about risk in the next model, that is spiral model. More about some more points about the risks. However, I'll create a separate video on risk because because we have a complete tutorial on risk as well, because that is separate part. So risks are identified and resolved during each iteration. So what are the different disadvantages of spiral model? So it is not suitable for smaller projects. So since we have divided into different modules, and we work on the basis of SDLC, and we followed module wise concept. So if cost will be increased if we follow this for smaller projects. Okay, so maybe it will not applicable for small projects. Design can be changed again and again because of imperfect requirements. So if you don't get the correct requirements, then design can be changed again and again. So this will cost this will double the budget of the project. Requirement changes can cause over budget, the same thing. And then project completion date not confirmed because of changing requirements. So yeah, completion date is not confirmed because of the changing requirements. So these are the drawbacks of spiral model, sorry, iterative model. So in the next video, guys, I'm going to talk about spiral model. So thank you, guys. Thank you so much, and please like, share, and comment if you have any questions, and subscribe this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what is the difference between project and product. So many people are getting confused between what is a project and what is the difference between project and product. So let's talk about like what is the difference between project and product. So let's talk about project first. So when we develop a software, when we build or develop a software for any specific customer based on their needs or their requirements is called a project. And when we build a software for wide range of customers based on market requirements is called a product. So this is the difference between project and product. And there could be multiple projects under a product. So let me give an example. So suppose I'm working for a company called X and we are building a software in like trading platform. So if you are aware of stock market, so there are different segments in stock markets. Like we have equity segment, we have derivative, we have forex, we have mutual funds, and my company X are having different clients. We have different clients like client A, client B, client C, client D. So these are the different clients we have. Now client A wants to trade only in equity segment, and client B wants to trade equity and derivative both. Client C wants mutual fund only. So we need to work with them in a separate project. So here we have a separate, like we have a single product, but projects are different based on our client's requirement. So this is the difference between project and product. And so here you can see like we have multiple projects under a product. Like we have product a trading platform, but based on our clients requirements we need to deal with separate projects with them. Now we have two types of companies, like we have project based companies and like we have service based companies and product based companies. So what happens in service based company? Okay, so like we have Infosys, TCS, they are all dealing with different clients, and they are dealing with different projects, they are handling different projects with different customers. So they are service based clients, service based companies. And we have product based companies. Okay, so we have Google or Microsoft, so these are product based companies. So like we have product Google Pay, so which is widely used. Individuals are also using, companies are also using this Google product, YouTube or Google Pay. So Google Pay is nothing but a product, YouTube is nothing but a product. So this is the difference between project and product, and service based companies and product based companies. So guys, if you have any questions or anything, then please comment it, and yeah, please like, share this video and click the bell icon to get the notification for upcoming videos, and please subscribe it. Thank you so much. Hello friends, welcome back to another video of Automation Testing Insider.com. So today I'm going to talk about spiral model. So in the last two videos we talked about waterfall model and iterative model. So if you have not watched those videos, then please I would recommend please watch those videos and come back to this video, because until unless if you don't understand like what is waterfall model and what is iterative model, you cannot understand spiral model. So it's important to go and watch those videos. So I have given the link in the description box of this video, the complete playlist link. You can go and watch those videos and come back to this video. Now let's talk about what is spiral model. So we have seen there are some drawbacks in waterfall model and iterative model. So to overcome all those drawbacks, here we go for spiral model. So what do you mean by spiral model? So spiral model is the combination of waterfall model and iterative model. Okay, so let me take you to my PPT where we can understand better with the representation of spiral model, and we'll see some notes about spiral model and pros and cons as well. So let me take you to my PPT and understand better like what is spiral model. Guys, as we have discussed at the beginning of this video, like a spiral model is the combination of waterfall model and iterative development approach, iterative model. So let's talk about some of the points about a spiral model. So you can make a note of it. And in the next slide, I'll show you with the help of diagram. We'll understand better like what is the spiral model. So let's get started. So it is incremental development approach. It is incremental development approach. So you have seen in iterative development approach, like we used to develop the product based on the requirements. Like we prioritize the requirement and we develop module wise, module 1, module 2, like that. So that's why it is called incremental development approach. The project is developed phase by phase. Phase by phase, the new requirements are integrated to the existing application. So as I have discussed, like module 1 we have certain requirements, and then in module 2 we'll add some more requirements, and so on. The requirements are prioritized based on business requirements. This is a risk driven software development process model. So as I have discussed, like this is the combination of waterfall model and iterative development model, but there is an extra factor like risk analysis. So it's risk, there is a high percentage of risk analysis in spiral model. So it is also called like risk driven software development process model. So it is suitable for large and complex projects. This spiral model is the combination of iterative development process model and sequential linear development model, that is waterfall model, with a very high emphasis on risk analysis. So this is these are the some notes about spiral model. Now let's talk about in detail like what is a spiral model with the help of diagram. So there are four phases uh, in a spiral model. So first phase is planning. We have first phase is planning, and then we have risk analysis. Third would be coding and testing, or you can call it as engineering as well. Engineering, or you may call it as implementation. Implementation, or so the third phase you can call it as coding and testing, or engineering, or implementation, and the fourth one would be evaluation. Evaluation. So evaluation is done by customers. They'll provide the feedback. So let's start with the planning phase. So yeah, it starts from here. So suppose we got some requirements from client, and in this particular phase, planning phase, what happens is BA works with customer to get the requirement, and with the help of project manager, they used to estimate the project and do the complete the planning of the project. So let's say we have divided our requirements into different modules. So right now we are working on module 1. This is module 1. So this phase will start like this. Now we need to do risk analysis for the module 1. So we'll do risk analysis over here. So first of all, we need to understand like what is risk. So risk is the possibility of something bad happening, and you can say like it involves uncertainty, uh, events like it may or may not happen in the future. So there are certain phases in risk, like certain steps to resolve the risk, like we have identification of the risk, evaluation, prioritization of the risk, and there could be different project related risk, like scope related risk, and cost related. We have schedule related as well, and lack of clarity in the requirements, resources unavailability. So these are the different risks we have. Cost related means if cost is the at higher side, so that will be a risk. We'll do all kind of risk analysis in this particular phase. So do not worry about guys like risk, because risk analysis is a separate topic we can discuss later on. So for now you can understand like these are the different risks, like whatever I have talked about related to project. So we'll do all kind of analysis over here. So risk analysis for module 1 is done. Now coding and testing will be done over here. So whatever requirements we got, we'll do the coding, developer will do the coding, and they will implement the coding, and then they'll send it to testing team for testing that particular module. So we'll do the testing of module 1 over here. After successful once successfully tested module 1, then we'll go for the release, and we'll do the release over here. So module 1 will be released over here, and based on customer reviews and feedback, we'll work upon module 2. So we may add some more requirements. We can change the requirements from module 1. We can update the requirements of module 1, and we'll work with the new requirements from module 2, and then we'll start module 2 over here. And then same process will go like this. Planning phase, again we'll do the planning for module 2, and the same thing like risk analysis for module 2 will be done over here. And then coding of module 2, and developer will integrate module 2 with module 1, and we'll do integration testing of module 1 plus module 2 over here, and we'll do regression for module 1. So we'll make sure that the changes of module 2 does not affect the module 1. So that's the reason we do the integration and regression testing over here. Do not worry about different testing like integration or regression testing. We'll discuss in coming videos. So once testing and everything is done for module 2, and then we'll deploy module 1 and 2 over here. Module 2, 1 and 2 integrated, and we deployed successfully, and we'll work for module 3 over here. So this is how we'll keep working on module wise. So let's say this is module 3. Now again the same process, will start planning of the module 3, and then we'll do the risk analysis for module 3, and then again we'll do the developer will integrate module 1 and 2 with module 3, and we'll do the integration testing between among module 1, 2 and 3, and then we'll do the regression testing, like module 1 and module 2 does not get impacted, and so on. This process will go. So this is a spiral model, guys. So this is the combination of like iteration, like iteration is there, you can see here, like we have iteration is nothing but repeatable things. So we are keep repeating the same phases like planning, risk analysis, coding and testing, and evaluation. We have 4 phases over here. So we are keep repeating all these phases. So that is iteration in a spiral model, and incremental is nothing but we are adding module 1 with module 2 and module 3. So this is how we are developing the software. So this is about spiral model. Now next we'll discuss like when to use a spiral model. So when deliverance is required to be frequent, so we'll get when we get the frequent requirements from the customer, so we should go for spiral model. When project is large, of course, and when requirements are unclear and complex, so we can go for spiral model, because in this particular model there is high risk analysis, so we can take the requirements in the middle as well. So what are the different advantages of spiral model? The requirement are prioritized based on the business requirement, so that is the advantage we have. We can prioritize our requirements, like from whatever requirements we got from the customer, we can prioritize them and we can work upon those requirements. It is suitable for large and complex projects. There are some disadvantages of spiral model, like can be a costly model to use, because as I have discussed earlier, like we have to do high level of risk analysis, so uh, it could be a costly model. Risk analysis needed highly particular expertise. Doesn't work well for smaller projects. So in smaller projects, we cannot afford the high cost, so it won't work for smaller projects. So this is all about spiral model, guys. So in case if you have any questions or anything, please comment it, and please like and share this video, and please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about the comparison between waterfall model and spiral model. So already we have discussed about waterfall model and spiral model. So if you haven't watched those videos, then please go to description box of this video, and I have provided the link in the description box, and you can watch those videos and then come back to this video so that you can understand the comparison between waterfall model and spiral model. So let's talk about, I'll take you to my PPT, and where we'll discuss like what are the different factors about, we'll see the comparison between waterfall model and spiral model on different factors. So let's get started. So guys, let's do a comparison between waterfall model and spiral model, and we'll see some differences as well. So I'll create 3 columns over here. One is for properties, like on what basis we'll do the comparison. So this is property, on basis of what we'll see the differences, and we'll do the comparison. This is waterfall model, waterfall, and this is spiral model, spiral column, spiral model column. So let's see the first point, definition. So what is the definition of waterfall model? It is linear sequential model, linear sequential model, or base model, or traditional model, or traditional model. And what is spiral model? This is risk driven model. You can make a note of this, guys. I could not create PPT on this like with the notes. That's why I'm writing some of the differences over here. So you can make a note. However, don't worry, I'll put it the complete notes in my blog later on. So the second is flow of the process. What is the flow of the process? So waterfall, what happens is after completing a phase and reach to the new phase, it is not possible to go back to the previous phase. Suppose this is phase 1 and this is phase 2, 1 and 2. So once we reach to phase 2 from requirement analysis, let's say this is requirement analysis and this is design. So once we reach to second phase, we cannot come back from the second phase to first phase. And here it operates on the basis of iteration. It operates on the basis of iterations, as we have seen in iterative model or spiral model. We have seen like how it iterates. So we have different modules in spiral model, and we'll follow the same process again and again. So that is nothing but the iteration. Now the third point. What is the third property? Customer involvement. Customer involvement. So here in waterfall model, it's very minimum because our steps and everything are fixed in waterfall model. Here customer involvement are more because the customer has an awareness of what the product is. So customer involvement in spiral model is more. What would be the fourth point? Fourth point is the usage. So this is for small projects, and this is for large and complex projects or big size projects. Flexibility. Fifth point is flexibility. So this is, it is not flexible. Okay, this is not, it is not flexible. And whereas in spiral model is flexible because it works on the basis of iteration, so we can change the requirement anytime, or it is more flexible. We have different phases in spiral model and iteration as well, as I've discussed earlier. So this is about flexibility. Changes in the requirement. One of the property. So here changes is not possible. Here changes are possible. Here changes are possible. Seventh one is cost of the module, like how much expensive waterfall model or spiral model. So this is less expensive compared to spiral model, and this is very expensive because here manpower requires a lot, and team strength are needed, like more team members required here. And because we have a separate things like risk analysis, so for that we need expertise to analyze the risk. So this is the seventh point. And the last one is risk involvement in waterfall or spiral model. That is eighth point, risk. Waterfall model is high risk. High risk are involved in waterfall model. Here less risk in spiral model. Why high risk in waterfall model? Because we have certain phases, and there is it's in linear sequential phase, and once a phase is done, we cannot come back or change the requirements, or we cannot come back to the current phase once it is done. So risk involvement is high because the requirement may, if customer is change the requirement or anything happens in the future, so it's very risky model, I would say. Whereas spiral model, because we used to take the feedback and reviews from the customer, and it works on the basis of iterations. We divide the requirements, we prioritize into different modules, so risk is very less over here. And we do the risk analysis. The model itself called as risk driven model. So these are the different properties we can differentiate waterfall model and spiral model, guys. So I'll put this notes clearly because this is not visible, I guess. So I'll put in my blog, that is automationtestinginsider.com. Don't worry about that. I'll put it in my blog in coming days. So thank you guys for watching. This is all for today. Thanks a lot. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by verification and validation and what is the difference between these two. So before I start V model or V and V model, it's very important, very important to understand like what do you mean by verification and validation and what is the difference between them. So let's talk about like what do you mean by verification and validation today and difference between them, and then probably next video I'll talk about V model so that you can understand better. So before I take you to my PPT where we'll understand the proper definition and difference between these two, let me give you an example so that you can understand, you can relate better, like what do you mean by verification and validation. So suppose you are buying any product from any e-commerce website. Take an example, Amazon. So what you're gonna do first thing is either you open the browser or open the app, and you'll select your product based on your need. Like suppose you want to buy a T-shirt. So based on your size, the brand which you want to from which you want to buy, you select that brand, and then color you choose as per your choice, and then you do add to cart. Now you added the product in the cart, and from there, before making the payment, what you're gonna do is you'll verify all those things, like whether I have selected the proper size or not, the color which I have selected earlier, it's fine or not, and then address where it will be delivered, the where address is proper or not, and the price also. If you have any kind of coupon code or something, you apply that also and verify the price at the end, like how much charge it is going to cost you, right? I mean, how much is the cost of the product with the delivery charge and everything. And another thing is you'll see the return policy as well. So these are the different things you verify before making the payment. So these are the things is nothing but a verification, because you did not get the product yet, but you verifying all these things by just seeing the product. So this is nothing but the verification. Now once it is delivered to your address, what you're gonna do is you will test that, right? And by wearing that product, let's say T-shirt, so you'll verify like how is the size, how is the color looks like, and everything. So if it is not suitable for you, then you'll return it, because earlier you have verified the return policy and all. So after getting the product, you'll do the actual testing of the product. So that is nothing but the validation. So this is the difference between verification and validation. So same thing happens in case of verification and validation in testing. So I'll take you to my PPT where we'll understand like what do you mean by verification, the proper definition of verification and validation, and difference between them. So let's get started. So guys, let's talk more about verification and validation. And at the beginning of this video, I have given a very good example of verification and validation. So before getting the product, whatever you do, the investigation is nothing but the verification. And once you get the product, whatever you do the investigation is nothing but the validation. So same thing happens in software testing as well, software testing, verification and validation. So before I start the V model, it's very important to understand verification and validation. So in coming days, I'll talk about V model. So let's focus on verification and validation as of now. So here I have listed down the difference, the definition of verification and validation and difference between them. So verification is the process of checking the document like BRD, SRS, CRS, customer requirement specification, design, code, and programs. And validation is testing and validation of actual product. So if you see like V model, we have one side, this is nothing but the verification part, and this is validation part. So I don't want to talk more about the V model as of now, but this part, the left side part, is called the verification and the right side is validation. Here is the left side is also called SDLC. It is the part of software development lifecycle process, and this is part of SDLC, testing lifecycle. So here in SDLC, like we have requirement gathering, the design, coding, all these phases comes under SDLC. So verification is the process of checking the documents, different requirement documents, design, coding, and programs is nothing but the verification. And actual testing, once we get the product, testing and validation of actual product is called validation. Now the proper definition, like are we building the product right? That is the proper definition of verification. And in another words, software meets the specification or not. Here we talk more about the specification of the product. Here we are checking whether we are developing right product or not. And if you talk about validation, are we building the right product or not? Software meets the requirements. Here we talk more about requirement or not. We check whether the developed module is right or not. So this is the difference, like in terms of definition. And the second thing is, third point is static testing. This is comes under static testing, and this is dynamic testing. So in the next slide I'll talk more about like what are the different methods of static testing and dynamic testing. So these are the different methods, guys: inspection, reviews, and walkthroughs. So these are the part of static testing. Basically here we review the document, walk through, we go through documents, inspection. All these comes under static testing. And here in validation we have unit, integration, system, acceptance, all levels of testing. These are 4 levels of testing, probably we'll discuss later on in detail. But just for your understanding, like in validation we follow all the levels of testing as well as all functional and non-functional testing in validation part. And here QA comes under verification, QC comes under validation. So here you can see in V model we have this part as quality assurance and this part as quality control. So in the next video I'll talk about what do you mean by quality assurance and what do you mean by quality control. So left side is called quality assurance, right side is quality control. And QA involved here, like quality assurance analyst involved in verification part. So probably you have heard the CMMI process. So there are different CMMI process areas are there. So based on the company's level, like level 3, level 4, level 2, whatever, level 5. So we have certain process areas. So that is a different chapter, guys. Probably we'll discuss later on only. So based on the level of CMMI, they follow the QA used to follow the process areas. We have different process areas, and they'll prepare the documents. They'll track the projects progress and all. Metrics will be there. So a lot of factors are there in QA, in QA's responsibilities. And here tester involved with the help of QA. So here the actual testing process is done in validation. So of course testers are involved with the help of quality analyst. Seventh point is it comes first before validation. So verification comes before validation. So it comes later. And it finds the bug early in the development life cycle. And it finds the bugs that verification cannot catch. So when we start the development process, so whenever if you get any bug related to if requirement is not mismatching, I mean requirement is ambiguous, or it is not matching as per the customer needs, so we can raise the defects, bugs early in the development life cycle. Whereas in once we get the product, we do the actual testing, and there mostly like functional and non-functional related defects will get. So this is the difference between verification and validation. So thank you guys for watching. Please like this video, share it, and comment if you have any questions, and subscribe to this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about like what do you mean by quality assurance and what do you mean by quality control, and what is the difference between them. So I'll take you directly to my PPT where we'll discuss what is the difference between, what do you mean by quality assurance, quality control, and what is the difference between them. So let's get it started. So guys, let's talk about quality assurance QA and quality control QC. But before I start quality assurance and quality control, let's talk about like what do you mean by quality. So in simple terms, quality means if any product is fit for our use or fit for our purpose is called quality. So it's all about meeting needs, expectations with respect to functionality, design, reliability, and price. It's called a quality product. And what do you mean by assurance? So assurance is nothing but kind of positive declaration of a product or service which gives us confidence. So that guarantees that gives the guarantee that this product work without any problem. That is nothing but the assurance. So in software terms, how do you define quality assurance? So it is a procedure to ensure that the quality of software product or products or services provided to the customer is called the quality assurance. And quality mainly focuses on improving software development lifecycle. In the last video, we have seen one side of the V model is called the verification and the other side is validation. Similarly, this part is called quality assurance and this is quality control. So here we have software development life cycle. Here we have testing life cycle, software testing life cycle. So QA mainly focuses on improving software development life cycle. And nowadays this QA becomes SQA as well, software quality assurance. Now, what are the different stages of quality assurance to make sure that quality assurance take is on place in any company? So there are four steps, like we have plan, do, check, and act. Plan, do, check, act. So when planning, what we do, we should plan the process related objectives, process related activities. We should plan process to make sure all the process is on place. Do is nothing but do changes to the existing process or the development of the new process is called the do. Check, what we do, monitoring the process. It is monitoring the process, monitoring the process. And act, take actions to improve the process. So this is act is nothing but the improvement. Do is kind of changes to the existing process or development of the new process. So these are the four stages involved in quality assurance, guys. And there are some certifications in quality assurance. Probably you might have heard about CM level, CM I level, and we have ISO 9000. So these are the quality standards certifications which company used to do. When we call like if any company is like same level 3 or 4, right? So company has to follow certain process areas. If it is same level 3, then there are certain process areas which company has to follow. So who will handle this quality assurance process? So company used to hire quality analyst who will take care of all the quality assurance related activities, all the process areas. They will make sure that every documents, everything is on place. And they used to prepare the templates as well. We cannot use any template without any without certification we cannot use any templates. That has to be as per the process. Take an example, suppose we want to use any uh, test case summary document or test case authoring document, test cases document or test plan. All should be certified by QA, and the proper template should be there. And in sim level, if you have, probably you might have already aware, we have 5 stages like initial, repeatable, defined, managed, and optimizing. So those are the 5 different stages of sim level. Now let's talk about quality control. So the other side of the V model. V model we'll discuss later on. So just to explain you guys, like what do you mean by QA and QC, that's why I took the help of this V diagram. Now let's talk about QC. What do you mean by QC? So QC is nothing but it's a software engineering process to ensure quality in a product or service. So basically it examines the end product once product is developed. So this is like quality assurance is part of when product is going under development phase, and quality control comes under once product is done, the testing part. It's nothing but quality assurance, and this is handled by tester. This is handled by the software tester with the help of quality analyst, with the help of you guys. So this is brief about quality assurance and quality control. Now in the next slide, let's talk about the difference, the more difference between them. A couple of difference I can talk about it, like this is process oriented quality assurance, and quality control is product focused. It is mainly focused on the product, and this is mainly focused on process. And this is preventive technique. Quality assurance is preventive technique. Preventive technique. And quality control is corrective. Corrective. What do you mean by that? So preventive is it prevents the defect, and it corrects the defect. So in the next slide, let's talk about more about the difference between quality assurance and quality control. So QA is the process of managing the quality, managing for the quality. So that is quality which we have discussed. Quality control is used to verify the quality of the product. Quality of the product. QA aims to prevent the defect. This is what we have discussed. And QC aims to identify and fix the defects. So in testing, what we do, we raise the defects and get it fixed from development team. So QC aims to identify and fix the defect. It is method to manage the quality verification. It is method to verify the quality validation, which I have spoken about in the last video. One part of V model, one side of the V model is called verification, and other part is validation. So the left side is called verification and right side is validation. So here this is quality assurance and this is quality control. It is preventive technique. It prevents the defect. It is corrective technique. It is process to create the deliverables. It is process to create the deliverables means QA guys will help us to prepare all the templates which I have discussed earlier, like test case summary template, test case document, test case template, test plan, defect report, defect summary report. All these documents are prepared by QA guys. So it prepares the deliverables. It is the process to create the deliverables. It is the process to verify the deliverables. So we used to prepare all these documents and we'll verify, right, whether it is working correctly or not. I mean, when we write the test cases, so we verify all those deliverables. And QA is part of SDLC. Mainly, it's part of software development lifecycle, and QC under software testing lifecycle. Involvement of whole team, and here testing team. Generally, QA also involved here, like quality assurance people, quality analyst, perform before QC and it performs after QA. So this part anyway, this is software development lifecycle SDLC. So this will happen first and this is afterwards. Once product is ready, then software testing lifecycle. So yeah, this is all about QA and QC guys. And there is another term called quality engineering, QE. Probably we'll discuss more about quality engineering later on. So in case if you have any questions, then please let me know. So thank you guys for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider.com. And today I'm going to talk about V model, or you can say V and V model, or verification and validation model. So guys, already I have spoken about verification and validation and quality assurance and quality control. So if you haven't watched those videos, I would recommend first go through those videos and come back to this video. However, I have provided the link in the description box of this video. I have provided the complete playlist of manual testing as well as software development models. So you can watch, you can check out them and watch them, and then please come back to this video. So let's talk about V model today. So why it is called V model? So here all the phases which are involved in V model are executed executed in a V-shaped manner. So that's why it is called V model, and it is an extension of waterfall model, where each phase of testing is associated with development phase. So I'll take you to my system guys, where we'll discuss more about V model, what are the different advantages of V model and disadvantages. So let's get started. So guys, let's talk more about V model. So the V model is type of software development lifecycle model where process executes in sequential manner in V shape. It is also known as verification and validation model, which we have discussed earlier. So sequential manner in V shape means like this. So that's why it is called V model. The V model is an extension of waterfall model and is based on association of testing phase for each corresponding development phase. So this part of V left side is called software development lifecycle, and this is software testing lifecycle. This belongs to the development team, and this belongs to testing team. And what is the next? This is highly disciplined model, and next phase starts only after completion of the previous phase. So it is like waterfall model guys, so we cannot jump to the next phase unless this phase is completed, but corresponding we have testing phase. So you can understand the next slide better, where I'll talk more about V model, the pictorial representation of V model. And this part of V is also called quality assurance, and this is quality control, this is verification, and this is validation. The left side part is called verification and right side is validation, which already we have talked about in the last video, previous videos. So let's talk more about V model guys. So let me just draw a diagram in V shape like this. Now what is the first thing? We get the requirement from the customer in the form of CRS, customer requirement specification. So this is dev team and this is testing team. Now we got the requirement from the customer with the help of BA. BA will work with customer, business analyst will work with customer to get the requirement and got the requirement. Now BA will convert that requirement into BRD document, business requirement document, and with the help of manager it will be given to development team and testing team. Now what tester will do here? They will do three things. They will go through BRD and they will create acceptance test plan, and they will create acceptance test cases, and while going through all these phases, like going through the BRD, creating the acceptance test plan, or creating the acceptance test cases, if they find any ambiguity in the requirement, or if they need clarification, so they can contact with the dev team with the help of business analyst. Yeah, they can contact with the business analyst project manager to get the clarification of the BRD, business requirement document. Basically they will compare, they will get the CRS also, customer requirement specification, and they will compare with BRD here, testing team. And this level of testing is called acceptance test. So do not worry about different levels of testing, guys. I'll talk about more in coming videos. So this level is acceptance test. Now what is the next phase? BRD will be converted to SRS with the help of architect. The BA will convert that into, with the help of project manager and architect of the project, will convert that into SRS, software requirement specification, and it will be given to both development team and testing team, because development needs to understand the software requirement specification, and that at the same time it will be given to testing team as well. So what is the next for testing team? So they will compare both like SRS document with respect to BRD, and they will go through SRS document, software requirement specification. They will create system test plan and system test cases. I'll talk more about like how do you create the test plan, guys, test plan and test cases in coming videos. Do not worry about that. So just understand, like they will go through the software requirement specification with respect to BRD. They will compare. In case if they find anything, they can revert it back to the development team, and the tester at the same time will create the test plan, system test plan and system test cases. And this level of testing is called system test. Now what is next? So here HLD, who will create high level design. So HLD will be created over here with the help of architect, who creates the framework or create the high level design document. SRS will be converted to high level design document, and it will be given to both development team as well as testing team. Now here tester will compare high level design document with SRS, So already I have spoken about high level design, what is high level design, low level design, software requirement specification, BRD, in previous videos, guys. You can refer those videos. Now here tester will go through high level design, and they will create integration test plan over here, integration test plan and integration test cases. Integration test cases, and this level of testing is called integration test. Now what is next? Now HLD will be HLD will be converted to low level design. HLD will be converted to low level design, that is LLD, and it will be given to testing team as well. Testing team will compare low level design versus high level design. Like high level design is converted properly to low level design or not. If they find any discrepancy or any mismatch things, then they can revert it back to development team. Now here tester will this is functional test. Here it will come functional test. Now here what tester will do, they will create the functional test plan, functional test plan and functional test cases. And anyway, they will go through the low level design document here, and they will create functional test cases and functional test plan, and they will create functional test cases. Now what is next? Now developer will do the coding over here, coding with the help of low level design document. And now this will be given to the testing team as well. I mean, they will release the software to the testing team. Before releasing, they will do here white box testing, and or else you can say unit level testing, unit test. So this white box testing or unit level testing is will be done with the help of either developer or white box tester. Now we got the software, guys. Here we got the software. Now that will be given to the I mean, it is given to the testing team. Now what tester will do, because once unit testing is done by the development team or white box tester, now the software is ready. Now I will execute our functional test cases because it is already ready over here. After completing the functional test cases, we will we will go for integration test of all the modules. So in case in this process, if you get any defects or anything, then we can raise it in our defect tracking tool and we can get it rectified from development team. Now after integration test, we'll execute system test, and at last we'll execute the acceptance test. So this is the complete flow of V model, guys. So one second. Yeah, so this is the complete flow of V model, guys. So let's talk about the next point in the slide. So when to use V model? So the project is short. Requirements are well defined, clearly documented, and fixed. Product definition is stable, and there are no ambiguous or undefined requirements. So this is like V model. When we go for V model, waterfall model, when we have when the project is short. So this is also useful for short-term projects. And what is next? When to use is done. What are the different advantages of V model? So start testing from beginning of the project. So you can see we have seen in that slide when I have drawn the diagram of V model. So each testing starts from the beginning of the first phase, from the beginning of the project. So that is an advantage of V model. Testing include both validation and verification. Defect found at early stage cost, so that cost of fixing defect is very less. So because each phase we are verifying the documents, different documents. So that's why cost of fixing the defect is very less, because we'll get very less defects when we do the actual testing in V model. As testing is more involved from beginning, better understanding of the requirement. So these are the different advantages. What are the disadvantages? Not a good model for complex and object-oriented project. So if it is big project, guys, it will be, the process is very complex, right? So this process itself is complex, so it is not useful for big project or complex project. Poor model for long and ongoing projects. Not suitable for the projects where requirements are at moderate to high risk of changing. If requirements are changing frequently, so this model is of no use. I mean, it's very hard to go for V model. Once an application is in the testing stage, it is difficult to go back and change a functionality. So because we have already gone through all the phases of development lifecycle, and once it is delivered to the testing team, after the unit testing, we have seen integration unit testing over here, and then it is very difficult to go back and change that functionality because we have already gone through lots of stages, and more documents are required. More documentation are very high here. Documentation, we have to create lots of documentation, process documents. We have to go through all the process documents. So these are the different disadvantages of the model. No working software is produced until late during the life cycle. So in this phase, the software is not yet developed. It is developed after certain stages only. So these are the drawbacks of V model, guys. So thank you for watching, guys, and please like and share this video and comment if you have any questions, and please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Thank you. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important software development model, that is Agile model. You can call it as Agile development process model, Agile process, or Agile methodology. And this is a very important software development model which is widely used and frequently used by different software development companies. And this is you should aware of what is the agile process. Every QA must know about this process, and this model is mainly focused on the delivery of the software, the frequent delivery of the software to the customer, irrespective of the documentation. So we mainly focus on the delivery of the software to the customer. Now in agile model, like we have seen in different software development models earlier, like waterfall model, spiral model, V model, there were some drawbacks. So all those drawbacks are overcome by this software development model, which is agile model. Now there are different terms we have been using in agile process, and there are different meetings as well. So I'll take you to my system where we'll discuss more about like what is the complete process of agile development process model. So let's get started. So guys, let's talk more about agile development model, or you can call it as agile methodology or agile process model. Now there are a couple of things which is very much important in agile, like continuous delivery of the software to the customer, and the second thing is handle the requirement change. So these are the two important concept of agile development model. So unlike in previous models, we have seen uh, we mainly focus, I mean, we have done so much on documentation part, and they are not capable enough to handle the requirement change. But here in agile development model, we mainly focus on continuous delivery of the software to the customer and handle the requirement change, handle the frequent requirement change in the software. So these are two important points about the agile development model. Now there is a certain process to follow the agile development model. There are certain stages. Now take an example, we got the project from one customer and duration of that project is 1 year. Now we divide, customer wants the software in every 2 weeks. So we'll divide the software, we'll divide the complete requirements into different modules. So like this. So take an example, this is X, this is Y requirement, this is Z. So we have divided the different requirements into different modules. So each module, they want the software in every 2 weeks. So that 2 weeks duration is nothing but our sprint cycle. So sprint cycle is of 2 weeks. So every 2 weeks we'll release the software to the customer. Now in that 2 week we have to follow the complete agile process. So what are the different steps we have in agile process model? So in agile development we have planning of the sprint, we have design. So design, we have seen like high level design, low level design we have discussed earlier, and then we have development, develop, and we have testing the software, and release, and last feedback. So this is the complete process of agile development model, guys. So we have planning of the particular sprint, and then design, we'll do the design, and development of or coding, you can say coding, and testing of the software, release the software, and get the feedback from the customer. Now, so this agile development model is also called iterative. I mean, it is the combination of iterative development plus incremental. Why it is iterative? Because what do you mean by iterative? So we have seen in iterative development model, when we keep doing the same thing again and again is called iterative. So this is my module 1 or sprint 1. So we have followed plan, design, develop, test, release, and feedback. So similarly we'll do for, so this is sprint 1. Now we'll follow the same for sprint 2 as well, sprint 2 cycle or module 2. So that's why it is iterative development model plus incremental. Why it is incremental? So we have divided our task into different modules. So we have divided our task into different module. So this is module 1. We made some changes on module 1. I mean, we have developed some requirements on module 1, and we'll add in module 2. So we'll keep adding our requirements till we get the final product. So this is kind of incremental, module 1 plus module 2, module 3, like that. So that's why it is incremental model as well. So it is iterative plus incremental. Now there are few terms, guys, and different meetings are there in agile development model. So let's talk about them in detail. What are those different terms we have? So sprint we have discussed. Sprint. So it is nothing but the modules. We have divided the task into different modules, and each module is of 2 weeks. So that is nothing but the sprint. We'll plan, design, develop, test, release, and get the feedback. So this is sprint. Now we have Scrum. What do you mean by Scrum? Basically, in agile process we have to follow the agile process we need to follow certain framework. So Scrum is nothing but a framework that helps the team work together, or it is a work culture to follow the agile development model. So that is Scrum. Now in Scrum we have Scrum Master. Before that, owner product owner. So who is the product owner? So it could be the head from the marketing team who deals with the customer, or it could be from top management uh, individual as well. So who handles the requirements from the customer, who talks about the product with the customer, is called the product owner. Now we have Scrum Master. Scrum Master. So what do you mean by Scrum Master? So it can be project manager, or project manager can be Scrum Master. But the difference is manager handles different projects at the same time, and Scrum Master is particularly for this particular project, or this particular Scrum. So that is Scrum Master. Now we have user stories. What do you mean by user stories? User story. So user story is nothing but the requirement which we got from the customer. Like we have divided them into different sub requirements. We got some requirements from the customer, and we have divided them into different features: X feature, Y feature, Z feature. So one user I mean, one user story could be a combination of two features, or uh, one feature, or it could be one plus two feature. If it is like a small feature, then it may have only one feature. If it is like sorry, if it is big feature, then it may have only one feature. And if it is kind of small requirements, if you have small requirements, multiple requirements, then it could be uh, multiple features. So that is nothing but the user story. Now what next? We have product backlog. Product backlog. So what do you mean by product backlog? So product backlog is nothing but the combination of different user stories we keep in the product backlog. From there we'll pick and plan for the particular sprint to develop that requirement. So that is product backlog. You can say the requirements are split into user stories for any particular sprint, and user stories are picked from the product backlog. Now what is next? We have epic. Epic, what do you mean by epic? So epic is kind of again the same thing, but it has large number of requirements in epic. So we have large number of requirements in epic, and this product backlog is for particular sprint. We keep all the user stories there and we pick it from here. But whereas the epic contains different requirements, so we contain, it is also a combination of different user stories, but maybe for different sprints, like sprint 1 2, it contains all those requirements in epic. Another point is story point. Another term is story point. So what do you mean by story point? So it defines the complexity of the user story. So it defines the complexity of the user story with respect to dev and testing team, like how complex the particular user story. And the next thing is swag. Another term is called swag. So basically in swag what happens is it is way to compare the size, time and effort. Size, time and effort to develop any particular user story. Size, time and effort. Now we conduct different meetings, guys. So one of the meeting is sprint planning meeting. Sprint planning meeting. So what do you mean by sprint planning meeting? So Scrum Master conducted this meeting before the start of the sprint to discuss about the user story that can be covered in particular sprint, and the timeline of the same would be discussed in this. The timeline for the same would be planned in this sprint planning meeting. Now another term is burn down. Probably you might have heard that, burn down. You are burn down. So what do you mean by burn down? So it is the let's say that it is the graph between time and work, which shows that how much work is remaining for the project. It is shows that how much work is remaining for the project between time and work. This is burn down. And another term we have burn up. Burn up and burn down chart. Probably you might have heard that. So how much work is done, how much work has been completed is called the burn up, and whatever how much work is remaining is called burn down. Now we used to have daily stand-up meeting as well. Daily stand-up meeting or scrum meeting. This is also called scrum meeting. So what happens here is every day we need to have this daily stand-up meeting where we'll discuss like how much work has been done yesterday, what the work we have done yesterday, what we are doing today, and what we're going to plan for tomorrow. So these are all things discussed in this Scrum meeting. So sometimes product owner is also joining this meeting, but Scrum Master conducting this meeting to discuss about the progress about the project. And we have what else we have? We have sprint review meeting, guys. One more meeting. We have sprint review meeting. So this sprint review meeting is conducted at the end of the once sprint is completed. We conduct this sprint review meeting, so where we'll discuss about how how it was the previous meeting. So this is optional meeting actually, sprint review meeting. So at the end of the sprint it is conducted, but there is one important meeting, that is sprint retrospective meeting. Sprint retrospective meeting. So what happens in this sprint retrospective? So at the end of the sprint, or when we have started the new sprint, we conduct this sprint retrospective meeting, where we'll discuss like what went wrong in the previous sprint, what went good, what went well. So all these things discussed in this sprint retrospective meeting. And at last we have defect triage meeting. Defect triage, I can write here, defect triage meeting. So what do you mean by that defect triage meeting? So here, let's say we have 2 weeks of sprint cycle, 2 weeks, right? So at the end of the first week, we'll conduct this defect triage meeting. So in this particular meeting, the dev team, testing team, probably product owner is also joined this meeting, and we have a scrum master. So here we'll discuss about the progress, like how many defects are open state, and whatever defects we have closed. But basically we'll discuss about how many defects are in open state, and we'll prioritize them to fix them as soon as possible. And in case if any defect is not important, then we can defer it to the next sprint if it is not important. So do not worry about the defect related things, guys, like what do you mean by defer the defect, or how to prioritize, how to give the severity to the defect. We'll discuss in defect life cycle later on. So these are all different terms we use in agile development model, and different meetings we conduct in agile development process model. So in the next slide, I'll revise like whatever we have discussed so far, guys. Most of the points I have covered in this particular slide, but I have already mentioned in the notes, in the form of notes. So we'll discuss in next slide. So let's get started. So agile methods breaks. What do you mean by agile development model? Okay, so agile methods break the task into smaller iterations. We have seen that parts to directly involve long-term planning. We have seen one complete 1-year project. The project scope and requirements are laid down at the beginning of the development process. So we have divided into different modules or sprints to develop them. All the team members should work together to deliver a quality product. So this is the main focus of agile development model. Management is also involved continuously in this project. So we have product owner, scrum master, dev team, and testing team, and along with management also involves, higher management also involves in the agile development process model to follow the process, to follow the complete project. It is one of the most widely used process in software development world, as it helps team to deliver the work faster in small increments with less issues. So this is the main agenda of agile development model. Now we'll just recap what we have done in agile process. So customer satisfaction by rapid continuous delivery of useful software here in agile process. So we can monitor the project progress every day. Every release is implemented in iterations or sprints. So this is what we have discussed. Every iterations or sprint consists of 2 or 3 weeks in general. So it depends on project to project, company to company. Like it could be, I mean, it mainly for 2 or 3 weeks. In some companies, they used to follow in 1 week sprint cycle as well. However, the sprint duration varies from project to project and also sprint to sprint as well sometimes. Many meetings were involved in this agile process to know the progress of the release in each sprint. Now these are the different terms, guys, which we have already talked about, like product backlog. User stories requirements are split into user stories will be added here in product backlog. For any particular sprint, user stories will be picked from product backlog and worked upon. Epic, it is the complete feature or requirement which needs to be implemented, that we have discussed. User story, and epic is split into user stories based on the complexity of work involved in order to develop it. User story is generally part of epic. So we have seen in epic we contains all the different user stories. In case of a small feature, it will be a single user story. Story points also we have discussed. So it is measurement to define the complexity of the user story from dev and QA perspective. So basically, what do you mean by story points? So it defines the complexity of the user story, how complex is for development of that particular user story, and how complex it is for testing purpose. So this activity will be done in sprint planning. Burn down chart. So we have seen burn down and burn up. So this is pictorial representation of time and work. Pictorial representation of time and work. Time and work. Team needs to burn the hours on daily basis for the work accomplished against the task. Agile, different agile meetings also we have discussed. So sprint planning meeting at the beginning of the sprint cycle, we used to conduct the sprint planning meeting conducted before the start of the sprint to discuss the user story that can be covered in the particular sprint, and the timelines for the same would be planned. Daily stand up or scrum meeting, it is conducted to know the work done by each in the team. Mainly the below things are discussed. So what work we have done yesterday, what work is planned for today, what work is planned for tomorrow, and any impediments to work, to complete the work. Impediments means any obstacles or any problems we are facing to complete the work will be discussed in this particular daily stand-up meeting. And we have a sprint review meeting is conducted at the end of the sprint to discuss the progress and where does the team stand for the sprint. However, this is optional meeting, as I have discussed earlier, which is conducted based on the project companies as required. Sprint retrospective meeting. So this is an important point, or important meeting is conducted once the sprint is completed and next sprint got started. Following things will be discussed, like what went well in the last sprint, what didn't well in the last sprint, and what can be done to improve uh, or perform well in the ongoing sprint. So these are the points which we discuss in retrospective meeting. Defect triage meeting. So this is an important meeting, is conducted to review and have a proper action on the defects, which I talked about. Dev team, testing team, and sometimes product owner also will be involved in this meeting. Defects identified in the particular sprint will be triaged and assigned to respective team or defer sometimes depending on the defects. So sometimes any defect is not important to fix, so we'll defer it for the next sprint. So what are the different advantages of agile process, guys? So customer satisfaction by rapid continuous delivery of useful software, and working software is delivered frequently. So this is an important point about the agile development model. And quickly release are expected if any large requirement are split so that development and testing is completed in the week schedule. And customer, developers, and tester constantly interact with each other. So these are some advantages of agile development model. Now, yeah, daily cooperation between business people and developers. So these are some advantages of uh, so that when we have such advantages, then we can deliver the software very frequently to the customer. Now let's talk about some of the disadvantages of agile model. So sometimes in agile methodology the requirements is not very clear. Okay, hence it is difficult to predict the expected result. So it happens sometime when we don't have the clear requirement from the customer. In few of the projects at the starting of the software development lifecycle, it's difficult to estimate the actual effort required. So since there is an ambiguity in the requirement, so it is very tough to estimate like how much time it will take to develop for testing. All those things we cannot estimate properly because of the ever evolving feature. There is always a risk of everlasting project. So if requirements keep changing, if you are not capable enough to handle those requirements, so then in that case it will be very difficult to handle the project. For complex projects, the resource requirements and effort are difficult to estimate. If it is kind of big project and complex project, and so in that case we are unable to handle the things properly. And these are some certifications, guys, about the agile. Like we have certified scrum professional, certified scrum master, okay, agile certified coach, we have agile certified practitioner, and safe for agilist. So these are different certifications we have. If you want, we can discuss more about I'll create a separate video on this, like different agile certifications. So this is all about agile process, guys. So I'll keep the notes in my blog later on. So please, if you like this video, please like it, share it, and comment if you have any questions. And please subscribe this channel if you haven't done so far, and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about Scale Agile Framework or Safe Agile. So this is agile process or agile framework which we follow at enterprise level or company level. So I'll take you to my system directly, guys, where we'll discuss more about Safe Agile. So let's get started. So guys, let's talk more about Scale Agile Framework. So you can call it as SAFe. And let me just give an introduction of Scale Agile Framework. So in the earlier video, in the previous video, we talked about agile process and Scrum. We talked about agile. So what do you mean by agile? So let me just recap like what we have discussed in agile and Scrum. So agile is a mindset or the way of working the things, or you can say couple of things which we have discussed, like mainly it focused on the delivery of the software to the customer, and the second thing is the capability of handling the requirement change. So these are the two important things in agile principle or agile model. And what do you mean by Scrum then? So Scrum is a framework based on agile principles. So these are the two things which we talked about. Now if you talk about Safe, so it is an extension of Scrum. It is an extension, or it implements Scrum 8 enterprise level, or you can say company level. So since Scrum is framework, so Safe is also a framework, Scale Agile framework, which implements the Scrum at organization level. Another definition could be like Agile handles the small projects within the organization, and if you talk about Safe, it handles the large or complex projects, large complex projects at organization level. So when we talk about organization, so scale agile framework comes into the picture. Now there are three segments, so hope it is clear, guys, the difference between safe scale agile framework and agile or scrum. Now if we talk about scale agile framework, so there are three segments. We have portfolio, and we have another one is program, and the last one is team. So we can divide scale agile framework into three segments: the portfolio level, program level, and team level. So here, who handle this portfolio? So we have portfolio management team. Portfolio management team. So basically, it is like top level, or you can say governing body of the company. They will take care of this portfolio management. Portfolio management. So basically, they understand the current business of the company, and they work with the clients to get the requirements. So large number of requirements, right? At larger scale. The big picture is portfolio, right? At top level. So basically they get the business epics over here. So in the last when we talk about agile, so epic is nothing but the collection of user stories. So the portfolio management group will collect the business epic. So this is the responsibility of portfolio management group. So they will get the requirements, and they will create the business epic over here. They will collect all the requirements from the customer. Now the second level is program. So to implement those business epics into uh, features, we have this program level. So who will take care of this program level, the second level? So here we have release team or release management group. So we have here release management group, who handles the features which needs to be implemented. So we'll get the business epics from the portfolio management group and convert them into features here in program. And this is also called agile release train. This level is also called agile release train. So this is the first level. Now this is the second level. Now the third level is team. So here the engineering team will work to get the to implement all the features into convert features into user stories. So we have seen what do you mean by user story. So it may contain one feature or multiple features based on the requirements, the size of the requirement, uh, the size of the work needs to be done for particular feature. So the engineering team involvement, I mean, it involves dev team and testing team. So actual implementation is done in this by the engineering team. So these are the three levels of agile framework, guys. Scaled agile framework: top level, middle level. This is the top level, and this is middle level, and we have bottom level. If I draw a pictorial representation, so it will be look like let me just draw it. So it will look like, so let's say if we have different releases over here, release 1, release 2, like this, release 3, release 4. Now these releases will be, this is kind of product, and this product. So this is handled by the last team, which is engineering team, and this will be handled by the middle level, or you can say program or release management group, and in a broader way, in the large picture, which will handle by the portfolio management group. Portfolio management group, which is nothing but the top level portfolio. So this is about the different segments in Scale Agile framework. Now we have some core values in Scale Agile framework. Core values. So what are those core values? So the first one is alignment. Alignment. So what do you mean by alignment? So what happens here is we need to understand the current state of the business and planning for the upcoming projects, and understands the sets the goal in this particular alignment, and all the levels should be aligned to this whatever we goal set for the company. So all the levels like top level, middle level, and bottom level, all should be aligned to the core values of the Scale Agile framework. So that is the first point. The second one, we have built in quality. Built in quality. So what do you mean by this built in quality? So basically, in Agile principle, we have seen that deliver the rapid delivery of the software to the customer. Now, along with the delivering the software, we should also maintain the quality as well as some add some business values to the customer. So that is built-in quality. That comes under built-in quality. What is the third point? Transparency. Transparency. So in all the levels should be transparent, guys. So discuss all the what is the business value of the company, and yeah, so all the levels should be transparent enough to discuss about the current business scenarios, and discuss about the upcoming projects within the organization. And fourth point is program execution. So what is the meaning of this program execution? So this is the heart of Scale Agile framework. So here we mainly discuss like how what how to deliver the software to the customer, like the main release, the releasing of the software to the customer. So that comes under this program execution. Like along with the it's not about just releasing the product to the customers. Value we are adding to the uh, what value we are adding to our business. So that is the main idea about this program execution. Now the fifth point is leadership. Leadership. So this is an important point. What happens is it requires some leadership behavior to follow this agile scale agile framework. So leader can change the system. So this is an important part of scale agile framework. So these are the 5 core values of scale agile framework, guys. So we have alignment, we have built-in quality, transparency, program execution, and leadership. So this is about scale agile framework. So in the next slide, I'll talk about we'll just recap like what we have discussed so far. So let me take you to the next slide. So what is scale agile framework? So it is known as SAFe, as we have discussed. This methodology is an agile framework for development teams. The framework is divided into 3 segments. So we have talked about team, program, and portfolio. So this is the top level, this is the second level, and team is the bottom level. Now following are allowed in SAFe to implement agile software and systems in enterprise level. At enterprise level, gives detailed guidance for work at enterprise, designed based on lean and agile principles. So we should follow the agile principles, designed to meet the needs of organization. So these are the 4 things which we uh, discuss in this scale agile framework. So what are the benefits of scale agile framework? So it is lighter in weight and simpler. Also, it can be used to handle large size streams. Few of the key benefits are listed below. increase the productivity. So when we follow this scale agile framework, it increases. When we use this agile scale agile framework, it increases the productivity, helps in increasing the employee engagement and job satisfaction. So this is an important point, guys. So it increases the employee engagement and job satisfaction, because here the involvement of all the levels, like we have top level, middle level, and bottom level. So all teams will be in a synchronized in a particular sync, right? And they will work together to achieve the goals. Decreases the time taken for the time to market. So if you follow simple agile process or normal software development life cycle, so it will be like this. Now if you follow this scale agile framework, so it takes less time to deliver the software to the market or customer. Increases the quality. So it increases the quality as well as some value adds to the business. So this is the benefits of scale agile framework. Now what are the different project management tools, agile project management tools we have? So we have ServiceNow, we have Rally software, Spira plan, we have target progress, the plan view. So these are some of the project management tools, agile project management tools. So this is all about scale agile framework, guys. So this is an introduction. It's there is a huge topic like scale agile framework. If we talk about, this is just an introduction. So please like this video, share it, and comment if you have any questions. And thank you so much for watching this. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is shift left testing in agile methodology. So what do you mean by shift left testing? So shift left testing is nothing but when we do the testing as early as possible in software development lifecycle is called shift left testing. So let me give you an example. So let's say this is the duration of my project. This is the starting of the software development, which is point A, from the requirement analysis, and this is the end point of software development lifecycle, which is the release of the software to the customer. So this is the entire duration of the software. So what happens in shift left testing is we'll try to move the testing as early as possible in the software development lifecycle. So here in this case, this is the point A and this is point B. So we'll move towards point A at the beginning of the software development lifecycle. So this is shift left testing. So I'll take you to my system, guys, where we'll talk about like why we go for shift left testing and what was the problem in earlier software development lifecycle when we didn't perform shift left testing. And I'll also talk about like how to move towards shift left testing and what are the benefits of shift left testing. So let's get started. So guys, let's talk about shift left testing in Agile. So before I proceed with shift left testing, let me just talk about like what happens in earlier, how we do the testing in earlier software development models. So take an example, traditional software development model, how the testing is carried out in earlier software development model. So take an example of waterfall model. So we have different phases in waterfall model, like we have requirement analysis and feasibility study, we have design, then coding, then we have testing, release, and at last we have maintenance. So these are the different phases are involved in traditional software development model like waterfall model. Now here if you see this diagram, testing is carried out just before the release. So testing is just before the release. So release would be delayed in case if we get the some issues, right, just before the release. So in case if we get any issues or defects, so we won't go for release until those defects were fixed. So that is the biggest problem in this approach. Now how it looks like if you draw a chart between testing in this axis. Let's say this is testing and this is software development life cycle. We have requirement analysis here, design, coding, testing, and release. So earlier testing will be like this. We put effort, testing effort, just before the release. Here you can see that this is testing. So what are the different drawbacks when we follow this approach, right? So in case if you get the issues like defects just before the release of the software, that will take time to fix those defects. So these are the points. We get unexpected issues just before the release. Since we are doing the testing at later stage, we may get unexpected issues and will take time to fix those issues. So cost will be increased. Increase in the cost. Cost will be increased, and then delivery time will be more. Delivery time. It takes more delivery time. Correct? Because since we need some time to fix those defects, so definitely the it increase the time to deliver the software to the market or to the customer. So this is the different like this is about the traditional approach when we follow the waterfall model or any other software development model. So these are the different problems we face when you follow this approach. Now what happens, why we go for shift left testing? The question arises here is why we go for shift left testing. So basically, what do you mean by shift left testing? So it is a practice intended to find and prevent defects early in the software development life cycle process. So we do the testing as early as possible. So let me just draw a diagram like we have created the draw the chart earlier. So here we have this testing and this is my software development life cycle. So we do the testing, we put the testing effort as early as possible. So later on we do the less testing. We not later we no need to do a lot of testing effort later stage of software development life cycle, since we have already put so much effort at the beginning of the software development life cycle. And during this phase only we find so many defects and get them fixed from the development team. So this is the biggest advantage of shift left testing. Now question comes here is how to move towards shift left testing. So how to move? Next point is how to move to shift left testing. So we have couple of frameworks, guys. So we have TDD. If you have heard about TDD and BDD. So TDD is nothing but the test driven development and BDD is behavior driven development. So what happens in TDD is we first write the test cases and based on that we implement the software, right? Implement the coding later stage based on our test cases like what. So it is, this framework is driven by the test, that is TDD. So we have started testing from the beginning, like we have written the test cases and later on software is getting developed later stage. So in that case we put the testing at beginning of the software development lifecycle. And BDD is an extension of TDD, which is behavior driven development. So BDD is nothing but where we write our testing steps or scenarios in plain English language, American language, probably you might have heard that. And so this is about TDD and BDD, guys, and already I have covered in my BDD Cucumber framework series. So please go to my playlist and talk. You can learn so much about TDD and BDD. Now if we talk about different things which we do when we talk about like how we move towards shift left testing. So different things include like we create test plan, Test plan and test strategy document very early in the software development lifecycle. Strategy. So test plan is nothing but a document which has a scope, which defines the scope and objective of the test and approach. So it is a document which defines scope, objective, and approach of the testing. And how testing should be done is carried out in test strategy document. So anyway, guys, don't worry about test plan and test strategy. I'll cover them in coming videos. So the first thing is test plan, and we'll create the test strategy document. Now the second is static testing. We do static testing. So this is nothing but the verification. So already I have covered verification. So if you haven't watched the verification part, verification and validation, so please go go to the playlist and watch verification and validation video. So we do a lot of effort on static testing, like we do inspection, walkthrough. So these are some static testing methods. So we do all these things at the beginning of the software development life cycle. Now we create unified test strategy document. So what happens is, here is we'll talk about, we write about unit testing to acceptance testing, all the levels of testing carried out in this test strategy document, like how it should be done. All those things will be carried out in this particular document. Now another thing is risk based analysis. Risk based analysis, so it is carried out to determine likelihood of failure for each test scenarios which we have written earlier. So and this test, because we have already created test plan, test strategy, and test cases, so we can prioritize our test cases, which one we should execute first. So this is about the risk based related analysis. So these are the different things which we follow when we move towards shift left testing. Now what else remaining? Now we need to discuss about what are the benefits when we follow this shift left testing. Testing benefits. So the first thing is, it enhances the customer experience. Enhance customer customer experience. So we regularly get the feedback from the customer, so it enhances the customer experience. And scope for the implementation of test automation as well. So that is and another thing is, before that we find the defects, find defects early in the life cycle. So that is one of the advantage. And the cost will be less cost. And test coverage, it increases the test coverage because we have started the testing from the beginning, so the coverage will be more in this approach. And what else? Delivery speed will be more. Delivery of the software, delivery speed more. And what else? Yeah, automation, scope for automation, scope for automation. Why? Because since we start the testing from the beginning of the software development lifecycle, so it enhances the scope for the automation, because build gets gets stable at that particular point of time when we go for automation. So it enhances the scope for automation. And what else we have? It increases the quality. It increases the quality of the software. Quality of the software. So these are the different benefits when we follow shift left testing, guys. And yeah, one more is less production issues. The end point, less production issues. So I talked about 8 different advantages of shift left testing. So first one is enhance customer experience, find defects early. Second, less cost, test coverage will be more, delivery speed is more, scope for automation, increases the quality, and less production issues. So these are the different advantages of shift left testing. Yeah, so this is all about shift left testing, guys. So this is an important topic I wanted to discuss. So in case if you have any issues, or if you have any questions, then please write me back. Please put in the comment box, and yeah, please like, share this video, and subscribe to this channel, and click the bell icon to get the notification for upcoming videos. So thank you guys for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about prototype model. So what happens in prototype model? So basically, based on customer requirement, we create a prototype, or you can say dummy model, based on their requirement, and we'll test it and present it to the client, and based on their reviews and their feedback, we go for the actual implementation of the software. So this is how it happens in prototype model. Now question arises here is why we when we use this prototype model. So when customer is new, or if they are not sure about their requirements, then we go for this prototype model. Now I'll take you to my system, guys, where we'll discuss more about prototype model. So let's get started. So guys, let's talk about prototype model. Before I talk about what I mean by prototype model and when to use prototype model and what are the advantages and disadvantages of prototype model, so before that, let me talk about the different stages in prototype model. Like normally when we follow any software development model, there are certain stages, correct? So in the same way, what are the different stages in prototype model? So first of all, we get the requirement from the customer, requirement gathering. So this is the first point in first stage in prototype model. We connect to the customer and we get the requirements from the customer. Now the second point is quick design. Quick design. Why do we do quick design? Because we want to build a prototype. So based on requirements, we develop a design, and based on that, we create a prototype. Build prototype. So this is the next step. So what do you mean by prototype, guys? So prototype is where it's kind of dummy prototype or dummy model, which I have discussed earlier, or you can say replica of the actual software. Here all the functionalities will not work, so we'll showcase like this is how your product will look like to the customer. So it's kind of a dummy model. We create a dummy model based with the help of developers, UI developers and business analyst. We'll just create probably in the image format, or maybe half of the functionality will work, not even half, some of the functionalities will work, and we showcase them some images as well. Like this is how your prototype will look like. Now the next step is customer evaluation. Customer evaluation. So based on the customer feedback or customer evaluation, we go for the acceptance. Okay, if customer accept it, then this is called acceptance. acceptance or acceptance by customer, or in case if they want to make some changes on the prototype. Suppose they don't like the ideas which we have given in the form of prototype. So what we will do, will refine based on customer feedback, and then again we'll make the changes in the design, and again we'll build the prototype. And once customer is uh, happy with that, if they are okay with that, they will, then that is customer acceptance by customer. Now next is, we'll follow the same procedure like we do in normal software development model, like design and then coding, and we have testing, and then maintenance at last. Maintenance. So this is the complete procedure or stages in prototype model, guys. And now let's talk about like what are the different types of prototypes. So we have four types of prototypes, prototype model. So just for your knowledge purpose, I'll talk about them in brief, so you can get some idea. So the first point is, the first prototype is rapid throwaway. What happens in rapid throwaway is, we give some ideas to the customer, like based on their requirements, we give them the ideas like this how your actual product will look like. So we'll give so many ideas to the customer, and based on the ideas and their feedback from when we get the feedback from the customer on those ideas, we'll create a prototype, and that will be kind of a quality prototype. So later on we won't spend too much effort to modify on that particular prototype. So this is rapid throwaway. So rapidly we get the customer reviews and feedback, and based on that we create a quality prototype. So that is rapid throwaway. Second is evolutionary 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 prototype. So what happens in this evolutionary prototype? So here we create a prototype initially, and we keep based on the reviews or based on the feedback from the customer, we keep adding on our changes in that particular prototype, and later on we go for the final design. Like we have seen the typical workflow, or you can say the stages, like here we have seen. So it is like evolutionary prototype. So based on continuous feedback from the customer, we create our prototype, and then we go for the final design. So this is evolutionary prototype. What is third one? So third one is incremental prototype. So this is the third prototype. So here what happens is, we get the requirements from the customer. Now based on the requirements, we create we divide the task into different smaller modules, and we create separate prototype for each of the modules or tasks. Okay, so like we have p1, p2, p3. So these are the different prototypes we create, and we'll test at our end and get the feedback from the customer. And later on, based on the feedback and the changes we make on the particular the prototype, like let's say p1, we get it tested from our end and got the review from the customer, and then we made the changes as well based on their feedback, and later on we'll keep adding those prototypes in incremental manner. Incremental means like in this flow only, because this p1 has certain requirements, it should be built first, and then p1, and then p2, p3, p4, and then we'll combine all the prototypes and we create the final build, final software over here. So this is about the incremental, and the last one is we have extreme prototype. So what happens in extreme prototype is this is basically used for UI development, like for which has a lot of interactions in the UI. So firstly what we do is first we create static pages. We create the prototype for static pages and then for functionality we'll create another prototype. So incrementally again we do in this way, and we build the final product. So based on customer reviews we make the changes on our UI development, whatever prototype we have developed. So based on the based on the customer feedback we make the changes, and then we go for the final build or final product. So basically this extreme prototype is useful for UI development, as I have discussed earlier. So these are the four types, guys. We have rapid throwaway, the first one prototype, evolutionary prototype, incremental prototype, and extreme prototype. Now from the next slide, let me just recap like what we have discussed so far. So the prototyping model is systematic development method in which prototype is built, tested, and then reworked as necessary based on the customer requirement. An acceptable outcome is achieved until an acceptable outcome is achieved. So this is the idea behind this prototype model. If customer is not having clear understanding of requirement, so as I have discussed in the beginning of this video, if customer is new in the market, or if client is new, and if they are not aware of the, or if they are not sure about their requirements, so in these two cases mostly we go for prototype model. So this is what we have discussed, guys, the process. So requirement gathering, quick design, building prototype, and then customer evaluation, getting the feedback from the customer, refine the prototype based on their feedback. We make the changes on the prototype, and then go for the engineering product. Engineering is nothing but development and testing. So when to use prototype model? So prototype model should be used when the desired system needs to have a lot of interactions with the end users. So this is again one of the reasons we have. Typically online systems, web interfaces have a very high amount of interactions with end users are the best suited for prototype model, because here we are not sure like what to build, what customer actually wants. So we are not sure about what the client wants. So we create a prototype and we make the changes based on customer reviews. What are the advantages of prototype model? Active involvement. So users are actively involved in the development of prototype model. So early detection of missing functionality. So errors can be detected in the initial stage of the software development process. So since we are developing the prototype, so and we get it reviewed as soon as it is developed, so we can avoid the defects in the early stage of the development lifecycle. Quick feedback. So kicker, user feedback helps you to achieve better software development solution. So since we are building the prototype initially and get it reviewed from the customer, we can make the we can achieve a better software development solution by this process. Flexibility encourages innovation and flexible designing. So this is another advantage of prototype model. Now let's talk about disadvantages. So this model is costly and time consuming. Why costly? Because we are building we are putting effort to build prototype, and then time consuming. To build a prototype will take more time, right? So it has poor documentation because of continuously changing customer requirements. So we need to do a lot of documentation, guys. So it is not a quality documentation because of the continuously changing the requirements. There may be too much variation in the requirements, so this is another disadvantages. So this is all about prototype model, guys. So please like this video, share it, and comment if you have any questions or if you want to discuss anything. And please subscribe to this channel, click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about hybrid model. So what do you mean by hybrid model? So hybrid model is the combination of two or more models, and later on we'll modify as per our requirement. So this is called hybrid model. So I'll take you to my system directly, guys, where we'll discuss more about hybrid model. So let's get started. Guys, let's talk more about hybrid model. What is hybrid model? So hybrid model is the combination of two or more primary models and modifies them as per business requirements. Two or more primary models. So we have primary models like waterfall model, we have spiral model, V&V model, and prototype model. So it is the combination of either of two primary models and combined together to get the hybrid model. So basically, when we want the features of couple of models in a single model, it's called hybrid model. So let's talk about what are the examples of hybrid model. So when we combine spiral model with prototype, then we can call it as hybrid model. Another example could be V&V model and prototype model. So these are the two examples I have listed down here. Now, when we go for hybrid model, when lot of collaborations or interactions required between teams, then we should go for hybrid model. Dependency between the modules. So let's say for any particular product we have different modules, so and they are dependent with each other, then we should go for hybrid model. Unclear requirements. So if client is new to the market and if they are not sure about their requirements, then we should go for hybrid model. So generally we combined, I mean in hybrid model we combined with prototype model. So I have talked about prototype model in the last video, where if customer is new and if they are not sure about their requirements, then we go for prototype model. So here also the same thing, when we have unclear requirements, then we should go, because in hybrid model we generally combine with prototype model, as I have given in the example with spiral with prototype and V&V model with prototype. Organization is trying to transition to agile model. So this is another example when we go for hybrid model. Now let's talk about, guys, spiral and prototype, how we can make how we can combine spiral and prototype to make hybrid model. So already I have spoken about spiral model. So if you haven't watched that video, guys, so I would recommend please go through that video first. I have provided all the links in the description box of this video, like complete playlist about SDLC process, SDLC models. So please go and watch the spiral model and please come back to this video so that you can understand better. So let's talk about spiral and prototype, combination of spiral and prototype. So if you remember, we have 4 phases in a spiral model. So the first point is planning. Planning phase. The first one is planning phase. Second phase is we have risk analysis. Risk analysis. Third point is implementation. All these points already I have discussed, guys, what are the different phases in spiral model, and if you watch spiral model then you will come to know. And the fourth one is evaluation the software by customer. Now what happens in planning phase is when we combine spiral and prototype, here is first we build the prototype. We'll create a dummy dummy model prototype. So if you haven't watched prototype as well, prototype model, then please watch the prototype model. So let's say we have different modules, right? In spiral model we work in iterations. So let's say I'm planning to work for module A. Now what we'll do, the first we'll build the prototype for module A. We'll build the prototype for module A and we will test it. The tester will test it, and then we go for review from the customer, and then last one is approval from the customer. So these are the 4 phases we follow to create the prototype. And can join like this. So currently I'm planning for module A in spiral model, guys. Module A. So this is module A. Now what happens is, in planning phase, generally we get the requirements and all. Will analyze the requirements with the help of BA. So in this particular planning phase, we have created the prototype, we have get it done the testing and get it reviewed from the customer. And we if you get the approval, if you don't get the approval, then again we have to revise our prototype, and then again we follow the same procedure. Once it is approved, then this phase is passed. We can move on to the next phase, which is risk analysis. Once risk analysis is done, so we'll follow the same which we have followed in spiral model. So risk analysis, we do the risk analysis for module A, and then third is actual implementation of the product or project. So we'll do coding and testing here. Coding implementation is nothing but the coding and testing in this third phase of spiral model. Now this will evaluate, the customer will evaluate, give the feedback about the module A. If they want to make any change, then they will revert it back to the developer. Otherwise we will release it. Okay, one, because coding and testing is everything is done, so we will release it, and based on their feedback and customer reviews, we implement those in the next module. So this process will keep going on till we get the final build. So this is how it happens in spiral when we combine spiral with prototype. So this is the extra things which we are doing here to create the prototype, and when we combine with spiral model. Now let's talk about the next example, VNV and prototype. So how it happens in VNV when we combine VNV model with prototype. So I need to draw this V model, V shape, and this side is the developer side, and this is the testing side, or you can say this is a software development life cycle, and this is SDLC. So if you haven't watched V model, also V and V model, then please go and watch V model as well, V and V model, and then come back to this video. So how it happens in V model, we get the requirement from the customer, CRS, in the form of CRS, and then we'll convert that into BRD, and then I'm skipping that as of now, like BRD, convert that into BRD. We will directly go for the SRS. So that will be converted by technical team, and with the help of BA, that will be converted to SRS and system requirement specification, and at this particular point of time we'll create the prototype. Okay guys, and this is given to the development team as well as testing team, and we'll compare CRS and SRS when we create the system test plan, sorry, acceptance test plan, and we'll create the acceptance test cases. If you remember V model, we used to prepare acceptance test plan and acceptance test cases, because this will be my acceptance level. The level of testing is acceptance level. We'll come back here for the acceptance testing later on. So just understand, like we do acceptance, we create the acceptance test plan and acceptance test cases over here. Now what happens is the next sorry, we have with the help of CRS we create the acceptance test plan. Now the next point is will the developer created the prototype here. Now here this is the next level, which is system test level. Now what happens is here is we create this system test plan and system test cases. We'll compare will SRS versus CRS, and we'll go for here we go for CRS only, customer requirement specification, or you can say BRD, and here we go for SRS versus CRS. We'll compare both the documents, and here, because since prototype is created already guys, so we will test it, and if you find anything in the prototype like any defect or anything, then we will revert it to the development team here. And because here we'll test the prototype as well. Now what happens here is, again they will create the prototype, they will revise it and get it back to give it back to testing team. Now what happens, the next point is when we go for the client review. So the next point is here, client review. Client will review the prototype. So if everything goes well, then we go for the next step, otherwise they will revert it back to the development team for again designing the prototype, and then again we follow the same procedure, like we'll get it done the testing, and then if anything comes up, then we'll again go to the development team, and yeah, we'll revert it to the development team, and again they will give us for the testing. We'll get it approved from the client. Once it is approved from the client, then we go for high level design. Okay guys, so the next level here is integration level. Integration test, and here on this particular level, what the testing team will do here is integration test plan. They'll prepare the integration test plan and integration test cases, and this level of testing is integration test. Will perform the testing later on only, but this level of testing is called integration testing. We are ready with integration test plan and integration test cases. Now what happens, the next is here we'll go for the low level design, LLD, low level design. Now the next thing is functional testing. Here functional testing or functional test level. This is the functional test level. At this particular level, what we'll do, we create the, we'll come up with the functional test plan and functional test cases on this particular level. When developer developed the low level design, now they will do the actual coding here, because designing and everything is done, so they will do the coding, and developer will do the white box testing, or developer or white box tester will do the either the white box testing or unit testing. So this is unit level. So now like this, and once software is given to the testing team, now what we'll do, we got the build integration testing, unit testing is done. Now we'll go for the integration testing, because already we have functional test cases and functional test plan and functional test cases. Then if everything goes well, if you find any defect, we'll revert it to the development team, And if everything goes well, we'll go for the integration testing. Here we are ready with the integration test plan and integration test cases. And then we go for system test cases, system level testing. Here we have already ready with that system test plan and system test cases. And then finally we go for acceptance test cases, acceptance testing. Here we have already done ready with the acceptance test plan and acceptance test cases. So we'll execute the test cases whatever we have written on particular level. So this is how it happens with V and V model and prototype model when we combine together. So guys, hope it is clear. If you have any doubts, then please write in the comment box. I'll clear it. Now the next we'll talk about the advantages of hybrid model. So the hybrid model is highly flexible. So since we are combining two models, so it is very flexible model. In this model, the customer rejection is less because of the prototype. So since we already get the approval for the prototype, so customer rejection will be very less. It is easy to implement because it has flexibility of synchronization. So easily we can sync because it has flexibility of combination of different models. And it is easy to use and apply, especially with small and medium sized project. So this is very useful for the small and medium sized projects, guys. Now let's talk a couple of disadvantages of hybrid model. So it does not allow usual standards. So since we follow, we combine the couple of models. So usually sometimes we miss the some standards in when we develop hybrid model. For complex projects, it's very difficult to handle. So yeah, so these are the couple of disadvantages of hybrid model. So this is all about hybrid model, guys. So please like, share this video and comment if you have any questions regarding this video. And please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about derived model. So what do you mean by derived model? So in derived model, what happens is we take the basic model, let's say waterfall model, and we will change it as per our customer requirement. So take an example, if you take waterfall model, and like spiral model is derived from waterfall model, or V and V model is also derived from waterfall model. So these are the two examples of derived model, and this is also called customized model because we take the basic model and later on we customize the model based on our requirement. So I'll take you to my system, guys, where we'll discuss more about derived model. So let's get so guys, let's talk more about derived model or customized model. So this is derived model is also called customized model. So here we'll take a basic model, take an example waterfall model or single model, and change it according to the customer or business requirement or company standards. Is called derived model or customized model. So let me give you an example. So yeah, in requirement in waterfall model, what happens is we have requirement analysis, design, coding, testing, and maintenance, release and maintenance. So these are the phases of waterfall model. So what happens in waterfall model is we cannot go back to the previous phase which is already done. So here in this case we have this is requirement analysis, design, coding, testing, release and maintenance. So once requirement analysis and feasibility study is done, we cannot go back and change the requirement. So that happens in, that was the biggest drawback in waterfall model. Now you can see what do you mean by derived model. So we have a spiral model which is derived from waterfall model only. So this is our traditional model or base model, guys. If you remember, already I have spoken about waterfall model, spiral model, VNV model. So if you haven't watched those videos, then please go and watch those videos. I have provided the link in the description box of this video, the complete playlist. So what happens there is like a spiral model is derived from base model, that is waterfall model only. and we have done some kind of customization uh, in spiral model. Like risk analysis is the biggest thing in spiral model. Second thing is we do the module wise implementation of the will implement the software, we'll do the coding testing module wise. So these are the couple of things which we customize on spiral model. So spiral model looks like this. So we have module 1, module 2, like this. We do the implementation module wise. So that is the spiral model which derived from waterfall model. Okay, another example is V model. Now here also we do the testing as early as possible, parallelly with development life cycle. So this side is software development life cycle. Here we have software testing life cycle. Here you can see we have seen in V model. Parallelly we create the test plan, test cases when we go through development phases. So already we have started the testing phase. So this kind of customization we have done on V model. So yeah, this is the example, two example, like spiral model and V model are the customized model because they are derived from the base model. Now let's go move on to the next point. The most significant disadvantage of previous models like waterfall model is that there were lots of customer rejection that happens after the application was developed and there was no involvement of the customer in between the project. So this is the biggest drawback in spiral model, or you can say, sorry, waterfall model and spiral model later on. So yeah, the customer involvement is very rare in that case, less. So that's why again we customize, we go for the another customization, like we have done the prototype, right? So again we got some drawback in spiral model. Here you can see, like I have listed on, I have given the spiral. Waterfall already we have covered, like what are the disadvantages. Now spiral is because customer involvement is very less, so hence they have started the new approach which is known as the prototype model. So again this is customized thing which we have done from the basic model. Like we present to the present a dummy model to the customer, and based on their reviews, their feedback, will develop the actual software, will develop the actual product. So this is a derived model, guys. So let's say what is next. So the spiral example of derived model. So the spiral model is derived from waterfall model, which we have discussed. V model is also derived from waterfall model, and waterfall model is known as mother of all the models. So whatever model we have, uh, because waterfall model is also called traditional model. So all the models are, you see, more or less derived from waterfall model. So these are the examples of derived model. So this was very quick, guys, because if I mean for knowledge purpose, this is very important to understand, like what do you mean by derived model. So thank you guys for watching. Please like this video, share it, and comment if you have any questions. And please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by build, what is release, and what is the difference between them. So many people are getting confused, like what is build, what is release, and how we can differentiate them. So they look similar, but they are not quite similar. So let's talk about build first. So when a new version of the software, is given by the development team to the testing team for testing purpose, that is nothing but a build. And when a new version or complete software is given to the end user or customer, or in the market, when we release the new version of the software to the market or end user or customer, so that is nothing but a release or release process. And it's a formal process. Release is a formal process. Why I call it as formal? Because once testing is done, then only we release the new version of the software to the customer. So that is release process. So this is the difference between build and release, guys. So if you see, in both the things, we are releasing the new version of the software either to the QA team or to the customer. Then the question arises here is how the developer will build a new version of the software. So what they will do is there are few reasons they will do. They will give the new version of the software. So one of the reason is like when we get any defect in the software, so we'll raise a defect, and to fix that defect they will make the changes to their code, and they will compile it at their end. Once it is fixed, they will compile it, they will run it, and they will compress the code. So build is nothing but, guys, they cannot directly give the source code to the testing team for testing purpose. So what they will do is they will compile the code, they will run it, and they will compress it, correct? So it's compressed form, basically the build is compressed form, and they will deploy it on particular server. So in case of testing, they deploy it on QA server, and in case of if we deploy it on production, so they will deploy it on production server. So that's how they will do. So this is the first reason, like whenever we get any defect, so they will fix the defect and they will deploy a new version of the software. Another reason could be if they integrate multiple modules, so they will give the new version of the software, integrated version of the software to the testing team for testing purpose. So that is another reason. Another reason could be if you get some requirement from the customer. If you get the new requirement from the customer, they will develop that new requirement and make and do the adjustment in their code, and they will deploy the new version of the software to the testing team. And once testing is done, we'll deploy it on with the help of developer, they will deploy it on production server after successfully done with the testing. So this is how it is happening in build and release process. Now guys, if we talk about any example like Amazon releasing their software in every 11.7 seconds, how this is possible, how even this is possible when we do it manually, right? So they are not doing it manually. Nowadays we are living in Agile worlds or DevOps world. So this process is completely doing by automation, right? Automatically builds will be released to the customer or to the QA server automatically. So how it happens, correct? So we have several tools in the market. We have several build tools, like we have Apache Maven, Apache Ant, we have Gradle and Hudson. So these are the different tools we have which process this build process automatically, which doing this build process automatically. So that's the reason they are releasing the software in every 11.7 seconds. After making the changes to their code, they are making the changes in the UI or whatever as per the requirements, they are doing it, and they are releasing the software to the customer. Now I can give an example in Selenium automation as well. So if you remember, guys, I have created a framework in Selenium. So if you haven't watched that framework, then you can go to the description box of this video. You can see the framework related playlist, and you can watch that framework. So if you talk about example of that, so what happens, what I have done here, there is like I have integrated the Selenium framework, Selenium code with Maven and Git and GitHub and Jenkins. So whenever I make any changes to the code, automatically it is read by the GitHub, right? Whenever I check in any code to the GitHub, it picks up by the GitHub, and automatically builds are running in Jenkins and Jenkins pipeline. So this is how it is happening, guys, automatically. So yeah, this is all about build and release. So if you have any questions related to this, then please write on the comment box of this video. And yeah, please like and share this video, guys. And if you are new to my channel, then please subscribe it and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So I'm going to talk about an important topic today, and quite interesting as well. So I'm going to showcase you all kind of testing at one place, or testing hierarchy. So it's very important video for everyone, whether you are new to the software testing or already you are working in software testing. So this is very important video, guys, and yeah, it's interesting too. So without wasting much of your time, so I'll take you to my system and let's get started. So guys, if you are new to my channel, then please subscribe to this channel and click the bell icon to get the notification for upcoming videos. So guys, this is the complete hierarchy of software testing, and here I have mentioned all kind of testing over here under different levels of testing. You can see here unit level testing, integration, system, and acceptance level testing. So I have tried to list it down all possible testing which are available in software testing over here. And here, if you scroll down, you can see testing methods. We have white box testing, black box testing, and gray box. And we have some other testing as well. So guys, I tried to make all possible testing whatever we have in software testing over here. So please leverage this opportunity and watch this video till the end so that you can learn something from this video. And if you need this diagram, guys, if you want this hierarchy, then please let me know your email ID in the comment box of this video, and also mention if you have any questions over there so that I can answer you. So if you talk about any in software testing, like we have 4 levels. So whenever we do testing, whenever we perform software testing, so there are 4 levels we have to go through. We have unit level testing, we have integration, we have system level, and acceptance level. And uh, this is the flow which we do. Firstly we do unit level testing, integration, system, and acceptance level testing. Now let's talk about unit level testing first, and I'll go through all kind of testing which I have mentioned over here in a brief, guys. Today briefly I'll talk about each level of testing, whatever testing I have mentioned over here, and in coming days I'll talk about them in detail. Like I'll create a separate video on unit testing, under which what are the techniques we have. I'll talk about integration testing as well, system testing. There are different testing under system testing. I'll talk all about them, and then we have acceptance testing. So I'll talk about them in detail in coming videos. So today I'll go through what are the testing I have mentioned over here. So let's get started. So what do you mean by unit testing? So basically, whenever we get the requirement from the customer, whenever we develop any software, so developer will not develop the software as a whole. What they will do is they will divide the task into different modules. So let's say we have different modules. We are developing different modules. So module A, we have module C, D, and C and D. We have A, B, C, and D modules. So what developer will do as part of unit testing? So first they will develop module A, and they will do unit level testing on module A. So basically they will check internal structure of the program, and then they will test the functionality whether this particular module is working as per expectation or not. So that is what they will do as part of unit testing. Similarly, they will do for module B, and so on for module C and D as well. So this is what a developer will do as part of unit testing. Now, what are the different techniques we have as part of unit testing? So we have structural techniques, we have functional, and we have error-based techniques. Now let's talk about them in brief. So in structural techniques, guys, we have again 4 types. We have statement. So what do you mean by statement? So basically, let's understand like what do you mean by structural techniques. So basically, what happens is we verify the internal structure of the program under structural techniques. Structural techniques. So the name itself says, right, structural techniques. Now we'll there are 4 types under structural techniques. We have statement testing. So what we verify under statement. So here we testing each line in the program at least once. So that is statement testing. Moving on to condition testing. So what we verify? So we verify the conditional statement working correctly or not. Like we have if else, we have different loops like for loop, while. So we'll verify whether they are functioning correctly or not. All the loops is all the conditional statements. Moving on to branch testing. So what we verify here? So basically we verify all the branch statements are working perfectly fine or not, like nested if else, nested for loops, and other loops. Okay, so we verify all the branch statements whether they are working perfectly fine or not, working correctly or not. And if you talk about path testing, what we do here, so testing the flow of the execution of the program is tested under this path testing. So these are the 4 techniques, 4 types of testing under structural techniques, guys. Now moving on to functional testing under unit testing. So what we do in functional testing? So basically this is kind of black box testing where we don't bother about the internal structure of the program. We do test the functionality of the program. So some kind of functional testing which we perform as part of this unit under functional testing under unit level as well. So developer, as I have discussed earlier, like they will verify whether a particular module is functioning correctly or not. So that is part of functional testing under unit testing. Now, if I talk about error-based testing, so what do you mean by this error-based testing technique? So what happens here is intentionally developer will put the defect in the software in their code and verify whether we are getting the expected outcome or not, expected error message or not. So that is what they do as part of this error-based testing technique. And yeah, this is also called error seeding or defect seeding as well. And there is one more testing, guys, mutation testing. So what happens here is we change the specific developer change the specific components in the source code to ensure that a software test suite will be able to detect that changes. So that is part of mutation testing which developer will do. Now if we talk about integration testing, moving on to integration testing. So what happens in integration testing? So there are a couple of types. We have big bang approach and incremental approach. So what do you mean by integration first? So integration is nothing but the combination. So once all the modules are combined together, then we do integration testing. Once all the modules are combined together, then we'll do integration testing. So in big bang approach, what happens is when we test all the modules together, like module A, B, C, and D. When we test all the modules together after integration, so that is big bang approach. And if you talk about incremental approach, what will happen? First, we'll integrate module A to B, and then we'll test it A and B, and then again we'll integrate with module C, and we'll test module A, B, C together, and then we'll integrate with module D, and we'll test all the modules together. So this is how we test under incremental approach. Again, there are three types of incremental approach. We have top-down integration, we have bottom-up integration, and mixed or sandwich integration. Here we have mixed or sandwich integration, and we use stub and driver as part of mixed or sandwich integration, guys. So again, this will be a separate topic, incremental approach, which I'll discuss in a separate video. Now moving on, system testing, guys. So most of the testing are done under system testing, which we perform. So basically we do manual as well as automation testing as part of system testing. And yeah, we can divide system testing into two parts. We have functional testing and non-functional testing. So what is functional testing? So basically we do black box kind of testing where we don't bother much about the internal architecture of the system, internal structure of the system. We mainly focus on the functionality of the system. So these are the different testing under functional testing, which we have kind of user interface testing. So the first testing is user interface testing. What we verify as part of user interface testing. So let's say we have a web page, let's say login page. Here we have different objects like username, password, different fields, username, password, and forget password, and all. So and submit button or forget password. So these are the different UI element on the web page. So we'll verify all those elements are available, are present in the web page or not. So that is part of UI testing. Now if I talk about object property testing, object properties testing, so what we verify here? So let's say we have different fields on a web page, and we'll verify uh, like which field are enabled or disabled, the properties of particular field. So that is part of object properties testing. So we'll verify as per the requirement a particular field is enabled or disabled. So that is part of object properties testing. If we talk about error guessing testing, so what will happen here is this is kind of negative testing where we'll put invalid condition in the software, invalid condition in the application, and verify whether we are getting the expected outcome or not, like expected error message or not. So that is part of error guessing testing. If we talk about input domain, so what do you mean by this input domain testing? So we verify the data is accepted by the system, like we can enter in edit box or input box. So we'll verify as part of this, we'll verify whether system is accepted the data or not. So again, we have couple of techniques to verify this input domain testing. We have boundary value analysis and equivalence class partitioning as well. So I'll talk about input domain testing in detail. So all kind of testing, I'll talk about them in detail, guys, in coming days. If we talk about database testing, again, it's a separate topic because it's very vast topic. Database testing itself is a big chapter. So here what we'll do in database testing is we verify the data whatever we enter on the UI, whether it is saved correctly in the database table or not. We verify the stored procedure, we verify the triggers, indexes in the database. We also verify the constraints like primary key, foreign key, and some kind of database security also comes under this database testing. And yeah, so procedure as well. So these are the different kind of testing which we perform as part of database testing. Now if I talk about calculation testing, what we do as part of calculation testing, so this is mainly done in BFSI projects, like in banking project or financial services projects, or finance related projects where we do a lot of calculations. So we do calculation testing over there. If talk about link and URL testing, so this is on UI related application where we verify the particular link or URL whether it is redirected to particular URL or not. Whatever links, hyperlinks we have on a web page, whether they are redirecting to targeted a page or not. So that is part of link and URL testing which we do on UI related application, on web based application. Now if I talk about non-functional testing, so here we have usability testing. So what do you mean by usability testing? So basically here we verify the application is easy to use, easy to operate, and easy to understand or not. So this is part of usability testing. And if I talk about performance testing, so again, performance testing can be divided into different parts. So what do you mean by performance testing? So here we calculate the response time of the application. So here we have load testing. So what do you mean by load? So we gradually increase the load in on the system. So verify how the system behaves on certain load. So that is part of load testing. Stress testing is nothing but when we maximize that load into the system and verify how the system behaves. So that is part of stress testing. If you talk about soak testing, or this is also called endurance testing, guys, endurance testing. So what happens here is we'll verify the application like access the application for more than 24 hours or 48 hours, and we'll verify how the system behaves when we access the application for that long duration, like 24 hours or 48 hours. So uh, that is kind of testing which we do as part of soak testing. Now coming to accessibility testing, so it is kind of a practice to making your web or mobile apps usable as to as many as user as possible. So that is kind of accessibility we test, like how many user can access the web based application or mobile access, whether they are able to access correctly or not, properly or not. Kind of we check the response time, how they are accessing the web based application as well as mobile based application. If you talk about scalability testing, so what we test over here is it's kind of type of load testing. uh, so basically it measures the application scale up or down based on certain loads. So this is scalability testing. Now coming to memory leakage testing, so what happens in memory leakage, guys? So some memory got allocated during the development phase, correct? So basically, uh, they forget to deallocate some memory, and the developer used to forget some to use some memory. So that is memory leakage. And how we can verify this? So we can go to our task manager. We can verify how is the usage, CPU usage of that when we use certain application. So that is part of memory leakage testing. And here basically we check like some memory is not used. So that is memory leakage testing. What do you mean by volume testing? So when we verify the data transfer between two system, when we verify the data transfer between two system, and verify how the data is flow from one system to another system, so that is part of volume testing. If we talk about compatibility testing, so we verify our application is how our application is compatible on different browsers and different operating systems, so that is part of compatibility testing. Security testing, again a separate topic which we'll discuss in coming days. However, I'll discuss about all kind of testing in detail. So let's talk about security testing in brief. So here we verify application can be accessed for authorized user or not. So that is part of security testing. And again, we have different types of security testing, and we have separate testing for security testing. We have automation tool as well for security testing as well. Similarly, we have automation tool for performance testing, guys. We have load runner and JMeter. JMeter is very popular, so probably I'll create separate video on JMeter, separate series on JMeter, which we do as part of performance testing, which we use for performance testing. And yeah, this is security testing. Configuration testing. So what we do in configuration testing? So basically in configuration testing, what we verify is how our system testing the application access on different hardware technologies. So that is part of configuration testing. So this is related to hardware and compatibility related to different environments or different browsers. Recovery testing. So in case of failure, how we recover our data in the system, how we recover data for our software, right? Let's say we are in case of our application failure, so we'll verify whether we are recover the data in the system or not. So that is part of recovery testing. Installation testing. So this testing is done just before the production. So basically here we verify whether we are able to install properly or not, whether how much space the system is taking, and in case of installation and uninstallation, whether existing system should not get impacted. That is what we need to verify as part of this installation testing. And whether we are getting the upgradation message or not for when we install the software. So that is part of installation testing. Compliance testing. So as per market standards and companies policies, where application is compliant or not. So that is part of compliance testing. Documentation testing. So as part of software development life cycle, we prepare so many documentation. And yeah, so we need to verify as part of, as name says, that documentation testing, right? So we verify documentation as part of this documentation testing. Interoperability testing. So this is kind of end-to-end testing, guys. So here we verify end-to-end workflow in the system. Interoperability testing. Now moving on to the testing methods. What are the testing methods we have over here? So we have different testing methods, guys. White box testing. So what we verify as part of white box testing? So in white box testing, we verify the internal structure of the system, which comes under white box testing. So tester should know the internal structure of the system and should have technical knowledge. And if you talk about black box testing, so black box means we should not bother about the internal logic of the system, internal structure of the system. We should only focus on the functionality of the system. So that is black box testing. Gray box is the combination of white box and black box. So do not worry about all these testing method, guys, like white box, black box, gray box. I'll talk about them in detail in separate video with the help of an example. Now let's quickly go through other types of testing, like we have ad hoc testing, and these are the different testing terminologies, I would say. So what do you mean by ad hoc testing or unstructured testing? So here we don't need any documentation or kind of test cases to execute this ad hoc testing. So this is unstructured testing. Ad hocly we verify all the system whether it is working correctly or not, whether the data flow and whether application is working correctly or not, so without any documentation. So that is ad hoc testing, or you can say informal approach of the testing is called ad hoc testing. Regression testing, so what will verify as part of regression testing? So let's say if we get any defect in that application, so we'll revert it to the development team and they will fix the defect. Now after fixing the defect, we verify the unchanged functionality in the system should not get impact because of that defect. So that is we do as part of regression testing. Now we have retesting. What do you mean by retesting? So let's say we have some n number of test cases to test any functionality. We have tested n number of functionality. Now we got some error in for test case number 5 and 6. So what we'll do, we'll revert that defect to the development team. They will fix the defect, and again after fixing the defect we'll verify those two defects, two test cases only, for number 5 and number 6, to make sure that is working correctly or not. Yeah, we just re-execute our test cases as part of retesting. The name itself says, right, retesting, so we'll execute our testing again. That is retesting. Now what do you mean by sanity testing? So sanity testing is a subset of regression testing. So basically, let's say if developer fix any defects, let's say we have uh, created a calculator software, and we got some defects for addition. So what we'll do in sanity testing, we'll verify some of the basic functionality whether that is working for perfectly fine or not. So once the defect is fixed by the development team, let's say addition is fixed by the development team, so we'll verify like 5 plus 7 is equal to 12 or not. We don't check further. So this is capable enough to do further testing. We don't check like 10 divided by 5 plus 30 divided by 2. Okay, so we don't check this kind of addition over here. So we'll check like basic functionality whether it is working fine or not, and then moving for further testing as part of sanity testing. Now what do you mean by smoke testing? So here we check the critical functionality whether that is working correctly or not. Let's say we got some defect in the application, or we receive the new build in the software from the development team. Now we'll verify whether our let's say in case of web page, whether we are able to access the application or not. After putting the username and password, whether we are able to enter into the application or not. In case of Windows based application, whether we are able to launch the application or not. In case if it fails over here, then we'll revert it back to the development team. So that is part of testing which we do in smoke testing, like critical functionality, because login is the critical functionality, right? Until unless if you don't log in, we cannot go for the further testing. And here also, if you launch the application, in case of Windows based application, in case if it get crashed, so we cannot move further for further testing. So that is smoke testing. Now if you talk about parallel testing, so this is automated testing approach, guys. Parallel testing, so here we'll test different system parallelly. So in case of parallel execution, if you might have heard, when we execute our test cases on different browsers, Chrome, Internet Explorer, Firefox, or Safari, when we execute our test cases on different browsers, so that is part of parallel testing. And basically the main purpose of parallel testing is to save the test time. So that is parallel testing. Now what do you mean by concurrent testing? So within the system, when we when we test some functionality which are executing concurrently. When couple of functionalities are executing concurrently, couple of processes are executing together, so that is concurrent testing. So basically what we can differentiate between concurrent and parallel is, concurrent is within the system where two processes executing simultaneously, whereas parallel between the different system, one or more system, or sorry, more than two systems. When you execute our test cases on more than two systems, that is parallel testing. And within the system, when two processes are executing simultaneously, is called concurrent testing. Benchmark testing, again, this is the subset of performance testing, which we'll discuss in separate video, guys. Benchmark testing, end-to-end testing. So when we test the application flow from beginning till the end, so that is complete workflow of the application. So that is nothing but the end-to-end testing. Reliability testing, this is again another type of testing. So here we make sure that application is able to access, like able to execute all the test cases and without defect, right? So whatever defects we have raised as part of other testing, all are working perfectly fine or not as part of reliability system. So basically we check here how our system is reliable. So these are the different testing, guys. Here I have listed down, and these are very important testing which we do as part of software testing. And yeah, please go through it again one by one, and let me know if you have any questions related to any testing. And yeah, in coming days I'll make sure that I'll talk about them in detail, like unit testing, integration testing, system testing, and acceptance testing. And I'll talk about each level of whatever testing I have mentioned over here. So this is all for today, guys. So if you are new to my channel, then please subscribe this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. So guys, if you are new to my channel, then please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about different levels in software testing. So there are 4 levels in software testing. We have unit level testing, integration level testing, system level, and acceptance level. So these are the 4 levels in software testing. Now if we talk about unit level, so let me recap, like we already spoken about software development lifecycle. So there are different phases in software development lifecycle. We have requirement analysis, feasibility study, we have design, coding, testing, release, and maintenance. So these are the different phases in any software development lifecycle. Now what happens is, when we get the requirement from the customer, when we do the analysis of the requirement, feasibility study of the requirement, then we go for the designing part. So once design is done, then we go for the actual implementation of the code, or you can say coding phase. Now what happens in the coding phase? So as a whole, we cannot develop the whole system, correct? We cannot get all the requirements from the customer and develop as a whole. So we need to divide the task into different modules. So let's say in our take an example, in our case, we have divided them into different modules, like module A, module B, module C, and module D. So we have 4 modules, guys. Now what developer will do as part of unit testing? So what they will do is they will develop the module A, and they will verify each line of the code whether it is functioning correctly or not. So they will done the development for the module A, and they will test it themselves. So that is unit level testing, guys. So basically they will check, like that particular module is working perfectly fine or not as per the requirement given by the customer. So that is module A, and similarly they do it for module B, C, and D as well. So this is how it is happening in unit level testing. Now the second level is integration level testing. So what happens in integration level? So once all the modules are integrated, and unit level testing is done usually, like most of the cases, by developer guys, and sometimes it is done by white box tester as well. So the person who has sound knowledge in terms of technical things, then they can do the unit level testing. Now we talk about the integration. So once modules are integrated, once all the modules are integrated, now we have to check the functionality, like the data flow from module A to module B, module B to module C, C to D, or D to A. Basically we need to check the data flow from one module to another module. So that is the purpose of integration level testing. So who will do this integration level testing? So sometimes a developer used to do the integration level testing, like in most of the cases, and sometimes we used to do with the help of tester used to do with the help of developer, that integration level testing. Now moving on, the system level testing. So what happens in system level testing? So when we test integrated system, or as a whole, when we test a system, the complete system, that is called the system level testing. And in this particular testing, testers are involved, and here we do manual as well as automation testing. And in system testing we do check all kind of functionality, or all kind of non-functionality as well. Like, so basically we do functional testing as well as non-functional testing. So most of the testing comes in system testing, guys. So that is all about system testing. Now moving on to the acceptance level. So end user will do the acceptance level testing, whether the software is working correctly as per their requirement or not. So to check that, they will do the UAT level. So once testing is certified from our end, we send it to the UAT, where they will check, and customer and end user will test at their end or at developer's end, like whether it is working perfectly fine or not. So there are a couple of types of user acceptance level, guys. We have alpha level and beta level testing. So we'll talk about them in detail, like that will be a separate topic. Like, and if you talk about unit level testing also, we have some unit testing techniques as well. So I'll talk about them in a separate video, each level of the testing. So this is all for today, guys. I wanted to talk about what are the different levels of testing and some brief introduction about the test levels. So this is all for today, guys. Thank you for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by unit testing and what are the different techniques used by the developer or development team to do the unit testing. And at last we'll talk about what are the advantages and disadvantages of unit testing. So let's get started. So the first thing is, what is unit testing? So guys, we have already spoken about the software development life cycle. So there are certain phases in software development life cycle, like we have requirement analysis, feasibility study, design, coding, testing, release, and maintenance. So these are the different phases in software development life cycle. So once requirement analysis is done, feasibility study is done, then we go for the design. And once design of the software is done, then we go for the actual implementation of the software. That is nothing but the coding. Now take an example. In our case, we got some requirement from the customer, like we got one project for the website development. Now in any website, if you see, there are certain pages which are common. So let's say in our case we have registration page. So these are the common pages we can see in any website. So we have registration page, we have login page, and then home page. So what happens is, whenever we get any requirement from the customer or project, so we cannot develop that project together, like as a whole we cannot develop at once. So what developer does here is, they will divide the task into different modules. So they will divide development task into different modules. So in our case here, you can see module, this is module A, this is module B, and here we have C. Similarly, we have some other pages, and just for example, guys, here we have registration page as module A, and we have certain fields in registration page, like first name, last name, we have the user name to for the login purpose, and then we have email ID phone number, etc. are there in registration page to register for this website. So once registration is done, we will get the link in the email, and once we verify the link, we go for the login. To enter username, password, and click on submit button, we'll go for the will land in on the home page. So this is the flow of our website, or normally in any website. So what happens is we get some requirement or project from the customer, so we'll divide them into different modules: module A, module B, module C, and module D. So these are different modules we are developing. So what developer will do, so they will go and they will do the development for registration page first. So they will pick up the module A, and they will start development of the registration page. So they will do the coding, everything they will do. Once the development of registration page is done, they will do the unit testing. They will do some kind of testing at their end, so that is nothing but the unit testing. So they will verify internal structure of the program, whether they have written whatever code they have written is correct or not, and the UI and everything, whether as per the requirement there or not. So they do some kind of internal structure testing, and they'll do some functionality as well, like after doing the registration, whether we are getting the receiving the email or not for the verification purpose. So they will not do the detail level testing in terms of functionality, but they'll do some internal structure testing. So that is unit testing. So once unit testing for module A is done, they will go for module B development, and they will do the unit testing over here. And similarly they will go for module C. Once all modules are done, they will integrate for further integration, and they will create the integrated system, and that will go for integration testing. So this is about unit testing, guys. So let's see some definition of unit testing. So unit testing is a software development process in which individual units of source code modules are tested to determine whether they are fit for use or not. Fit for use means whether we can go ahead with the further process or not, like for integration of all the modules and then integration testing. So that is the main purpose of unit testing, like individual units of source code should be tested properly, or modules should be tested properly as part of this unit testing. Testing is conducted by developer or white box tester. So this is usually done by the developer or white box tester in some companies, if they had a white box tester, and the person who has very good knowledge in terms of technical things, so that they can do the unit testing. So to conduct this testing, programming knowledge is required. So this is what I was talking about. So this technique allows developer to analyze code. So just concentrate on this one, guys. So this technique allows developer to analyze code, catch bugs earlier, and fix them faster. So the main purpose of unit testing is to get the defect as early as possible. Like they will analyze the code, they will do the code review, and if everything goes well, they will do some kind of functionality testing as well. So their main motto is to get some defect early as possible, so that they can fix them as soon as possible before they go for the integration and integration testing. Now what do you mean by this unit test life cycle? So there are certain process, guys, so certain stages in this unit test life cycle which developer used to follow. Now let's say they have developed module A already, they have developed, and this is into remote repository. Already they check in the code and put into remote repository. So whenever we work in any company, guys, so we used to follow certain repository, like let's say in this case we have GitHub. So to check in the code, so that other team members can share their code as well, they can check out the code, and they will make some changes as well. So to work in a team environment, we have to use some repository. So in our case, the developer we have developed module A. One developer has already developed, let's say X developer has already developed module A and check in the code into the repository. Now what that developer will do, first process is check out the code. So check out the code from repository, and the second thing is execute unit test cases. So developer will write some test cases, guys, with themselves for unit testing. They'll create some scenarios, not in a formal way, but they used to have some kind of scenarios to execute the unit test cases in terms of internal structure of the program, how they will review it, and some functionality as well, whether that is working correctly, perfectly fine or not. So the first point is check out the code from the repository. Second is execute unit test, and the third one is, let's say as part of unit testing they get some defects or defects or error in the program. So what they will do, they will fix the defects and error. Now the next point is code review. So after executing the unit test, we get some defects, guys, defects or error, and they will fix those defects. They will fix the defects. The developer will fix the defects, and they will ask the other developer to review the code. So in this case, we have developer X, so they will ask other developer Y to review the code, and then what is the last? Check out the code, check in the code, check in the code, check in the code into repository. So this is the kind of life cycle of a developer, guys. So this is what they do whenever they go for the unit test. This is unit test life cycle. We have check out the code and then execute the unit test. We'll fix the defects or error if we get any on the code, and then code review by the peer review, or code review by the team, other members in the team, and then check in the code. So this is how the life cycle of unit tests. Now the next thing is, what are the different unit testing techniques we have? So we have structural testing techniques. So this is, again, there are 4 types of structural testing techniques we'll discuss in coming slides. We have functional testing, and we'll do some kind of functional testing as well, guys, as part of unit testing, as I have discussed earlier. And error-based testing techniques. So we have couple of error-based testing, like error seeding, which we'll discuss later, and the next one is mutation testing. So we'll discuss in coming slides about error-based testing techniques as well. So let's talk about structural testing techniques first. So structure-based testing techniques use the internal structure of software to derive the test cases. So to derive the unit test cases, so we'll do this structural testing technique. So yeah, it is white box testing technique. It required programming skills. So since we are talking about the unit test cases, so it requires programming skills. So these are the 4 types, guys. We have statement testing, condition testing, statement test condition, branch, and path. So these are all related with internal structure of the coding, guys, internal structure of the program. So what do you mean by statement testing? So testing each line in a program at least one time. So let's say we have developed module A now, so we have to go through each line of the code and execute each line of the code at least once. Like we have to execute our program, verify all the we'll do some kind of code review as well, so verify that everything is perfectly fine as part of this, for programming of or development of module A. Condition testing, so verify the conditional statements are working correctly or not. So what we have if, and we have if else, we have nested if, we have switch statement. So we'll make sure every what all the conditional statements we have all should work properly, all are executed properly as part of this condition testing. Branch testing, so verify all the branch statements are working correctly or not as part of branch testing. So we have break, continue, and return statements in for loop. So all those statements or branch statements should work correctly as part of this branch testing. So that is what we do as part of this branch testing. And another one is we have path testing. So testing the flow of the execution of the program. Basically we test the flow of the execution of the program in this path testing. So developer will use some workflow for their development guys. So for, let's say for module A, they have written some workflow. So all should be in a proper manner, like flow, the execution of the flow of the program is proper as part of this path testing. So these are the four structural testing techniques: statement, condition, branch, and path. Now if we talk about functional testing, so let's say they have developed registration page, correct? So which we have seen earlier, registration page. Now what they will do some kind of functionality check on this registration page. So some kind of functional testing we do as part of unit testing guys. So developer use some functionality check, like they will themselves they will do from their end some functionality check, like they will enter username, they will enter first name, last name, and after entering all the fields, they will go for the register, and they will verify whether we are getting the email or not. So some kind of functionality they will check. They will not go into detail like a tester, but they will do some kind of functionality check as part of functional testing. Functions are tested by feeding them input and examine the output. So this is the functional testing. Functional testing ensures that the requirements are properly satisfied by the application. And functional testing is a quality assurance process and a type of black box testing. So where what do you mean by black box testing? We don't care about the internal structure of the program. We just see the functionality is working properly, working perfectly fine or not. So however, we'll discuss more about functional testing when we talk about system testing guys. So but the developer also do some kind of functional testing when they go for unit testing. So that is the purpose I put it here, like functional testing. Now error based testing techniques. So there are a couple of example I have given over here, like couple of types. So we have error seeding and mutation testing. So what happens in error seeding? So what they will do, developer, they feed some error, they will seed some error, seed or feed errors in the program, and they will verify like how, what are the actual errors in the program by putting the what you can say artificial error in the program. How we how they do that, we'll see in the next slide with the help of an example. Mutation testing. So what do you mean by mutation testing? So what they will do, let's say we have written some program over here, let's say we have some statements over here. Now they will change it to, they will change something in the program to make sure whatever they have written is correct. So for this one, this changes, they should get some error or message, correct? So they will make sure that whatever they have written inside the program is correctly after making the changes. So after making the changes, we should get the exact message or exact flow. So that is the main purpose of this mutation testing. So I'll talk about an example in the coming slides. Let's talk about error seeding first. So I got this question in the internet guys. So this was asked in the gate exam. So a software tested using, and this is error seeding example, error seeding. So a software was tested using the error seeding strategy where which 20 errors were seeded in the code. So developer put 20 errors in the code, seeded in the code. When the code was tested using the complete test suite, 16 of the seeded error were detected. So out of 20, we got only 16 of these seeded errors were detected. So the main purpose of error seeding is, since we won't get the exact number of errors, so uh, that's the problem. So that to avoid that, we go for the error seeding technique to derive the actual number of errors in the program. So that Same test suite also detected 200 non-seeded errors. So non-seeded errors are 200. What is the estimated number of undetected errors in the code after this testing? So this is the question. Now here we have four options. So how to resolve this? Correct. So we have a formula, guys. So let me write the formula. So found or detected seeded error in the program. Detected seeded error. Let's say let's denote by this with n, and total seeded error. So what I have written here, detected seeded error divided by total seeded error. Now equal to, we have detected non-seeded error, non-seeded error divided by total non-seeded error. So this is the formula, guys. So detected seeded error n, this is, let's say, n, and this is r, small r, and this is capital R. You can see detected seeded error. We have detected seeded error, we have 16, correct? And divided by total seeded error, we have 20. We have error seeded in the program. Detected non-seeded error, we have 200. So we want this total non-seeded error first of all to derive the estimated number of undetected errors. So we can put the values in the formula. So we have 16, which is detected seeded error, which is 16, and divided by 20, which is total seeded error, which is this one. Now detected non-seeded error 200 divided by this r. So r will be 200 into 20 divided by 16. 4 4 is 16, 4 5 is 20, and 4 5 is 20. So total 250. So 250 is the this one, total non-seeded error in the program. Now we have to derive, right? So total is 250 non-seeded error minus, what is 200? 200 is non-seeded error. This is non-seeded error, right? Total non-seeded error is 250 we got, and we got the we already got, right, non-seeded error, which is 200. So what is undetected? Here you can see undetected errors. So undetected errors will be 50. Hope you got this answer. If you don't get this, then if you are not able to understand, then please let me know in the comment box, so I'll explain again. So we got the answer 50, which is undetected error in the program. So this is how you can derive the undetected errors with the help of error seeding. So before that, let me give an example of mutation testing as also, guys. So I don't have that slide as of now. So, and later on we'll discuss about the advantages of unit testing. So mutation testing, what happens is whenever we make any changes in the code, and then we'll see what is the behavior after making the changes. So let's say if we have some statement A is greater than B, so C is 20, else C is equal to 30. So this is my actual program. If A is greater than B, C is equal to 20, else C is equal to 30. Now I'll change it, we'll mutate some programs. So we'll change this program to if A is less than B, C is equal to 20, and else C is equal to 30. So this is what we made the changes in the program. So here you can see we have less than symbol over here. So there are three types of three types of mutation testing as well, guys. So we have value, decision, and statements. So this is decision related, like we have changed the symbol over here, the operator, arithmetic operator I have changed over here. Now this is mutant program. This is mutant program, and we'll verify as per this program whether we are getting the expected outcome or not. So definitely we'll get some error for this program. So that will make sure that this program is perfectly fine. The program which we have written is perfectly fine. So this is the main intention of mutation testing. So we'll make sure that whatever code we have written inside this if else, all are working fine. So this is just an example I have given with the help of if else block. So in the main program, like it will be like more coding. So now let's talk about what are the advantages of unit testing. So unit testing significantly improves code quality. So we do a lot of internal structure techniques we apply, and then we'll do code review as well. So unit testing significantly improves code quality. Unit testing helps identify all kinds of issues with the software at very early stage. So this is the biggest advantage of unit testing. If there are any problems, they are detected early on, and making changes to the system thus become much easier. Reduce cost. So as soon as we get the defect, we'll fix them as early as possible. So cost of the project will be reduced. Now, what are the disadvantages of unit testing? So it's difficult to write quality unit test cases, and the whole process can be time consuming. So this is very time consuming process, guys, if you do a lot of unit testing. So sometimes it's very difficult to do the unit testing as well. Not all errors can be detected. So we cannot find all the errors in the program since every module is tested separately, and later different integration bugs may appear. So right now we have tested a separate module A, B, C, D, A, B, C, and D. But once they are integrated, correct? So we may get some more defects later on, more defects. And also they have done the integration, unit testing only. So when we do the integration, when we go for integration, we may get some more defects as well. So this is, I think we are done. So this is all for today, guys. So thank you for watching. If you are new to my channel, then please subscribe it and click the bell icon to get the upcoming interesting videos. Thank you so much. Have a nice day. Bye bye. So guys, if you are new to my channel, then please subscribe it and click the bell icon to get the notification for upcoming videos. Thank you. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by integration testing and what are the different approaches of doing integration testing. And later we'll talk about what are the advantages and disadvantages of integration testing. And if you talk about like who is performing this integration testing, so it depends on companies' practices and preferences. So in most of the cases, it is done by testers itself, but in some companies, it is done by developer as well. Now let's move to the next slide and talk about what do you mean by integration testing. What is integration testing? So what do you mean by integration first? So integration is nothing but combination. So when we test two or more modules together, then that is called integration testing. So let's say we have module A and module B. So when we test these two modules together, that is nothing but integration, and we'll see the interfaces, the connection between two modules, like how the data is flow from module A to B and from module B to A. So that is what the purpose of integration testing. Now if you remember, guys, in the previous video we talked about unit testing, and there I have taken an example of website development. So let's say we are developing a website, and we have home page, login page, and home page in our website home page. So this is module A and this is module B. Now when we log in into this application, we have username and password, and then submit button. So once we enter username, password, and then click on submit button, then we'll navigate to home page. And this depends on this home page until unless we won't land on the home page when we until unless if we don't provide the username and password and click on submit button. So these two modules are dependent on each other. So when we test these two modules together, that is nothing but the integration testing. Now let's talk about some of the let's look at some of the definitions of integration testing. So testing is conducted by integrating two or more component is called integration testing. With the same system or two different systems are integrated. So it doesn't mean that within the system, if we integrate multiple modules, is integration testing. In integration, we may integrate multiple systems as well. It is it is a phase in software testing in which individual software modules are combined and tested as a group. So this is the meaning of integration testing. During the integration, we verify the data communication between the component. This is what I have spoken about, guys. So how the data is flow from module A to B and B to A. We calculate the performance time taken to complete the transaction. So this is another parameter we verify when we do integration testing as well. We calculate the performance as well, like how the data is flow, how the interface between module A to module B, time taken, how much time it is taking the data transfer from module A to B. That is also matters in integration testing. We verify the function of the application, functionality of the application. So this is an example, guys. So here we have module A and module B, and this is the common between these two modules, where these two modules are integrated, right? I mean, this is the common place where we perform the integration testing, the interface between module A and module B. So in case of login page and home page, so when we provide username, password and click on submit button, then the next thing will land on home page. And similarly for home page, until unless if we don't provide username and password and click on submit, we won't land on home page. So that is the integration between home page and login page and home page. Now let's talk about what are the different approaches we have to perform integration testing. So we have big bang integration approach, and we have incremental approach, where again we can divide three types, like top down integration, bottom up integration, and mixed or sandwich integration. So what do you mean by big bang integration? So big bang integration, when we combine all the modules together and test, that is nothing but the big bang approach, when we combine all the modules together and perform the testing. So this is big bang approach. What do you mean by incremental approach? So when we combine one module to another module and perform testing over here, and then combine to another module and perform testing here, combine another module and combine testing. So this is incrementally, we are adding one module at a time. So that is incremental approach. Again, incremental approach is three types, right? We have top down integration, bottom up integration, and mixed or sandwich. So top down, bottom up, and then mixed integration or sandwich integration. We'll discuss about them in detail in coming slides. So what is big bang integration approach? So testing is conducted on multiple components together. All the units are tested together as one single combined unit. So this is what I have spoken about in the last slide. This form of integration testing works well for smaller systems. So there are some limitations in big bang approach, guys. We'll discuss in next slide. Yeah, so this is the big bang approach. We have one system, and here all the modules are combined, all the units are combined, and when we test, so this is nothing but the big bang approach. Now what are the limitations faced in big bang integration approach? So in this approach, detailed testing is not possible. So detailed testing is not possible because we have combined all the modules together, and we don't know how the data is flow from one module to another. So it is time consuming process, and it's very difficult to check like how the data is flow from A to B, B to C, C to D, and then A to D or D to C, like that. So it's very complicated to test when we follow this big bang approach, particularly in big for big projects. Not possible if any defect is found. It will take time or effort to analyze the defect. So it is also difficult to find the root cause of the defect in this method, because we don't know like how the data is flow. So it's very difficult to find the root cause of the defect. Critical modules are not prioritized, which could increase the overall risk. So this is another limitation. Critical modules are not prioritized, which could increase the overall risk in the project. So these are different limitations guys when we follow big bang approach, and it's time consuming as well. Now let's talk about incremental approach. So in incremental integration testing, the developers integrate the modules one by one, which I have discussed. Like we integrate module A to B, and then from B to C, B to B and C to integrate with C. So incrementally we are adding the modules using the stubs and drivers. So we'll discuss about what you mean by stubs and driver to uncover the defects. This approach is known as incremental integration testing. Incremental integration testing. Now what do you mean by stubs and drivers? So what happens is, let's say we have module A. Now we are integrating with the sub module. This is sub module. This is main module guys. So this is main module or parent module, and this is child module or sub module. Now we are integrating with these two, correct? So let's say this is under process, this is under process, this is not yet done, but still we wants to do integration testing. So we create a program called stubs, temporary program. So that is nothing but the stubs. So we'll discuss in coming slides. Testing, in which components or systems are integrated and tested as long as all components or system are integrated and tested completely. So this is about incremental approach. So what are the three types? We have top-down integration, bottom-up integration, and mixed. So what do you mean by top-down? Testing is conducted from main module to sub-module. In this approach, verify the data updated in main module and is updated in sub-module. So let's say take an example of login page and home page. Correct. Now we'll verify, because we'll verify here. We'll integrate first login with home page. Now testing is conducted from main module to sub module. So this is my main module, login page is my main module, and this is sub module. So how the data is flow, because until unless we don't log in with username and password, it won't log in with it won't land on this home page. So in this approach, verify the data is updated in main module, is updated in the sub module. So here it will showcase the username, right? So it depends on this module. So data will be updated once we log in in the application. Bottom up integration. So testing is conducted from sub module and verify the data tested in sub module, thus make sure the highest module is tested properly. So let's say in case if this module is developed and this module is not developed, so we'll use the driver over here. So they will create a driver. Now we have this home page. So to run this program, we need to supply the username and password. So what they will do, they will create one valid user or some function. So that will call that will supply the username and password and will land on this particular page, home page. And later on they will develop the module login page module. Anyway, we'll discuss about top down, bottom up integration in coming slides. What about mixed or sandwich integration? So it is a combination of top down and bottom up integration. So this is the combination of both the bottom up, top down and bottom up integration. So what do you mean by stubs and drivers, guys? So these are the temporary components which are used in place of sub module and main module. Stubs. What do you mean by stubs? So it is substitute of sub module in top down integration approach. And driver, it is substitute of main module in bottom up integration approach. So I'll show you with the help of diagram in the next slide. So here you can see this is stubs. So here our main module is done. Okay, this is top down approach, guys. So here you can see top down approach, and here our sub module is under maintenance, under development. What developer done here is they have created a stub. So some functionality they have created a temporary program for testing purpose, for test. So this is how we perform top down. So basically what happens in top down integration is without developing the next module, sub module, we can still perform using these stubs. So this will act as a sub module. Now just reverse bottom up. So here we our in case we have taken an example of home page, right? So this is take an example, this is our home page. So home page is already done over here, but our main module which is login screen is not yet done. This is under development, main module. So here driver will act as main module, which will provide the user ID and password for this home page. So what they will do, they will create one temporary program which will provide the which will supply the user ID and password for this home page screen. So this is for test, right? This is driver, right? So this is bottom up approach, guys. So what are the advantages of integration testing? So it ensures that internal modules and components communicate properly, and it performs regression testing on important connection points. So it performs regression testing also on important interfaces between two modules. It also helps to detect the issues related to the interface between the modules. Integration testing helps to simulate the interaction between the various modules. So basically integration testing talks about the interaction between the two modules. It covers multiple modules to provide broader test coverage. So this is the biggest advantage of integration testing, provide the broader test coverage if it covers the interfaces between two modules, like how they are connected with each other. So what are the disadvantages or limitations of integration testing? So difficult to perform because it is time taking process, as well as it's very difficult because how the modules are integrated with each other. So that we need to understand in integration testing. So it's very difficult to perform as compared to system testing, in which we can consider the application as a black box. So in if we talk about black box, so we can directly consider like a black box when we talk about system testing, where we need to just talk about like how the functionality are working in the integrated system. We don't care about how it is working internally. So that is the biggest one of the disadvantages of integration testing. Time consuming. It is very time consuming and resource intensive to test all the interfacing between the different connected modules. It's time taking process, guys. And additional efforts, it requires the creation of stubs and drivers. So this is what we have spoken about top down and bottom up approaches of incremental approach, which if not created correctly can result in inadequate testing. So the developer should create proper stubs and drivers so that integration testing will be smoothly done. So this is all about integration testing, guys. So if you have any questions, then please write your question in the comment box, and please like this video, share it, and if you are new to my channel, then please subscribe it and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what is system testing and what are the different types of system testing. So let's get started. So what is system testing? So guys, already we have spoken about what do you mean by unit testing and what is integration testing. So if you haven't watched those videos, then I would recommend first go through those videos and please watch them and come back to this video. So I have provided the link in the description box of this video, the complete manual testing playlist. So please go there and watch them, and then please come back to this video. Now if you talk about like briefly, if you talk about unit testing, so what we have done in as part of unit testing, we have tested the individual module. So that is nothing but the unit testing. So these are the we are developing a software, guys, and these are the part of. So we have tested individual module in as part of unit level testing. So this is my first level, which is performed by developer or white box tester. So we have tested all the modules individually. Later on, we'll integrate all the modules together. And when we perform the testing on integrated module, so this level is called integration testing. Integration test level or integration testing. So what we do here, so we mainly check the data flow from one module to another module. So here we have different modules which are integrated, and we mainly check the data flow from one module to another module. So that is the main purpose of integration testing. We check the interfaces between the modules. That is integration level or integration testing. Now the third level is system test, and we perform on integrated system. So this is my third level, guys. So this is called system testing level, system test level or system testing. So this is performed once all the modules are integrated and tested as part of integration testing. Then we go for system testing. So what we test over here, so basically we check the functional aspect and non-functional aspects of the software or our system. So that is part of system testing, that is system testing. Here we also check like end-to-end testing. So what is the meaning of end-to-end testing, and what is the difference between end-to-end testing and system testing? So in end-to-end testing, what we do, we check the data flow from beginning to the end. We check the functionality from one point to another point, like from beginning till the end. We'll check the complete flow of the application. So this may be in one system or maybe different system as well, how the data is flow from one system to another system. Whereas in system testing will test in one integrated system. So that is called the system testing. And we can say, guys, system testing is the superset of end-to-end testing. So we can say end-to-end testing is the part of system testing, or in other words we can say end-to-end testing is the subset of system testing. System testing is the superset of end-to-end testing, and end-to-end testing is the subset of system testing. And in any other differences between system test and end-to-end testing is, we perform system testing after the integration testing. Here you can see after the integration testing we perform system testing, and end-to-end testing is performed as part of system testing only. So these are the differences between system testing and end-to-end testing. And the fourth level would be UAT, which will be done by the end user. And you can see, guys, this is completely done by the tester system test, and this is done by the developer or white box tester, and this is done by the tester, and in some companies with the help of developer as well. And this is the system, this is the testing where completely testers are involved. And because here there is no involvement of the developer or the end user, and this is completely by the end user. So this is all about system testing, guys, which we are going to discuss today. So now let's talk about some of the theoretical stuff about the system testing. So system testing is testing conducted or on a complete integrated system to evaluate the system's compliance with its specified requirements. So whatever requirements we have we got from the customer, we have created the system test plan. We have already spoken about as part of verification and validation model. So as part of whatever requirements we have captured, we test the system test, like all the functionality is working perfectly fine and perfectly fine or not. And we do check the functional as well as non-functional aspect of the system. Testing is conducted by the tester, which we have spoken about. and it is black box testing. So what do you mean by black box testing? So mainly we focus on the application, functionality of the application. We don't focus on the the other like non-functional function of the application, like security, performance, or internal structure of the system. Mainly we'll focus on the, we don't care about the internal structure of the system. We mainly focus on the functionality of the application. So that is black box testing. So this testing is conducted after the complete code is developed. And during system testing, we will conduct both functional and non-functional testing, which we have spoken about. So what are the different types of system testing, guys? So I already have discussed, like we have functional testing and non-functional testing. Yeah, so these are the different testing, guys, we perform as part of functional testing as well as part of non-functional testing. So these are the different testing we perform. And if you remember, I have already created a video on testing hierarchy where I have explained like in brief about all these testing which I have mentioned over here, like whatever functional testing, user interface testing, object properties, error guessing, input domain, already I have explained. So I'll provide the link in the description box of this video on top of it. So you can go there and watch this, the complete testing hierarchy. So you will understand better. So this diagram is the part of that testing hierarchy, guys. And also I have spoken about non-functional testing as well in brief. However, in coming days, I'll explain each of the testing in a separate video, and I'll explain with the help of an example as well. So let's move on. So what are the advantages of system testing? So it helps in getting maximum bugs before acceptance testing, because we do perform functional as well as non-functional testing. So we get so many defects in terms of functionality and non-function of the application. It ensures the application is validated as per customer requirement, software requirement specification, and functional requirement specification, because we do write the system test cases as part of based on software requirement specification and functional requirement specification. So what is SRS? So this talks about the functionality of the application, or and functional requirement specification is also, but this is detail level, guys. So functional requirement specification will talk about the functionality in detail level. So mainly this is used by the tester only, testing team, but we'll also take an example of take help of SRS as well, which is mainly used by the project manager or subject matter experts or business analyst. So it is first testing level in which whole system is under test from end to end. So we have already spoken about end-to-end testing as well. So this is the phase where the whole system system is under test from end to end. This technique phase uses the test environment which is similar to the real business environment or production environment. So yeah, this is same like the production environment, guys. So once all the systems are integrated, once everything is done, development and everything is done, then we go for the system testing. So it will be like staging requirement, or it will be a kind of replica of the production environment. So you can treat like this. So what is functional testing, guys? So these are black box testing techniques. So I have already spoken about, which test the functionality of the application. Functional testing validate the application's functionality is working as per requirement or not. So in functional testing, we do care about how the system is uh, performing functionally, like how it is functioning, whether it is functioning correctly or not, as part of functional testing. So take an example of Gmail. So whatever we do in Gmail, like we log into the Gmail and we compose the email, and we send the email, we write to address to where we are going to send the email, and subject line, and we'll write in the body our contents, and then send the email. And once we send the email, it will go to the send box, correct, and sent items it will go. So this is what we test as part of functional testing. Like the functionality we will check, we don't care about how internally it works and what is the performance to send the email, how much time it is taking, what is the security things, security related things. We don't care about that. So this is functional testing. It is quality assurance process. Functions are tested by feeding them input and examining the output. So feeding them input means we are sending the email, we are putting the data, we are putting some data over there like to address, and then we are putting the subject line, and we are putting body also, the contents as well. After sending the email, we will go to the recipient and will verify whatever we have sent whether we have received those or not. So that is kind like we are providing the data input, and we are getting the in terms of output. So based on the data, like whatever we have provided, we verify whether we are getting the expected outcome or not. So these are the different we have seen in the diagram also, guys, type of functional testing: user interface testing, object properties testing, we have error guessing testing, input domain, database testing, calculation testing, links and URL testing. These are the different testing. And as I have already told, so as part of hierarchy, when I have explained the hierarchy, complete hierarchy of the software testing, where I have spoken about the brief about all this testing. So please go and watch that video. The link is given in the description box. Non-functional testing. So what do you mean by non-functional testing? So it is the type of testing where we check non-functional aspects like performance, usability, reliability, etc. of a software application. We test the characteristics and feature of an application. Non-functional testing has a goal to validate the performance of the software. So what are the different types of non-functional testing, guys? So we have usability testing, performance testing, memory leakage testing, volume testing, compatibility testing, security testing, configuration testing, and recovery testing. And we have installation testing as well. So if you want to, again, I have provided the link in the description box, so please go that complete testing hierarchy where you can understand better. And however, in coming days I'll talk about all these testing types in detail with the help of example as well. The last one, compliance testing. So this is all for today, guys, about the system testing. So thank you for watching. Have a nice day. Bye bye. So guys, if you are new to my channel, then please subscribe it and click the bell icon to get the notification for upcoming videos. Thank you. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about acceptance testing and its levels, like alpha and beta level testing. So acceptance testing is the highest level in software development lifecycle, guys. Highest level of testing. So we have different levels of testing, like unit level testing, integration level testing, system level testing, and this is the highest level, which is acceptance testing. So if you haven't watched those videos like unit testing, integration testing, and system level testing, then please go and watch those videos. I have provided the link in the description box of this video, guys, and then come back to this video. So this is the highest level of testing, and this is also called UAT, user acceptance testing, guys. So let's talk about more about acceptance testing in detail. So before I move towards the theoretical stuff, like what do you mean by UAT and what is alpha testing, what is beta testing, and what are their advantages, let me just explain you like what is acceptance testing or UAT testing, and why do we need UAT testing, and how do we perform this UAT testing. So let's get started. So take an example, guys. We are working for this company. So this is our software development company. We are working for a software development company, and this is the customer which we are dealing with. Now this customer wants to have a software. They want to build a software from our company. So they requested our company to build a software for their clients. So what they will do, they have given their requirements in the form of customer requirement specification. Now what our company will do, our BAs, business analyst, work with their requirements, work with client or customer and get the requirement in the form of CRS, and BA will convert them into different documents for our company's understanding. Like we have software requirement specification, we have functional requirement specification, or we have business requirement document. This is just for our understanding. BA will convert them into different documents, which we have already spoken about at the time of software development lifecycle. Now, what our company will do, now we got the requirement and will develop a software. We'll develop a software or application for customer. And once we have to follow the software development lifecycle, correct? We have followed the software development lifecycle to build this software. Like we have requirement analysis, we have feasibility study, we have design, coding. Now when we talk about testing, we have performed different testing. We have done unit testing, we have integration testing, we have system testing. Now we need to perform the highest level of testing, which is acceptance testing. So how do we do this acceptance testing, and why do we need acceptance testing? So what happens is, whenever we build a software, customer wants to have a final look of the software, like how the functionality is, how the workflow is, how the interface is, and how the feature, what are the features they have included as per our requirement or not. So this is what the customer wants to do the UAT. So this is one of the reasons they, because they are paying for this software, right? They are paying to our company to have the software, to get the software. So they want to have a final look of the software, they want to review it. So that is the reason they want to do the UAT testing, that is user acceptance. So based on that, they will accept the software, they will accept the application. Now user acceptance, another reason could be, so whatever documents we have written over here, we have gathered the requirement from the customer, that might be misunderstood by our developer while developing the software by our development team and testing team while developing the software and testing the software. So that is that could be another reason. Customer wants to review the software, whether they have captured all the requirement or not, they have implemented all those requirements as per our expectations or not, whether the design is whatever they have designed in the application, that fulfill our expectations or not. That is the reason customer wants to do the UAT testing. So in most of the companies, guys, we have pre-UAT and post-UAT, and in some companies we do only UAT testing. So pre-UAT, so here we have pre-UAT, and this is also called alpha testing, alpha. And at customer end we do beta testing, and this is called post-UAT, post-UAT. So now we'll do the pre-UAT testing. We'll create a test plan, pre-UAT test plan, scenarios and test cases, and with our testers and BAs involved in this pre-UAT test, and we'll do the pre-UAT test at our end, alpha or alpha testing at developers end. So this is development company, guys. So our in testing environment will do the pre-UAT testing. Now if everything goes well, then we pass the pre-UAT test. Otherwise, if we get any defect, then we'll get it fixed by the development team and we'll release the software to the customer for beta testing or post UAT testing. Now they will perform at their end. This is real time environment, guys. Real time environment or staging environment, just like production. So this is production environment, so it will be just like production environment. So they will execute some real time scenarios. They have their own testing team there, including BAs. So they will perform the post UAT testing. So they have set of UAT test cases and they will execute those test cases. Now if they are not happy with some of the requirements which we have developed, so they will revert it back, or if they get any UAT defects, so they will revert it back to our development team. Now we'll redevelop those functionalities or requirements from the customer, or suppose they have missed some requirements from while giving the CRS, at the time of initial requirement given, giving the while giving the at the time of initial requirement, if they missed some requirement, so they will add while doing the UAT, and they will revert it to the development team. Now we'll redevelop all those requirements and will revert it back to the customer again. Now again they will execute their post UAT test cases or beta level testing they will perform. Now if everything goes well, they will release the software into production with, and they will release the software to their customer, their own clients. So this is how it is happening, guys. Acceptance testing or UAT testing. So as I have told, like some companies, they are following pre-UAT and post-UAT, which is called alpha testing and beta testing. And in some companies, we used to do only UAT at customer end. So this is all about acceptance testing, guys. Now let's talk about like theoretical stuff and what is alpha testing exactly, and what are the different advantages of alpha and beta testing. So let's move on to the next slide. So after testing is completely completed by tester before deploying the application into production, business user will conduct testing to ensure the application is working as per their requirement or not, called acceptance testing, which we have discussed. This is a type of testing done by users, customers, or other authorized entities to determine application software needs and business process. So this is done at our end, which is developers end, which is called alpha testing. Another way to do UAT is if they release their software to their own customers. So we can do the UAT at their end as well. They will perform the UAT at their end as well. So that is another way to do the UAT testing. Software testing, where a system is tested for acceptability. So whether to accept that software or not. So that is evaluate using this UAT testing. What are the different levels of acceptance testing, guys? So we have discussed, we have two levels: alpha test or pre-UAT, beta test or post-UAT. So here you can see alpha testing and beta testing. Advantages of acceptance testing: so reduces the risk of defects being identified in production. It increases the satisfaction of clients as they test application itself, increasing software robustness and usability, and increase end user happiness. So these are the different advantages of doing acceptance testing, guys. Now let's talk about alpha test. Alpha testing is conducted in the development company, which we have already spoken about. Alpha tests are carried out early in the development process by internal staff. Project manager teams up with the developer to define a specific goal for alpha testing. Testing is conducted in test environment. So this is what we have spoken about. Testing is done by testers and quality analyst. So quality analyst is nothing but the business analyst, and some QA group is also there, and testers with the help of them will do the UAT testing. We have will create certain test plan and scenarios and test cases as well to perform pre-UAT testing. Testing is conducted for application and product. So what are the advantages of alpha testing or pre-UAT, guys? So it helps to uncover bugs that can pose a serious threat. It helps to deliver good quality software or beta testing. So during this testing, the real world behavior of the users and the environment is imitated. Correct. So we'll try to imitate the real world scenarios. So what is beta test? Testing is conducted at customer location. Beta testing is one of the final steps in your software development lifecycle before a product goes live. Beta testing is performed by the real users of the software application in real environment. So this is what we have discussed so far. At the beginning, we have discussed beta testing allows a company to test post-launch infrastructure. Advantages of beta testing or post-UAT. Direct feedback from customer is major advantage of beta testing. So we'll get the direct feedback from the customer, like what exactly they want to have change in the software. Reduces product failure risk via customer validation. improves product quality via customer feedback. So yeah, this is all about acceptance testing, guys. So if you have any questions, please write in the comment box of this video, and please like it, share it, and if you are new to my channel, then please subscribe it and click the bell icon to get the upcoming interesting videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about the difference between system testing and integration testing. So basically we do perform system testing and integration testing on integrated system, but we need to understand like what is the exact difference between system testing and integration testing. So let's get started. So what is system testing? So when we check the behavior of all the modules, behavior of all the modules as a whole. Correct. When we check all the modules as a whole system, then we perform system testing. So that is the when we check the behavior of all the modules as a single unit. Correct. So that is nothing but the system testing. And what we check in integration testing, interfaces between the modules, interfaces between the modules. That is system testing. What is the second point? What is the second difference? Okay, so here what kind of technique we use? Before that, what are the testing we perform? Here we perform functional and non-functional, functional and non-functional, and here we perform functional only. So what is the difference between functional and non-functional? Here in functional we do the UI testing and input domain testing and database testing. So these are comes under functional testing, whereas in non-functional testing we do check performance, security, memory leakage. So these are all comes under non-functional testing. So what is the third difference, guys? We perform system testing after integration. After integration testing, and we do perform integration after unit testing. So we have already spoken about unit testing, integration testing, system testing, and acceptance testing. So these the level, guys. These the different levels in software testing: unit testing, integration testing, system testing, and acceptance testing. Now fourth point is which technique we use. So we use black box technique, and here we use black box plus white box. So black box means we don't care about the internal structure of the system. We check mainly the functionality. What is the fifth point? Fifth difference. So here we create the real-time scenarios. Here we'll test with try to create the real-time scenarios, or you can say created to imitate real time or real life scenarios. And here we try to simulate uh, simulate interactions between modules. What is sixth point, guys? Sixth difference. This is performed System testing is performed by testers, and here integration testing is performed by testers as well as developer in some companies, because we need to check the interfaces between modules. So that's why some typical scenarios we need developer involvement as well. So these are the different points which we talked about, the difference between system testing and integration testing. So guys, if you still have some doubts, then please let me know. Write your question on the comment box of this video. Thank you so much for watching this video. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about the difference between Agile model and V model. So guys, already I have covered about different software models. So I have provided the link in the description box of this video, the complete playlist of software development models. So if you haven't watched those videos, then I would recommend first go through and watch those videos, and then please come back to this video. So let's get started with the difference between Agile model and V model. So what is the first point, guys? What is the first difference? So Agile is iterative model, whereas V model is not a iterative model. Why I called Agile as iterative model? Because it based on sprints. So let's say we are developing sprints, sprint 1, and what we'll do here in sprint 1, we'll follow these certain software development process like requirement, design, coding, testing, release and maintenance. So 5 phases will apply on this sprint 1, and once it is developed, we'll develop sprint 2, so and so on, we'll develop till we get the final product or final build. So this is how we follow in Agile methodology, like it is based on sprints, and so we are following a certain process in each sprint, correct? So like software development life cycle, the 5 phases of software development life cycle. So that's why we keep repeating those phases. So that's why it is called iterative. Iterative means when we perform same task again and again, so that means iterative. What is the second point or second difference between Agile and waterfall? So this is incremental model, guys, and V model is not a incremental model. So why Agile is incremental? Because since it is based on a sprint, so we'll keep adding on sprints till we get the final build. So each sprint has certain requirements from the customer. So this sprint has certain requirements because customer changing their requirements frequently, and that's the reason they go for this Agile methodology. And here we are following Agile sprint cycle to develop the software. So this sprint 1 has certain requirements, sprint 2 has certain requirements, so we keep adding on the requirements, correct guys? We keep adding on the requirements, so that's why it is incremental. Our software is getting developed in incremental fashion. So that's the reason it is called incremental model. What is the third difference? It consists of sprints. It consists of sprints, which we talked about, sprints, and here it consists of verification and validation. So this is V model, guys. So left side is verification and this is validation. This is also called development cycle and this is testing cycle, testing levels, and this is the developer's life cycle and this is tester's life cycle. So we have verification and validation. So we have two main phases over here, verification and validation. Here it is based on sprints, And what are the different phases, guys, if you talk about agile methodology? So 5 phases which we have discussed earlier, 5 phases in agile methodology. Here we have how many phases? 5 phases in verification and 5 phases in validation. So phases in agile methodology, what are those? Like we have requirement analysis, design, coding, testing, release, and maintenance. So these are the 5 phases. Release plus maintenance is one phase. So we have 5 phases in agile methodology in each sprint. And here in verification and validation, each side we have 5 phases. So verification side we have requirement analysis, then designing we can divide in two parts. We have high level design, low level design, and then we have coding and then release. So these are the 5 phases. And the testing side we have different test levels. We have unit test level, and then we do perform functional testing as well. So functional testing is one level, and then we have integration, system, and acceptance level. So 5 phases in verification and validation. What is the fifth difference between agile and V model, guys? So here we can say testing and development are concurrent. And here we can say it is not concurrent. Because here you can see testing and development, because when developer start development of sprint 1, we'll start testing this as well at the same time, and once it is finished, we'll complete this testing and we'll start planning for sprint 2. And similarly, developer will start developing the second module or second sprint. So once we finish this one, we'll start second module, and developer will start third. So concurrently testing and development are keeps going on. So that is in agile methodology. Here what we'll do, we cannot start the testing until unless the product is finished. So first we'll follow, however we'll start our testing phase along with the development. Like we'll prepare the acceptance test plan. For each level we start the will planning will start when we start the development for the testing phase as well, but we'll start the actual testing once software is developed at this level. Once coding is done, they will release the software to the testing team, and then we'll start the testing. We'll execute all our test cases one by one, like unit level, and then integration. For that functional integration, and then functional, and then we have system, and then UAT. So this is how it is going in V model. What is the sixth difference, guys? So I would say testing is easy in agile methodology. Here little bit difficult. Why it is easy? Because we are keep interacting with the development team uh, and BA team and the customers. So we are in sync, particular proper sync with the sprint cycle. Here it is difficult because it takes a lot of documentation, and it's time consuming, guys. So that's why it is little bit difficult to do the testing, and it is kind of uh, V shape, correct? So until unless product is not developed, we cannot start the testing phase. So testing is, and there is no communication like agile methodology in V model. So that's why testing is difficult in V model. So seventh point, we can say seventh difference, testers and developers are dependent on each other. Here independent. Here tester and developers are independent, because both the phases are different, guys. So we are not dependent on tester. So these are the differences between agile model and V model, guys. So hope you like it, and please share this video. Thank you for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by error, bug, defect and failure. And this is an important interview question guys. So if you are new to the software testing industry or if you are a fresher and if you go for an interview, so people or interviewer might ask at the time of interview that what do you mean by error, bug, defect and failure and what is the difference among them. So generally, some of the terms we use interchangeably in the software industry. So that's why people are getting confused while answering this question. So let's talk about them in detail. So let's talk about error first. So what is an error? So error is a mistake made by developer while writing the code. Or in other words, I would say error is a programmatical mistakes done by developer while writing the program. So what are the different types of error we may face while writing the program? So we may have syntax error. Let me just write some of them. We may have syntax error. We may have compilation error. Compilation error. We may have runtime error. And we may have logical error. So these are the different types of errors we may face while writing the code guys. So if you talk about syntax, so let's say suppose I want to print something in the code. So suppose I want to print hello and here I have missed the last parenthesis. The second parenthesis I have missed in the code. So that leads to syntax error in the program. If you talk about compilation error, so if we made some mistakes like syntactically, if we made some mistakes in the code or if you have written some wrong statements in the code, so that leads to compilation error in the program. So we are not able to compile our program. If you talk about runtime, so in runtime, what happens is we are successfully able to compile the code, but we are not able to run the code because of runtime error. So what are the examples of runtime error guys? So suppose we divide any number, by 0, that leads to runtime error. Or another example could be suppose we have given reference of any missing file in our code, that leads to runtime error. Or suppose we are calling any invalid statements invalid function in the program. So because of that we will get runtime error. So these are the different examples of runtime error guys. So in runtime error what happens is we are able to compile the code but we are not able to run the code because of runtime errors. And if you talk about logical error guys, so let's say we are developing a software and for some functionalities we have written some logic, and if we made some mistakes there, then we will not get our expected outcomes. So that is logical error. And these two, runtime error and logical error, further leads to defects in the software because we are not getting the expected outcome. So that is defect, which we'll discuss next. So these two leads to defect in the software. So if you talk about so this is all about error guys. If you talk about bug and defect, so these two terms are used interchangeably in software testing guys. Somewhere we are using bug and somewhere we are using defect. It depends on companies to companies and project to project guys. And in some tools we used to say bug and some tools we used to say defect as well. So these two terms are using interchangeably. But what do you mean by bug and defect? So if you see any deviation or difference in the software with respect to expected result and actual result, if you see the difference in actual results and expected results or expected outcomes and actual outcomes, so that is nothing but the bug or defect. So let me just give you an example. Now developer is developing a software guys. Now unit testing is done. Now they have given us the software for testing purpose. They have released a build to this testing team. Now in this software we are testing the login screen. So we have username, password. We have two fields, username, password and submit button. The build came to us for testing that software. So we are testing it. So we are testing the login screen. Here we have username and password, and this Username should take, as per the requirement, it should take alphanumeric values. Alphanumeric values, guys. Alphanumeric values. But while testing it, it is taking only alphabetical values. So that is not as per the expectation. So that is a defect. So what we will do, we will revert to the development team. We will raise a defect. In that case, we will raise a defect because our actual outcome is not as per the expected outcome. So we will raise a defect in defect tool. So that is a defect. Now what about failure? Last term we have here failure. So when we release the software to the end user, when we release the software to client, and if they face some problems, they face some issues like the software is not as per their expectations, so that leads to failure in the software, and end user will use it, or while testing the application they will face some issues or problems, so that leads to failure in the software. Now how do we relate error, bug, defect and failure? So let's say this is error, and bug, as I have discussed earlier, we are using interchangeably these two terms. And here we have failure. Now error leads to the bug and defects in the software. Bug and defect leads to failure. So error, we have spoken about runtime error and logical error. Because of that we got the defect, and because of the defect, let's say suppose we are not able to catch that defect in testing environment, and we have released the software to the customer, that leads to failure in the software. So this is the relationship between error, bug, defect and failure, guys. So this error belongs to developer, this belongs to tester, and this failure belongs to customer. Yeah, so this is the difference between error, bug, defect and failure, guys, and this is how we can relate these terms. And if you like this video, please share it, and if you are new to my channel, then please subscribe it, guys. So this is all for today. Thank you so much. Have a nice day. Bye bye. So guys, if you are new to my channel, then please subscribe it and click the bell icon to get the notification for upcoming videos. Thank you. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about GUI testing, graphical user interface testing, or you can say user interface testing. So this is kind of functional testing, guys. So before I proceed further, let's talk about what you mean by user interface and what you mean by GUI, graphical user interface. So if you talk about UI, so when human being interacts with computer, or any user interact with computer by any medium, let's say we have mouse, keyboard or touch screen, when we interact with the computer, that is nothing but the user interface. So this is the interaction between user and the computer. Whereas GUI, when we interact with computer with the help of graphical elements, let's say we have windows, scroll bars, buttons, radio buttons, images, checkboxes. So these are graphical mediums when we interact with computer, so that is nothing but GUI. So GUI is the part of UI, guys. So GUI is the part of user interface, and UI could be different types, user interface could be different types. We have command line argument as well, we have CLI, command line interface. So when we interact with command line, so that is command line interface. When we interact with menu driven MDI is another interface. We have screen reader as well, screen reader. So these are the different medium we interact with computer. So as I have discussed, GUI is the part of user interface, and you can say in other words, GUI is subset of UI, or you can say UI is superset of GUI. Now what we test as part of GUI testing. So we test the front end, whether all the elements are displayed properly or not as per given in the requirement, whether size of the image is correct or not, whether font is correct or not, whether we are getting the error messages properly it is displayed or not, or color of the fonts or images has good clarity or not. So these are the different testing we the different checklist we do as part of this GUI testing, guys. So we will discuss more about that. Now we can perform GUI testing in two ways. We have manual testing, and manually we can perform it, and through automation tool as well. Let's say we can use Selenium, Eggplant, Cucumber, or Test Complete. There are different tools we can verify UI or graphical user interface. So let's talk about what is GUI, and we'll discuss more about it. So UI testing, also known as GUI, graphical user interface testing, which we have discussed. Verify the page or window displayed or not. So that is the main purpose of GUI testing. So here in GUI testing, we don't care about the functionality. Firstly, we see the whether look and feel are proper or not. All the elements are properly designed as per given in the requirement or not. So that is the main purpose of UI testing or GUI testing. Verifying the object displayed in the page. This usually means testing the visual elements on the application. So whatever elements are given in the web page or application, whether they are as per the requirement or not. So that is the main purpose of UI testing, guys, or GUI testing. Now there is another testing term, usability testing. Usability testing. So do not confuse usability with this GUI testing, because usability testing is different, guys, and GUI testing is different. Basically in UI we mainly talks about the front end testing, and usability talks about the overall functionality of the application, look and feel, how easy to use that application. So that is the main purpose of usability testing. Whereas UI testing, we just see the look and feel, all the elements are there or not. We don't care much about the functionality in UI testing. So that is the difference between usability testing and UI testing. We'll talk more about usability testing going forward as well. Now let's talk more about GUI testing. So why we use user interface testing? So GUI testing is helps to deliver high quality and user friendly software. In the end, you achieve a higher level of user engagement and satisfaction. So that is the main purpose of user interface testing. So let's say if you give any application to the user, and if that is not user friendly, or if all the elements are not properly aligned, or if it is not designed properly as per the requirement given, so definitely the user will not satisfy with the application, so they will reject it, because that is not easy to use, or their look and feel is not proper, so they will reject the application. So this is the main purpose of user interface testing. Whatever the elements are there should be proper, and it should achieve the higher level of user engagement with satisfaction. To ensure the images and other feature are user friendly or not, to ensure that user will use the application further or not. So that is another reason we go for GUI testing. What we verify as part of GUI testing, guys? So in GUI we mainly test the visible design element like button, icon, text box, etc. We check for the fonts are readable or not. Check for the images, their clarity and pixel size and the position of the image. Check for the page if it is easy to understand as per customer point of view. So check for the buttons and boxes. Check boxes are proper and not overlapped. So that is also part of GUI testing. So check for grammar and spelling in the page. Testing of the error messages that are getting displayed on the web page. So these are all different types of Part of GUI testing, guys, we verify all these stuff while doing the GUI testing. Testing the different sections of the screen. So let's say we have a web page and we have different menus in the web page. So we will verify all the sections are properly aligned and all the sections are properly defined as part of requirements or not, whether they are properly aligned or whatever contains each section has, whether they are properly given as part of properly designed or not as part of requirements. So that is what we verify as part of GUI testing. So what are the advantages of UI or GUI testing, guys? So it helps validate the compliance of various icons and elements with their design specifications. The sooner we can catch offending elements in our UI, the quicker they can be resolved. So offers developers and tester ease of use and learnings. Efficiently reduces the number of risks towards the end of development life cycle. So these are the different advantages of UI or GUI testing, guys. Now let me just show you. So this is Orange HRM application, guys. So as part of GUI, we'll verify the logo is proper or not on this. This is the Orange HRM logo. So whether this is properly aligned and properly the size of the pixel of this image is given is designed properly or not. And here we have username, password fields, and if you click on login, we should verify this user the error message properly displayed or not as per the given in the requirement. We check this link whether it is working. When we click on this forget password link, it should redirect to correct page or not. And this is again Orange HRM logo, and here you can see HR for all. So all the elements, all the UI related things, front end, whatever is displayed on the web page or application, we verify all as part of GUI testing. So this is all for today, guys. So if you have any questions, then please write in the comment box, and please like this video, share it, and if you're new to my channel, then please subscribe it. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about error guessing testing technique, and this is a test design technique in software testing industry. We using this technique we derive the test cases or write the test cases. So what exactly error guessing testing technique? So it is an experience based testing technique, guys, where the test analyst uses his or her experience to guess the problematic areas of the application, and this technique necessarily requires skilled and experienced testers. So the person who has very good experience and who has good knowledge on the application can derive this kind of test cases and perform this kind of testing. So what exactly we do as part of this testing technique? How do we do the testing? So basically we perform invalid operation on the application, and we expect the meaningful message when we perform the invalid operations. So this is kind of when we perform invalid operations, so we expect the meaningful message from the system. So how do we do? Let me give an example. So let's say we are testing a website, guys, and there is a field to upload a file, and where we another field we have to browse the file from the computer and upload the file. So here the path of the file will come. Now as a formal testing approach, how do we do this? So we will simply upload a file, valid file, and we'll see whether it is getting uploaded properly or not. So that is a basic testing we'll do as part of normal formal approach. Now what we do as part of this testing process? So what we do, we'll upload a blank file. So we'll upload the blank file and verify the message. It should give the proper error message like the file is blank or file is empty or something. So it should give a proper message. It should not give any exception over here or any invalid message. Now another scenario could be, another test cases, we can upload a file with maximum limit, which has maximum number of records over here, and we upload here. Let's say this field will take only 500 records, and here we'll upload with 510 or 550 like that, and we'll see the error message. We should get the proper error message that maximum limit exceeded or something. Now another could be invalid format, file with invalid format. Let's say our headers are invalid, or we have some invalid records in the file. When we upload this file, we should get a proper message that file is invalid, or headers are incorrect, or incorrect format. So these are the different scenarios we do as part of this error guessing testing technique, guys. So we can derive number of test cases using this testing. Basically, we perform invalid operation and we see the error message. We should get the expected error message, like meaningful error message. Now, why do we do this testing? Why do we do error guessing testing? So there could be a couple of reasons. Let's say, so we have different test design techniques, guys. We have boundary value analysis, we have equivalence class partitioning, we have state transition. So these are the different test design techniques. So we'll cover, I'll talk about them in coming videos. So when we are not able to cover different test cases using as part of this test design techniques, then we go for this. Then we cover those test cases using this error guessing testing technique, guys. And another reason could be, in formal testing approach, we cannot cover all the test scenarios or test cases. And using this error guessing testing technique, we can cover maximum number of, we can give a proper coverage of test cases. We can thoroughly write the test cases as part of this test design technique. Now let's talk more about error guessing testing technique, guys, in next slide. So testing is conducted by performing invalid operations, which we have discussed, and validate the error message is displaying or not. The error message should be meaningful to understand. So this is the point which we have discussed. It is a type of testing method in which prior experience in testing is used to uncover the defects in software. It is an experience-based testing technique in which the tester uses his or her past experience to intuition to gauge the problematic areas of software application. So this is what we have discussed. So there are different functionalities in whenever we do testing in any application, guys. So when we have experienced user, we can explore more the more problematic areas of the application. So this is the main purpose of this error guessing testing. So what are the examples? So we need to test a program which reads a file. What happens if the program gets a file which is empty or the file does not exist? And enter blank space into text fields. Use maximum limits of files to be uploaded. So these are the different examples, some of them which we have discussed at the beginning of this video. So what are the advantages of error guessing testing, guys? So it uncovers those defects which would otherwise not be possible to find out through formal testing approach. So this is the biggest advantage of error guessing testing. To expand the test coverage, it does not follow any specific rules. So these are the different advantages of doing error guessing testing. What are the disadvantages? So only experienced testers can perform this testing. You can't get it done by freshers. So this is the kind of disadvantage. It also cannot guarantee that the software has reached the expected quality benchmark. So this is all for today, guys. This is about error guessing. So thank you for watching. Have a nice day. Bye bye. guys, if you are new to my channel, then please subscribe it and click the bell icon to get the notification for upcoming videos. Thank you. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what we mean by smoke testing, what is sanity testing, and what is the difference between them. So this is an important interview question, guys. So many people are getting confused, like what do you mean by smoke, what is sanity testing, and what is the difference. So today we'll discuss more on smoke testing, sanity testing, why do we do smoke, why do we do sanity, and what is the difference between them. So before I start from the next slide, more about smoke sanity testing, let me just give you an example, guys, so that you can understand better, real world example, so that you can understand better and relate better and understand what you mean by smoke testing and what is sanity testing. So please concentrate on this example so that you can easily understand what you mean by smoke and sanity testing. So take an example, we are working for TV manufacturing company, and right now we are developing a new model of the TV. We are manufacturing a new model of the TV. And let's say 25% of the manufacturing or 25% of the features we have implemented for this particular model. Now before we go for the further development, like 75% are remaining, so before we go for the further development, we'll ask the tester to test those new features, those 25 features which we have implemented. So we'll send this to the testing team to test these 25% of the features. So they have set of test cases for those 25 features, guys. The testers have test cases for those 25 features of the features. They have written some test cases. Now before they go for the testing of those new features, those 25% of the features, what they're gonna do, they will test the critical functionality of this TV first, because this is under development, like build is not stable, so they will go for critical functionality testing first. The high level testing they will do, they will perform first. So what they're gonna do, they will plug in the cable, the power cable of the TV, and they will switch it on, and they will make sure that TV is getting switched on properly or not after switching it on. Now another high level functionality should be like whether after switching it on, whether the screen is coming properly or not. So we cannot expect like because since 25% features are implemented, but still we will test some critical functionality. Another could be we will with if the remote features have been implemented, so we will test with the help of remote as well, whether we are able to switch on the TV or not with the help of remote. So these are some of the test cases as part of critical functionalities, guys, we will execute. So this is nothing but the smoke test. Now just assume that in case while plugging the power cable of the TV and when we switch it on, if something comes, if those test cases are passed, those critical functionalities, then that's fine. Like we can go ahead and test those 25% features which we have already written the test cases. Correct, we can execute easily those 25% of the test cases. But just imagine in case if while testing the critical functionality, let's say we have plugged in the power cable and we'll switch on the TV, and let's say some smoke is coming out of the TV. So what happens, we will verify, definitely the TV will not get we will just stop it, and we will revert this build to the development team, because some smoke is coming out of the TV when we switch on the TV. So this build is not sufficient to go ahead for the further testing. So this is smoke testing, guys. So hope it is clear. Like this is performed on unstable build, mostly unstable build, to verify the critical functionalities are working as expected or not. Critical functionalities testing at high level, or we can do high level testing on the critical functionalities, and we perform on unstable build. Now take an example of so this is smoke testing. Now I'll give the same example, guys, with the help of same TV. Let's say we have implemented 100% of the features and this TV is rolled out into the market, and some user have already bought this, and let's say one user reported that his screen is not working as expected, like screen is not coming when we switch on the TV. So that is the issue that one user has reported. Now it comes to the, since it is in warranty period, so it comes to the customer service. Now they will do the bug fixes for this particular issue. So what we'll do, so what we're gonna do before we do the further regression testing or we do the complete testing of this TV, what we're gonna do is we'll quickly check whether that bug fix is working fine or not, and we'll test the related functionalities as well, related functionalities of the TV, like after switching it on, whether the screen is coming properly or not, and then color and voice is coming properly or not. So these are some test cases we will execute as part of our testing. So this is nothing but sanity testing, guys. Sanity testing. So we will execute some like if new features have been implemented or any bug fixes are done, then we go for the quick testing for the bug fixes or new functionalities, and related testing will perform. So that is nothing but the sanity testing. And sanity testing is the part of, or you can say subset of, it is subset of regression testing, guys. Regression testing, and this is done mostly on stable build. So since we are doing the bug fixes, quickly checking the bug fixes whether they are working fine or not, and related functionality, so that's why it is called subset of regression test cases. And smoke tests are called subset of acceptance test cases. Acceptance test cases, because this build is under development, and this smoke testing mainly performs on unstable build, so we cannot go ahead with the further testing, so we will reject this build, correct? So this is kind of rejection, correct? We cannot accept. If everything is working fine like critical functionality, then we can accept this build, and we can go for the further testing of those 25 features which are implemented. But in case if smoke is coming out, like if the critical functionalities are not working, then we can reject this build and revert it to the development team. So the same things happen in software testing also, guys. Smoke testing and sanity testing and smoke testing are scripted, mainly scripted, because these are the part of acceptance test cases. Like it is subset, we will retrieve some of the test cases from acceptance test plan, acceptance test cases, and mostly it is automated, or you can say scripted. And sanity tests are not automated or scripted. We'll randomly check some quick functionality check, and we will do some related testing. So this is about smoke and sanity testing, guys. Hope it is clear. So from the next slide, let's talk more about smoke and sanity. We'll discuss some theoretical stuff about smoke and sanity testing, guys. So smoke test is also known as build verification, which we have discussed, and or build acceptance testing. Smoke testing is preliminary check of the software after build and before a release, and it is type of acceptance testing, guys, and provide an initial check that a new software build and its critical functionality are stable or not. So that is the main purpose of smoke testing. Smoke testing is group of tests that are executed to verify if critical functionalities of particular build are working fine as expected or not. So these are all points are related to smoke testing. You can just go through it and understand what you mean by smoke testing. How do we do smoke testing? So the development team deploys the build in QA. We will need to perform setup steps, then the subset of test cases are taken, which we have discussed because it is part of a subset of acceptance test cases, and then testers run these test cases on the build. The QA team tests the application against the critical functionalities. These series of test cases are designed to expose errors that are in the build. After the smoke test, we will need to clean up. This might include stopping server. So this is kind of best practices as part of smoke testing. Deleting files or emptying database tables. This could also be done before the initial setup to ensure that the environment is clean before any tests are started. So this is what about smoke testing, guys. The question comes like why we perform smoke testing. So smoke testing is done whenever the new functionalities of the software are developed and integrated with the existing application. New functionalities means, let's say if it is under development and I have given an example of 25% of the features have been implemented, the TV example. So this is when the reason we go for smoke testing when the build is unstable. It ensures that all critical functionalities are working correctly. It reveals simple failures but severe enough to reject a prospective software release. It helps to find issues in the early phase of testing. So this is an example of smoke testing, guys. If we talk about in our software testing, so a web page of insurance, we have insurance website, add a claim status page. So we have a claim status page. The tester would apply smoke test to verify that the existing builds work on fundamental levels, such as user can log in or not, and then navigate to claim status page or not, and retrieve the status report of a specific claim without the app crashing. So we will log in into the application. We'll make sure that we are able to log in the application and we are able to go to that claim status page, whether we are able to retrieve the status report or not. So that is part of smoke testing. Now let's talk about sanity testing. So sanity testing is subset of regression testing, which we have discussed at the beginning of this video. After receiving the software build, sanity testing is the first test to ensure that the code changes introduced are working as expected. This is also we have spoken about when I have talked about the TV example. If any defect is found in test, we can reject the build and stop the testing. After sanity test complete, the status either pass or fail has to be reported to the developers. The test is conducted for very short period of time, let's say 15 to 30 minutes. How to do sanity testing? So unlike other types of testing, sanity does not need a handful of techniques. So since this is unscripted, so we do kind of speedy and quick test. We do not need to write test cases for sanity testing because you want to perform quick and speedy testing, guys. The first thing in sanity testing is to identify new functionalities, changes, or any bug fixes, whether they are working fine or not. At very initial level, not we won't go to the deep level. Then we will check the newly implemented changes if they are working fine or not. And at last, we will randomly check a few related functionalities to see if they are also working as expected or not. If all good, then release can be passed for further testing, or if any one functionality is not working as per requirement or got failed, we can reject the build and stop the testing. So why we perform sanity testing? So it is known as surface level testing as well. Just remember this name, guys, surface level testing as well. This must be done to quickly evaluate quality of regressions made to the software. Surface level means we just do kind of basic test. We execute quickly and perform the speedy testing, or quality of regression made to the software regressions. Sanity is done to determine if new module additions to an existing software build are stable enough to pass to the next level testing or not. If sanity test is passed, we can continue further testing. If it is failed, we can reject the build and stop the testing so developer fix the changes as soon as possible. So what is the example of sanity testing? So here I have given an example as well. So a web page for loan provider returns a 404 error for personal loan page. So in loan application, we have a personal loan page where we got 404. The developer fixed the issue and submit the build for testing. The QA professional performs a sanity test to determine whether the basic functionality and navigation for that specific page is working as intended or not. So that is the main purpose of sanity testing. Now let's talk about the difference between smoke and sanity testing, guys. So smoke testing is performed on ascertain that the critical functionalities of the program are working fine. Sanity testing is done at random to verify that each functionality is working as expected. Because this is unscripted, so we'll do random testing and make sure that the functionalities are working fine or not. Smoke testing is usually documented and scripted. Sanity testing is not documented and it is not scripted, and it's unscripted. Smoke testing has a goal to verify stability, whereas sanity testing has a goal to verify rationality, or you can say the quality of the software. Testing is done by both developers and testers. So sometimes it is performed by developer as well. So sanity testing is done only by testers, and this is done by both developers and testers. Smoke testing is subset of acceptance testing, guys, which we have discussed. Sanity testing is subset of regression testing. Testing is wide and high level testing. Testing is wide and shallow testing. It is well elaborate and planned testing. This is not a planned test and is done only when there is a shortage of time. Smoke testing exercises the entire system from end to end. Sanity testing exercises only the particular component of the entire system. So here we do the entire system, the critical functionalities of the entire system, and here sanity testing exercises only the particular component of the entire system where the new features is implemented or bug fixes are done and related functionalities. So that is part of sanity. So these are the difference between smoke and sanity, guys, and hope you like this video. Share it, and if you have some doubts, then please write on the comment box. I will reply as soon as possible. So thank you guys for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about the categories of functional testing. So we have two types. We have positive testing and we have negative testing. So let's talk about what we mean by positive testing, what is negative testing, and we will see the difference between them. So what exactly positive and negative testing, guys? So let me just explain you with the help of an example so that you can relate better, you can understand better about what you mean by positive testing and negative testing. So let's say we are testing an application which when we perform with valid conditions, when we test this application with valid conditions and valid values. So this is nothing but the positive testing, guys, in simple words. And when we perform with invalid conditions and invalid values, this is nothing but negative test cases or negative testing. So I'll talk more about like what you mean by valid conditions and valid values, invalid conditions, invalid values when I provide the examples. So this is a simple definition of positive and negative testing. Now let me give you an example so that you can understand better. So let's say we are testing a login screen of a web page, login screen. So it will take username, it has username, password and submit button. Now let's say as per the requirement, the developer developed this username field which takes alphanumeric values, and it takes at the rate as well, because we can provide the username email ID as username. So it will take alphanumeric values plus at the rate as a special symbol. Now what are the positive test cases for this input field, right? This username field. So when we enter 1 2 1 3 4 5 6, so these are the positive test cases. When we provide a b c d, so this is positive test cases. When we provide x xyz at the rate xyz at the rate 1 2 3 4, so this is also positive test cases for this input field. Now this won't take another special character like hash when we include like let's say abc hash 321. So this is kind of negative test scenario or negative test cases for this particular field, username field. So this is positive and negative testing, guys. Now let me give another example. Let's say we have field, phone number field, cell phone number field. Now this should take 10 digits, right? Now if you provide 10 digits, so that means it is positive test cases, right? Positive test cases. Now if you provide like 11 digit, ideally it should not take 11 digits because this is a cell phone number. So this is negative test cases, negative test case. Now if you provide, let's say we have, if you provide like some characters over here like A, B, C, D, X, Y, Z or something. So this is again negative test cases for this one. Negative test case for this cell phone number, because ideally it should not take alphanumeric values. It should take only numerical values that should be like 10 digits only. Now, so this is kind of examples of positive and negative testing, guys. Now let me just explain one more example so that you can understand better. So let's say we are working for this application. Let's say this is loan application. Now we have two types of products over here. We have one is let's say personal loan, and this is home loan. Right now the interest rate, for take an example, for personal loan it is like, let's say 12%, and for home loan let's say it is 8%. Now company has imposed new interest rates on personal loan. Let's say they have increased the personal loan from 12 to 14%. Now when we test this application, guys, so when we create the personal loan as part of testing of this loan process system, right? So when we test this personal loan, we'll make sure that 14% is imposed on personal loans when we test this application. And at the same time, we will test, after testing this personal loan, we should also test the home loan as well later on for negative testing. So that this 14% should not apply over here, because there is no change on this home loan interest rate. So this is kind of valid condition. So this is valid condition, guys, so which we have spoken about at the beginning, valid condition, and this is invalid condition when we test for home loan, because changes are applied to this personal loan only and it should not impact the home loan. So that is negative scenario. So these are the examples of positive and negative testing, guys. So yeah, so let me just take you to the next slide from where we'll discuss now another thing, like a couple of techniques we can use when we test positive and negative testing. Let's say we have a couple of techniques like boundary value analysis, and we have equivalence class partitioning. However, I will discuss more in a separate video about the boundary value analysis and equivalence class partitioning, guys. So let me just give an example so that because we apply boundary values and equivalence class partitioning as part of this positive negative testing when we derive the test cases. Now these are the test design techniques. So using these we derive the test cases. Now let's say any input field taking number from 0 to 10. So what are the boundary values here? So we have -1, we have 0, and 1 plus 1, and here we have 9, 10, and 11. So these are the values at boundary, correct? These are the values at boundary. 2 points, we have this starting point and this is the end point, boundary values. So -1, 0, and 1 are the values here, and 9, 10, 11. So what are the negative scenarios here? So -1 is the negative scenario, negative test case, and here 11 is the negative test case. It should not take -1 or 11, and 0 and 1 are the positive test cases. 9 and 10 here are positive test cases. So this is about boundary value analysis, guys, which we apply when we test positive, when we do positive and negative testing. Now let's say equivalence class partitioning. So I'll take the same example like 0 and 10. It is this is the starting point and this is the end, 0 and 10. Now let's say we have divided that into 4 parts. So we have -10, we have -5, we have 0 and 10, or -10, -5, 0 and 10. Now we will test from these partitions. So we have divided into 4 parts. So let's say if we test like here -6, and when we test one value from here, let's say -2, and when we test some values here, 7. So this is positive test case, these two are negative, -6 and -2 are negative test cases here. Sorry, this is 3 partition, right? This is first and this is second, and here you can divide 0 to 5 and 5 to 10. So I'll take one value from here, 5 to 10 1, and 0 to 5 I'll take 3. So 3 and 7 will be the positive test cases, whereas -6 and -2 are negative test cases as part of this equivalence class partitioning, guys. However, we'll discuss more as I have discussed, as I have spoken about boundary values and equivalence class partitioning. We'll discuss in a separate video about those test design techniques. So let's talk more about positive and negative testing. So what exactly positive testing? As we have discussed, positive testing is type of testing which is performed on a software application by providing the valid data as an input, guys. This is what we have spoken about. Valid data as an input. So when we provide the valid data for any input, so that is nothing but the positive testing we are performing for that application, for that input field. Let's recap some more points. Positive testing is a type of software testing that is performed by assuming everything will be as expected. So since we are providing the valid data, so we can expect the expected outcome, correct? We can expect the, assume that we can expect the positive outcomes. It is performed with the assumption that only valid and relevant things will occur as part of this positive testing. In this type, testing performed within the boundaries, and this testing checks the product application is behaving as per the specification document with the valid set of test data. So this is what we have discussed, guys, as per the boundary values 0 to 10, 0 to 10. So when we test for 1 or when we test for 9, these are within the limits. So that is what we do as part of this positive testing. What is negative testing? So negative testing is a method of testing an application or system that ensures that the plot of the application is according to the requirements. According to the requirements means the positive testing, and can handle the unwanted input and user behavior. So unwanted input is invalid values, and user behavior is nothing but the invalid conditions. It is also known as error path testing or failure testing, and it helps us to identify more bugs and enhance the quality of the software application under test. So it is very important, guys, to perform negative testing. So because our intention as a tester should be to break the system. Like when we test the application, so we should think about all the permutation and combination when we test any application. So that's that kind of thought we should have. So negative testing is very, very important. So negative testing uses invalid input data or undesired user behaviors to check for unexpected system errors. So it's not about when we provide the values, it should also we should also test for undesired user behavior, which we have discussed when I have given the example of loan application. So we should also see the negative behaviors, like what could be the negative scenarios for any particular application. We can say that the negative testing is executing by keeping the negative point of view in simple terms. Now let's talk about what are the differences between positive and negative testing, guys. So positive testing means testing the application or system with valid data. Negative testing means testing the application or system with invalid data. It is always done to verify the known set of test conditions. It is always done to break the project or product with unknown set of test conditions. It ensures software is normal. It ensures 100% defect free software. So this negative testing means we'll check the quality of the software, so that it takes all the positive negative scenarios, like this application is capable enough to handle all kind of scenarios. So that is the main intention when we do negative testing. It doesn't cover all possible cases. So since we are testing within the limits, so that's why it does not cover all possible cases. It covers all possible cases and scenarios when we do negative testing, guys. So it can be performed by people having less knowledge. it can be performed by professionals. Why I have mentioned like having less knowledge, positive testing, because whenever we test the application, so let's say we are testing any application and user will provide some documentation, right? We'll get some documentation for the project, like customer requirement specification or business requirement. So they will provide like what should be the expected like what are the input values and what should be the expected behavior. So normal tester will simply test the positive test scenarios or positive test cases. They will think about the positive scenarios and write the positive test cases only. But we should consider the negative test cases, negative impact of the application, like when we provide the invalid data or when I perform the invalid operations, or when I do negative kind of when I derive the negative test scenarios, how the system will behave when I provide the negative test conditions, how the system will behave. So that is what should be the expected error. So we should always think about the negative testing perspective. Positive testing is implemented only for the expected conditions. Negative testing is implemented only for unexpected conditions. It is less important as compared to negative testing. So this is I have spoken about, guys. So it is more important as compared to positive testing. Positive testing can be implemented on every application. Negative testing can be implemented when the possibilities of unpredicted conditions. So we cannot apply always negative testing in every applications or every situation. So there are certain things we when we go for negative testing. So this is all for today, guys, about positive and negative testing. So if you have some questions or anything, if you have any doubts, then please write in the comment box, and please like this video, share it, and if you are new to my channel, then please subscribe it and click the bell icon to get the notification for upcoming interesting videos. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by exploratory testing, why do we do exploratory testing, and what are the advantages and disadvantages of exploratory testing. So let's talk about what do you mean by exploratory testing first, guys. So when we test any application, based on our skills and experience or knowledge, when we test any application based on our skills and experience, is nothing but the exploratory testing, when we explore the application based on skills and knowledge. And here we don't create the test cases in advance, unlike the formal testing approach where we go through the requirement, we write down the test cases and we execute the test cases. But here what happens is we will just explore the application on the fly. So here we may note down some scenarios, or we note down some ideas while like what to test when we go for exploratory testing, guys. So basically it is the process of learning test design and test execution. So it is the continuous simultaneous process of learning the application, test design, and test execution. Test design is not like the formal test design where we write the test cases. Here we may note down some of the scenarios, or we may just think about some of the scenarios in what to test as part of exploratory testing. So this is the simultaneous process of learning, test design, and test execution. So this is the simple definition of exploratory testing, guys. So here we don't create the test cases in advance. We will just explore the application on the fly. Now, if you see in formal testing approach, what happens is we will do structured way of testing. So we'll do one by one all these steps, right? So first we go through the requirement, we do the test design, and we'll execute the test cases. And there is a structured way of testing the applications, like application one, sorry, functionality one, and then we go for functionality two, functionality three, and functionality four. So we'll do step-by-step testing. We'll have completed a testing of functionality 1, 2, 3, and 4 one by one. But what happens in exploratory testing? So there is no particular order of doing the things or testing the application. So we'll just randomly will test the application like this. So there is no particular order. We just perform the random testing as part of exploratory testing. Now question arises here is why we go for exploratory testing, guys. And exploratory testing mainly used in agile methodology. Okay, now let's talk about like why we go for exploratory testing. So when we have missing requirement in the application, okay, let's say we are going to implement some functionality and requirement is missing. So in that case we will go for exploratory testing, because we have when we know about the application, so we can just explore the application based on the previous knowledge, previous experience. We can just explore the application. So that is one of the reasons we go for exploratory testing. So sometimes what happens is in agile methodology, because since we have frequent release, we don't get sometimes requirement from the business team, so we can go for exploratory testing. Now the second reason is when we have experienced tester in our team, experienced testers. So experienced tester already knows about the application very well because of the experience. So we can just go about the exploratory testing when we have experienced tester in our team. Third reason could be we choose exploratory testing is when we have deployment in when deployment cycle is very near. Okay, in that case we go for when deployment cycle is near. When deployment is near, we go for exploratory testing, because we don't have much time to go through the requirement, design the test cases and execute the test cases. So in that case we just explore the application and we perform the exploratory testing. Fourth reason could be when we have new testers in our team, new testers in the team. So we can just ask the new testers to just explore the application, so they will just go through the application and perform the exploratory testing. Another reason could be when we have critical application. When we have critical application, so many people doesn't know in our team, like because since this is a critical application, so we can just go for the exploratory testing and learn the application by performing exploratory testing. So these are the some of the reasons, guys, we go for exploratory testing. Now from the next slide onwards, we will just recap the things what we have discussed so far. I have noted down some of the points, some of the notes, so that might useful for you guys. So we and whatever we have discussed, we can just recap. So let's get started. So what is exploratory testing, guys? So exploratory testing is an approach to software testing that is concisely described as simultaneous learning. This is what we have discussed: learning, test design and test execution. Exploratory testing allows you to think outside of the box and come up with the scenarios that might not be covered in test case. Correct? So when we explore the application, we may think about the like outside of the box, correct, which might not covered as part of the normal testing approach. In simple word, it is a type of software testing where test cases are not created in advance, but testers check the system on the fly. This is what we have discussed when we talked about exploratory testing definition. It focuses on discovery and relies on the guidance of the individual testers to uncover defects that are not easily covered in the scope of other tests. So that is the biggest advantage of performing exploratory testing. It doesn't restrict the tester to predefined set of instructions. So we don't have hard and fast rule to perform exploratory testing. This is a test approach that can apply to any test technique at any stage in the development process. So at any level, we can perform exploratory testing. So why we should go for exploratory testing, guys. So we have discussed 5 points. So this is addition of those 5 points. So in many software cycle, an early iteration is required. When teams don't have much time to structure the test, exploratory testing is quite helpful in that scenario. So this is what we have discussed. So let's say we have a very early cycle in the software development life cycle when we have release is very near, so we can go for exploratory testing. When testing mission critical applications, exploratory testing ensures don't miss edge cases that lead to critical quality failures. It is especially useful to find new test scenarios to enhance the test coverage. It helps review the quality of product from user perspective. So these are the some of the reasons we go for exploratory testing, guys. Now let's talk about some of the advantages of exploratory testing. It requires limited preparation, which allows you to save time and quickly jump to the execution. So we may just note down some of the scenarios. We may just think about some of the scenarios about the exploratory testing. So it saves a lot of time and we can directly jump to the execution. In exploratory testing, you can generate your own test scenarios on fly, which will allow you to dive deeper into the functional aspect of the product. This test is much less time consuming. It allows you to think outside of the box and come up with the scenarios that might not covered in a test case, which we have discussed earlier. This allows the tester to find defects that are beyond the scope of the limited scenarios. This is one of the biggest advantage of exploratory testing, guys. This is an approach that is most useful when there are no or poor specification and when time is severely limited. So in that case, like missing requirement or requirement is not understandable, so in that case exploratory testing is very useful. What are the disadvantages of exploratory testing? So in exploratory testing, once testing is performed, it is not reviewed. So since we don't have proper documentation about the for exploratory testing, so we cannot review the what we have done as part of exploratory testing. Difficult to conduct, difficult to document each procedure. It is difficult to reproduce the failure. So this is one of the biggest disadvantage of exploratory testing. So we don't know like how we proceed and how we uh, produce the reproduce the failure, like steps to reproduce the failure in exploratory testing. Like we sometimes we forget like how we got that issue. It is not easy to say which tests were already performed, limited by testers skill set. So it depends on tester to tester, guys, how they execute the how they explore the application based on skills, knowledge and experience. Reporting is difficult without planned script. So these are the some of the disadvantages, guys. So this is all about today about exploratory testing. So if you like this video, then please share it, and if you're new to my channel, then please subscribe the channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by ad hoc testing, why we perform ad hoc testing, what are the advantages and disadvantages of ad hoc testing, and at last we'll talk about what is the difference between ad hoc testing and exploratory testing. So let's get started. So when we test any application, guys, so when we test any application without planning, without any proper planning or documentation, without documentation, that is nothing but ad hoc testing. And since we don't create any plan or we don't go for any documentation, so this is also called ad hoc testing, is also called informal testing. Informal testing, or you can say unstructured type of software testing. And in ad hoc testing, we should have to perform ad hoc testing, we should have some knowledge about the application, guys. We should have prior knowledge about the application, then only we can do ad hoc testing. So what happens in ad hoc testing is, let's say we have different functionalities in our application. We have different components in our application. So randomly we'll check the functionalities of those components. So that is kind of ad hoc testing. So when we perform ad hoc testing, so generally after once we execute the formal test cases, when we done the formal testing, let's say we have executed some test cases about the application, and still if we left some time in testing, then we'll go for ad hoc testing to learn more about the application. So this is the reason we perform ad hoc testing, to uncover some of the important defects in application. Then we go for ad hoc testing. Now you might have question like, what is the difference between ad hoc testing and exploratory testing? So we have seen in previous videos, we already spoken about exploratory testing. So what happens, guys, as part of exploratory testing, we'll explore the application. So we don't have any knowledge about the application. We will just explore as part of exploratory testing, and we'll create some kind of test plan. What needs to be executed as part of exploratory testing, some kind of plan, and then we'll learn the application. Learn the application. So this is these all processes are simultaneous in nature, right? Simultaneously we'll explore the application, we'll create some documentation for exploratory testing, like what needs to be tested, and we'll learn the application simultaneously. So that is exploratory testing. But here in what happens in ad hoc testing is we should have prior knowledge about the application. Here we'll explore the application and learn the application as part of exploratory testing. Exploratory testing. So this is the basic difference between ad hoc testing and exploratory testing, guys. We'll talk more about more differences about ad hoc testing and exploratory testing coming slides. So let's move on to the next slide, guys, where we'll discuss some definition about the ad hoc testing, and we'll see why we perform ad hoc testing and advantages and disadvantages, and at last we'll talk about the difference between ad hoc testing and exploratory testing. So when a software testing is performed without proper planning, so this is what we have discussed, and documentation, without proper planning and documentation, it is said to be ad hoc testing. Ad hoc testing is an informal or unstructured software testing type that aims to break the testing process in order to find possible defects. So that is the main aim of the ad hoc testing. Ad hoc testing is performed without a plan of action, and any actions taken are not typically documented. Ad hoc testing implies learning of the software before its testing. Ad hoc testing is done by executing the random scenarios, which we have spoken about, and it is form of negative testing, which ensures the perfection of the testing. So these are all points about the ad hoc testing, guys. Now question comes like, why we go for ad hoc testing? Why do we do ad hoc testing? So the main aim of ad hoc testing is to find any defects through random checking. Randomly we'll verify the application and try to find out some defects. These can uncover very specific and interesting defects, which are easily missed when we use when using other methods. When we perform the formal testing approach, when we miss some of the defects, then that can be uncovered as part of ad hoc testing. Ad hoc testing usually performed after the formal test execution. So this is what we have discussed. Ad hoc testing will be effective only if the tester has in-depth understanding about the system under test. So what we have spoken about, you should have knowledge about the application, then you can perform ad hoc testing. Whereas in exploratory testing, we should it's not mandatory to know about the application. We'll just explore the application as part of exploratory testing. What are the advantages and disadvantages of ad hoc testing? So let's talk about advantages first. So this method is very simple and can be performed without any training. It can be used when time period is limited. This can uncover very specific and interesting defects, which are easily missed when using other methods. So about this point, it can be used when time period is limited. Let's say we have very limited time period to go about the production. We have already executed the formal testing. Now we have some time left for testing. Then we can go for the ad hoc testing to uncover some of the defects which are missed during the formal testing approach. This testing can be performed anytime during software development life cycle process. This can also be performed at any time in software development life cycle process, guys. What are the disadvantages? So this method is not recommended when more scientific methods are available. The actual testing process is not documented since it does not follow a particular test case. It is difficult for the test to regenerate an error in ad hoc testing. So these are the some kind of disadvantages about the ad hoc testing. Now let's talk about what is the difference between exploratory testing and ad hoc testing, guys. So ad hoc testing implies learning of the software before its testing. Exploratory testing, you learn and test the software simultaneously. I've discussed. Documentation is not a basic need of this type of testing. The QA team always attains the testing without a specific documentation. And documentation is mandatory here. Some kind of documentation will create as part of exploratory testing to assure that qualities and necessary to documents the detail of this testing. Ad hoc testing is about the perfection of the testing, and exploratory testing is more about the learning of the application. So here we'll make sure that we cover all kind of test cases as part of ad hoc testing, like we test all kind of functionalities in any application. So this is kind of perfection of the testing when we perform ad hoc testing. This is more about the learning of the application because we don't have any knowledge about the application as part of exploratory testing. Ad hoc testing helps to find innovative ideas from the research. It helps to develop the application to get more ideas about the application. Ad hoc testing is technique of testing an application that these provides a significant role in the software production. This is an approach of testing that combines the learning test results and creates a new solution. It mostly works on the business concern and increases the knowledge about the application. Perform ad hoc testing. Different scenarios when we test as part of ad hoc testing. It categorizes the problems and compare them from the problems found in the past. This helps to reduce the time consumption. Ad hoc testing is not important to execute by an expert software testing, and this is always needed to be done by expert. It works on negative testing mostly, and this testing works on positive testing niche. It does not work with the workflow. Exploratory testing works with the workflow from beginning of the testing. It starts with primary objectives and collects proper information about them. So basically, when we perform ad hoc testing, so randomly we will check the application, right? So, but in as part of exploratory testing, we learn the application. So that is kind of step-by-step process. However, we'll do some kind of random testing as part of exploratory testing as well. By exploring the application, we'll just learn the workflow, right? So this is all about today, guys. So about ad hoc testing, what do you mean by ad hoc testing, and the difference between ad hoc testing and exploratory testing. So thank you for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by retesting, why we perform retesting, and we'll talk about regression testing, and we'll also talk about what are the advantages and disadvantages of retesting and regression testing, and at last we'll talk about what is the difference between regression testing and retesting. And so this is an important interview question, guys, and important topic, so please concentrate more on this topic. So let's talk about retesting first. What do you mean by retesting? So to test something again is called retesting in simple words. Or if you talk about the definition, so testing the same functionality with different combination of input data is called retesting. So let's understand with the help of an example, guys. So let's say this is our application. Let's say this is e-commerce application. And here we have different modules, guys. This is module A, this is module B, this is module C, and this is module D. Now in this particular module A, we have different features. Let's say user registration, we have login and some other features as well. And we have written some test cases for user registration. We have written some test cases for login page, and we have written some test cases for some other features. So these are the complete set of test cases for module A. Now take an example. While executing the user registration test cases, we got the defect. We are not able to register the user. So what we will do, we will raise the defect to the development team, and after the fix, we will re-execute our test cases for this user registration page. So that is nothing but we are doing the retesting. We are re-executing our test cases. So that is retesting, guys. So to make sure that defect is working fine for that particular page, that user registration page. So this is retesting, right? So sometimes we perform with different set of test data. We re-execute with different set of test data to make sure that defect is perfectly fine or not. So that is retesting. Now there are two ways we can perform retesting. So here you can see we have re-executed our test cases for the user registration page. So since we have login page as well, so we got the issue in user registration while registering the user. So we'll make sure that user is able to log into the functionality or not. So we will test the login functionality as well. So sometimes we do on that particular feature, we'll re-execute the test cases for particular feature, and sometimes we'll re-execute the test cases for entire module in retesting. So that is retesting, guys. So this is all about retesting. Now let's talk about what you mean by regression testing. Let me take another example. So here we have another application. Here we have module A, module B, module C, module D, and module E. Now what happens in regression testing? So let's say we got issue in this module C. We got some issue and it is fixed by the development team, and we re-execute our test cases. So that is retesting on this particular module C. But this module C is dependent on some other module. Let's say C is dependent on B, A is dependent on C, C is dependent on D, and D is dependent on E. So module C is dependent on some other modules, or some other modules are dependent on C. So what happens is, as part of regression testing, since we got the issue here, so we will make sure that other part of the application does not get impacted because of this change. So this is not about just got the issue in module C. Sometimes what happens is, if some features has been added, some feature has been added in this module C, in that case also we need to make sure the other part of the application does not get impacted. So other related functionality. So that is nothing but regression testing, guys. So in regression testing, we have certain suite of test cases we have to execute on which combines which is the combination of all the modules. So we have suite of test cases which combine the test cases from the subset of test cases from all the modules, all the interrelated modules. So we will execute all those test cases to make sure all the features, all the other features or unchanged features are working fine or not. So this is regression testing. So let's move on to the next slide, guys, where we'll talk more about retesting. We will recap what we have discussed so far, and we'll discuss like why we perform retesting, regression testing, and difference between them, advantages and disadvantages also we'll talk about. Let's get started. So testing the same functionality with different combination of input data. So this is what we have discussed. Different combination of input data is called retesting. Retesting essentially means to test something again. In simple words, retesting is the testing a specific bug after it was fixed. Retesting ensures that the issue has been fixed and it is working as expected. So this is the main purpose of retesting, to make sure that issue has been fixed and it is working as expected. It is plan testing with proper steps of verification. So when we get the fix, then we have to re-execute our test cases. So this is plan testing, guys. In some cases, the entire module is required to be retested to ensure that quality of the module. So this is what we have discussed, right? When I have given the example of retesting. Why and when we perform retesting? So retesting is used when there is any specific error or bug which needs to be verified. It is used when the bug is rejected by the developer. So this is another example why we perform retesting. Then the testing department test whether the bug is actual or not. So let's say this is the bug is rejected by the developer. So again we have to re-execute our test cases with different set of different combination of test data, or we'll try to reproduce the defect, whether that is for that reason we have to re-execute our test cases, make sure that is a actual defect. It is also used to check the whole system to verify the final functionality. It is used to test even the entire module or component in order to confirm the expected functionality, called retesting. Advantages and disadvantages of retesting. So retesting ensures that the issue has been fixed and it is working as expected. It improves the quality of the application or product. It requires less time for verification because it's limited to the specific issue or any particular feature. So since we have taken an example of user registration page, so it's very easy to re-execute the same set of test cases, part of retesting. If the tester has knowledge of the source code, it becomes very easy to find out which type of data can help in testing the application effectively. And there are some disadvantages. So it requires new build for verification of the defect. So until unless if you don't get the new build, so you cannot re-execute our test cases. Once the testing is started, then only the test cases of retesting can be obtained and not before that. The test cases for retesting cannot be automated. So just remember, guys, we cannot automate retesting, right? We can automate our regression suite. Now let's talk about regression testing. What do you mean by regression testing? If any changes are done in the existing build, and this test is conducted on the modified build to verify the changes are working correctly or not, and because of these changes there are no side effects. That is the main purpose of regression testing. In regression test, the change functionality plus dependent functionalities are tested. The purpose of regression testing is to find any bugs which may get introduced accidentally because of new changes or modification. This also ensures that the bugs found earlier are not creatable. This helps in maintaining the quality of the product along with the new changes in the application. Why we go for regression testing? Any new feature is added to an existing feature. The code base is fixed to solve defects. Any bug is fixed, and changes in configuration. So these are the different reasons we go for regression testing. Any new feature is added, which we have discussed. Code base is fixed to solve defects, and any bug is fixed, and changes in configuration, code configuration, right? So these are the different reasons we for regression testing. Advantages and disadvantages of regression testing, guys. It helps the team to identify the defects and eliminate them earlier in the software development life cycle. It ensures continuity of the business functions with any rapid change in the software. Regression testing can be done by using the automation tool. So generally we automate the functional test cases and regression test cases, because in regression test cases, whenever there is a change or there is a deployment, we have to perform regression testing. For that reason, we automate our regression suite. It helps us to make sure that any changes like bug fixes or any enhancements to the module or application have not impacted the existing tested code. That is main advantage of regression testing. What are the disadvantages? If regression testing is done without using automated tools, then it can be very tedious, because whenever there is a deployment, we have to re-execute all our regression suite manually. So that is kind of very tedious process and time consuming, because here we execute the same set of test cases again and again. That is regression testing. Regression testing has to be performed for every small change in the code, as even a small portion of code can create software. It takes time to complete the test, and this slows down the agile velocity. It is expensive, and the cost is hard to justify. So what is the difference between retesting and regression testing, guys? So retesting is about fixing specific defects that you are already found. Regression testing is about searching for defects in other modules, other related modules. So retesting is done only for failed test cases. Regression testing is performed for past test cases, which we have seen, right? If particular module is fixed, then we have to just re-execute the test cases for that particular module, and we have to execute our regression suite to make sure other related functionalities are not impacted. Retesting is used to ensure that the test cases which failed in last executions are fixed. Regression testing is to ensure that changes have not been affected the unchanged part of the product. Verification of bugs are included in the retesting. Verification of bugs are not included in the regression testing. Retesting is of high priority, so it's done before the regression testing. Regression testing can be done in parallel with retesting. Retesting, the test cases cannot be automated, and here we can automate our regression test cases. In case of retesting, the testing is done in planned way. In case of regression testing, the testing style is generic. Test cases of retesting can be obtained only when the testing starts. Test cases of regression testing can be obtained from the specification document and bug reports. So what happens in regression testing whenever particular module is deployed? So let's say we have certain features in module which are deployed, right? So we have already regression suite. So after the deployment, we will pick some of the test cases and will put in regression suite, and will execute for the next deployment. That is how we do as part of regression testing. So this is all about retesting and regression testing, guys. So if you have any questions, then put your comments put your questions in the comment box, and please like this video, share this, and if you're new to my channel, then please subscribe it and click the bell icon to get such interesting videos. Thank you so much. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by monkey testing, and what is gorilla testing, and what is the difference between monkey testing and gorilla testing. So before I start this video, guys, so I'll let you know that I have started taking mock interviews. So if you want to give your mock interview, then please send out your resume on my email ID. So my email ID is hitendravarma22@gmail.com. So I'll provide the email ID in the description box of this video. So please send out your resume and book the slot for mock interviews. So let's get started with today's topic. So today we are going to discuss about monkey testing and gorilla testing. So what do you mean by monkey testing? So monkey testing is a random testing, guys. So there is no plan, or there are no test cases to execute monkey test. So we can easily relate with monkey. So that's why it is called monkey. So you see the basic nature of monkey. So it monkey jumps from one branch to another branch in a tree, right? So that's what we can relate. So monkey testing, as part of monkey testing, we do the random testing on any system. When we perform random testing on any system, so that is called monkey testing. So random testing, the the basic purpose of monkey testing is to get the defect as much as possible or to break the system with the random inputs or random testing. So that is monkey testing, and this is black box kind of testing, guys. Black box testing, and it is part of system testing. So we perform on integrated system. Monkey testing is used to perform on integrated system, and we don't have any plans, and I have discussed earlier. Without test cases, we use to execute monkey test. Now, if we talk about gorilla test, so gorilla is rather cool and calm than monkey. So it is basically focused on particular system, particular module, I would say, particular module. So this is part of unit testing, and here we have certain plans to execute gorilla testing, and this is part of white box testing. So user should have understanding of the system, internal architecture of the system, and coding that he or she can perform the gorilla testing. So basically it is part of unit testing. This is monkey testing is part of system testing. This is unit testing. So let's talk about more the differences between monkey and gorilla testing in coming slides. The next slide. So let's get it started. So monkey testing is type of software testing which is performed based on some random inputs without any test cases and checks the behavior of the system and confirms whether it crashes or not. So do not think that it is kind of load testing. In load testing, what happens is we have certain test data prior to perform load testing, right? But in monkey testing, what happens is we'll perform random testing. So our intention is to get defects or by performing invalid operations or random testing to break the system. So that is the purpose of monkey testing. If you talk about gorilla testing, so gorilla testing is type of software testing which is performed on a module based or some random inputs repeatedly. So whenever we perform, so as I've discussed earlier, so basically we perform on particular module. The gorilla testing is performed on particular module repeatedly. So we'll perform repetitive test cases on same module and check the module's functionalities and confirms no bugs in the module. In monkey testing, no test cases is used to test the application as it is part of random testing. It is performed repeatedly as it is part of manual testing. And the monkey testing approach is primarily used in system testing. And this gorilla testing approach is mainly used in unit testing, which we have discussed at the beginning of this video. Monkey testing is implemented on a whole system because this is part of system testing, and gorilla testing is implemented on few selective components of the system. No software knowledge is required in order to execute the monkey testing because we perform random testing on an application. It requires minimum software knowledge in order to execute gorilla testing. The main objective of monkey testing is to check whether system crashes or not. The main objective of gorilla testing is to check whether the module is working properly or not. So monkey testing is also known as random testing, guys. Just remember these names: random testing, fudge testing, or stochastic testing. So these are the different names of monkey testing. Gorilla testing is also known as torture testing, fault tolerance, or frustrating testing because repeatedly we perform the testing on particular module. So that's why it is called frustrating testing as well. There are three types of monkey testing: dumb monkey testing, smart monkey testing, and brilliant monkey testing. While there is no such different types of gorilla testing available, the implementation of monkey testing does not require any planning or preparation, and the gorilla testing cannot implement without any preparation or planning. So there should be certain plan or implementation test cases. I mean, some test cases should be there to perform gorilla testing. So this is the difference between monkey testing and gorilla testing, guys. So if you have any doubts, please let me know in the comment box. And guys, if you go to my blog, that is automationtestinginsider.com, just navigate to www.automationtestinginsider.com. So if you navigate to this software testing, so I keep all the notes related to manual testing here. See, like introduction to software testing, complete software testing hierarchy, software development life cycle, all software development models. So all the testing notes are here, whatever I have covered as part of manual testing videos in my YouTube channel. So you can go through all the notes, and if you have any questions, please note down your questions and put in the comment box so that I can reply you. And yeah, we have other tabs as well, like Selenium, automation tools, Java for Selenium, Java questions and answers, Selenium questions and and API testing. This part is pending. I'm going to cover very soon. So this is all for today, guys. So thank you for watching, and please do not forget to send your resume if you want to give your mock interviews. So I'll provide the email ID as I have discussed in the description box of this video. Thank you guys for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about software testing lifecycle, or you can call it as SDLC. So what do you mean by SDLC? So it is a step-by-step process to test any software or test any build or application. And in other words, you can say it's a standard process to test any application or software. So there are different phases, guys. When we follow SDLC process, there are different steps. So we'll discuss more about that today. So let's get started. So guys, if you remember, we have already spoken about software development lifecycle. So what do you mean by software development lifecycle? To build any software or any application, we have to follow certain process. So what are the different process in software development lifecycle? So let's just recap. So I'll tell you the reason behind I'm talking about software development lifecycle here is will relate with software testing lifecycle. How we can relate? Okay. So let's talk more about like what are the different phases in software development lifecycle. So we have requirement analysis, we have design, we have coding, testing, release and maintenance. Release and maintenance. So these are the different phases of software development life cycle. Now here you can see we have testing. Correct? Testing is the part of software development life cycle. So this is the life cycle of software development, right? To develop any software. Now testing is also divided into different phases. So what are the different phases, guys? We have requirement analysis, which is common in development phase as well as testing phase as well, because whenever we get the requirement from the customer, with the help of BA, so that will be distributed to the development team as well as testing team to understand the requirement, to analysis the requirement. So here we have requirement analysis as well in testing phase. So the first phase is requirement analysis. We have test planning, test design, test execution, and defect reporting and test closure. So these are the different 6 phases in software testing life cycle. So this testing process is nothing but software testing life cycle. So SDLC is the part of software development life cycle. Now here you can see defect reporting. Correct. So again, you might have heard defect life cycle. So that is separate life cycle. Correct. So this is defect life cycle, which we'll discuss in coming videos. Defect life cycle. So how we can relate SDLC, SDLC and defect life cycle? So you can draw the hierarchy like this: software development life cycle and SDLC, and from here defect life cycle. So defect life cycle is the part of software testing life cycle, and software testing life cycle is the part of software development life cycle. Now let's talk more about software testing life cycle today. What are the different phases we have in software testing life cycle in detail? So any project has to follow the below phases from beginning of the project to end of the project in testing. So this is what we have discussed, guys. Requirement analysis, test planning, test case design, test execution, defect reporting and tracking, and test closure. So these are the different phases in software testing life cycle. If you draw the diagram, so standard for software testing life cycle, so it could be like this. So test planning, anyway, requirement analysis is common for both development and testing. So that's why I did not keep it over here. So we have started from the test planning, test case design, test execution, defect reporting, test closure, and regression testing. So testing phase is for like to develop any software or to develop for any sprint or to develop any feature. So why we have regression test over here? So let's say we developed software, developed a build, okay, the development is done. Now we are testing for build one, and we need to follow this process, this complete testing process, correct guys? So we'll make sure after the end of the build, after end of the testing life cycle, that other part should not get impacted, because this is the process for testing life cycle for build one only, because this is recently deployed into production, recently developed by the developer. So we are following the testing life cycle for build one. So we'll make sure we'll perform regression testing over here. So make sure other part of the application should not get impacted. Now let's talk more about what do you mean by test planning, test case design, test execution, defect reporting, and test closure. So the first part is requirement analysis. So it's tester's responsibility, guys. So what we do as part of requirement analysis in software testing lifecycle phase. So we have studied the requirements. First, we need to go through the requirements. What are the different requirements given by the customer, correct? By the BA. Identify types of test cases to be performed. What are the functional test cases? What are the non-functional test cases? We need to identify in requirement analysis. Prepare RTM, requirement traceability matrix. So this is very, very much important, guys. So here we'll prepare the traceability matrix, like what are the different requirements. Whenever you get the requirement, it will be like this, like uh, in business requirement document, we have like business point one, we have certain features, and then 1.1, 1.2, like this. So we should cover all the, we should go through all the features, right? All the requirements given by the client. So we'll keep in the requirement traceability matrix. So we should not miss any of the requirements. So that's the reason we prepare this requirement traceability matrix. So here we'll map with the test cases, like scenarios first, like what are the different, what are the number of scenarios for particular requirement, and what are, how many number of test cases we are going to write for that particular scenario. So that is the purpose. Here we'll map with the scenario and then map with the test cases and then defect. So this is RTM. I'll create a separate video on requirement traceability matrix in detail. Okay, so identify types of test cases to be performed and then prepare RTM. Automation feasibility analysis. So let's link with the automation part as well, like automation. If we talk about, if we perform the automation testing as well, so we'll do automation feasibility as well at this particular point. So this is requirement analysis. So second is test planning. So it is again test lead, test planning is the part of test lead's responsibility, correct? So understand test lead or senior test engineer. So understand the project, scope of testing, identify the resources, schedule, deliverables, approach, and effort estimation, correct? So let me just come back to the previous one. So what is the outcome of this one? Requirement analysis. So here we will get requirement traceability matrix and automation feasibility report. So after this phase, we'll get these two deliverables. Now here, when we talk about test planning, so it's test lead or senior test engineer's responsibility. So we'll go through we'll understand the project and we'll write the scope of testing, identify the resource, schedule, deliverables, approach, and effort estimation. So test planning is nothing but a document, guys. Test plan is a document, and there is another document called test strategy. So how testing should be done, that is test strategy, correct? And this is test plan. Again, I'll create a separate video on what do you mean by test plan and test strategy. So here we have in test plan we have everything like what is the scope of testing, how many number of resources we are going to have for this particular testing, correct, for this testing life cycle, and what is the duration of the project, what is the approach and effort. So these all the things should be covered as part of test plan. Now next is, so what is the outcome of this test planning? We will get test plan and test strategy document. The next is test case design. So it is tester's responsibility design, or in case of automation, script the test cases or author the test cases, review the test cases, and update the test cases based on review and baseline test cases. So baseline is nothing but once when we write the test cases, when we get it reviewed from the when we get it reviewed from the lead or manager, then we will, once it is approved, then we can call it as baseline test cases, correct. Update the test cases based on review. We will update the test cases based on review comments and then get it approved from the test lead or test manager. Last is create the test data. If test environment is ready, then we'll create the test data. So this is part of test case design, guys. Now here we have two things. So first we'll write the scenarios, and then based on scenarios we'll write the test cases, correct. So let's say, what do you mean by scenario and test cases? So let's say we have login screen. Here we have username, password and submit button. So when we write the test cases for login screen, so login scenario, we can say login scenario, correct, or login functionality. So this is nothing but the scenario, guys, login scenario. Under that login scenario we may have number of test cases different, like valid login one test case, invalid login id, and then valid password, invalid password. So these are the number of test cases under this login functionality or login scenario. So this is part of test case design, guys. So the next is test execution. So it is tester's responsibility. So set up the test environment as part of test execution, execute the test cases as per the plan, document test results, and we will document the test results as well as part of test execution, whether it is failed or passed. And the next thing is defect reporting and tracking. So when we execute the test cases, correct, so we'll report the defects to the developer. If our functionality is not working as per expected, then we'll report the defect. That is nothing but the defect. So we'll report defect to the developers. Map defects to the test cases in RTM. This is what we have discussed about the RTM. So we will map the defects as well in requirement traceability matrix. Retest the defect fixes. So once defect gets fixed, we will retest them and track the status of defect to closure. So generally we use some tools to trace the defect, correct, Jira or any other tool. There will track all the like status of the defects and different status, like based on the developers activities, correct. So this is again separate life cycle, guys, defect life cycle, as we have discussed earlier. So we'll discuss more about that in separate video, defect life cycle, in coming videos. So these are the part of defect life cycle. And test execution, what you will get as part of this test execution? So we will get test results. This is the deliverable of test execution. Here defect reporting and tracking will get the defect report, correct, or execution, track the status of the defect. Execution results, here we'll get the execution result or test results, and here we'll get the defect report, complete defect report. And it is testers and test leads responsibility test closure. The sixth point is test closure. What are the different phases in test closure? So we will stop the testing based on all functionalities are tested, no new defects are found, schedule are conducted properly, and no risk in the project. So these are the different outcomes or activities are there or things are there based on which we conclude our testing and test closure report. So after this one, we have test closure report. So these are the different phases of software testing lifecycle, guys. Hope you understand it better. So if you have any questions, then comment in the comment box. And if you go to my blog, guys, go to my blog, Automation Testing Insider. So here I am keeping all the notes under software testing for the manual testing. So here we have introduction to software testing. So just navigate to automationtestinginsider.com and go through all the different notes about manual testing. So this is all for today, guys. Thank you for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by test planning or what is a test plan document. But before I start this video, let me tell you one thing, that I have started taking mock interviews. So if you want to give your mock interview, then please send out your resume to my email ID, which is hitendravarma22@gmail.com. So I'll provide the email ID in the description box of this video as well, guys, so you can check it out and send out your resume so that I can plan an interview. So let's talk about today's topic, which is test planning or test plan document. So we have already talked about what is testing lifecycle. So there are different phases in testing lifecycle. We have requirement analysis, test planning, test design, test execution, defect reporting, and test closure. So these are the different phases of testing lifecycle. So here you can see test planning is the part of testing lifecycle, which is most important part of any testing activities. So whenever we get the project, guys, so we'll plan the complete testing activities, which is carried out using test planning. So until unless if we don't have a proper test plan, so we cannot perform a proper testing. And test plan is a document which we carried out all the testing activities as part of test planning. So what are the things which we cover as part of test plan, right? So what are the things are there in the test plan document? What are the different sections? So there we should specify objective of testing. Before that, introduction of testing, right? Introduction about the project, and then objective of testing, scope of testing. So basically we'll discuss about when to test the application, what to test, and who will test. Who will test is nothing but the resources. When to test, the schedule of the testing, and what to test, like what are the items are there for testing, like in scope and out of scope. So these are the different sections of test plan, guys, which we'll discuss in coming slides one by one. There are around 15 sections are there in test plan. It will be more or less as well, depends on the project or company to company as well. So let's talk about first thing, like what do you mean by test planning or test plan. So let's get it started. So initially when we get the project, it is responsibility for a test lead or senior test to prepare the test plan for the project. So who will prepare the test plan? So it is the responsibility of test lead and senior test engineer, tester, to prepare the test plan for the project. A test plan is foundation of every testing effort. So this is most important step of any testing activities or any testing life cycle, like test planning. So test plan is the foundation of every testing effort. A test plan refers to a detailed document that catalogs the test strategy, objective, schedule, estimations, deadline, and the resources required for the completing the particular project. So it talks about test strategy, right? So in bigger projects we have test strategy document as well, which is at company level, and test plan talks about the project level. So this will basically talks about strategy document, basically talks about how to perform the testing, like what are the techniques to be used for testing activities to perform the testing, right? And in a small project, this is the section of test plan itself. So test strategy is the part of test plan in small projects. So basically I'll create a separate video on test strategy as well, and I'll talk about the difference between test plan and test strategy. Moving forward, let's talk about one more thing, like a good test plan clearly defines the testing scope and its boundaries. You can use requirements specification document to identify what is included in the scope and what is excluded. So in test plan, scope should be defined clearly, like what are the items should be in scope and what are the features which is not in scope. By creating a clear test plan, all the team members can follow, right, and everyone can work together effectively. So unless if we don't have effective test plan, so it is very difficult to test any particular application if we don't have proper test plan. So the main purpose of test plan is to just configure all the activities in test planning, right? So all the process should be in proper place. The steps to prepare the test plan. So what are the different steps to prepare the test plan? So the first thing is criteria, or you can say prerequisite criteria to prepare the test plan. So first thing is criteria, and then second is prepare the test plan, and third is get the approval of the test plan from the test manager. Once it is done by senior test member or test lead, then it should be approved by the manager or test manager. So what are the criteria, guys? To prepare the test plan, the test lead or senior test should have the below details. So development schedule. So we should clearly understand like when the development starts for particular project, when the developers starting the coding of the particular project or particular application. So we should clearly know, we should understand the development activities and the schedule of the development, so that then we can go for the test plan. Project release date, we should know the deadline of the project. Services to be provided to the customer, what are the services we are going to provide to the customer. Understand the project requirements, that is very very much important. Understanding of the complexity of the project. Scope of testing, what are the features which should be included and which are not to be included, that is scope and out of scope. Number of resources required. So these are the different things, guys. Another thing is type of testing to be conducted, what kind of testing which we are going to perform for particular project. So these are the different prerequisite criteria to prepare the test plan. So until unless if we don't know these criteria, then it's very difficult to prepare the test plan. The second thing is prepare the test plan. How we are going to prepare the test plan? So a test plan, this is what we have discussed. The test plan serves a blueprint to conduct software testing activities as defined process, which is minutely monitored and controlled by the test manager. So once we define every activities in test plan, so that will be monitored by the test manager whether every activity is in place or not. So that is the purpose of the test plan. So this is how we prepare the test plan in the second part. And third is get the approval. There are three things. First one is prerequisite criteria, second is prepare the test plan, and get the approval, the third point. Now let's talk about what are the different sections in a test plan. So test plan document has the below details, right? So we have introduction, features to be tested, that is nothing but in scope, what are the features are in scope. Feature not to be tested, out of scope. Pass fail criteria and entry exit criteria. What is the approach of testing, what is schedule of testing, what are the test factors. Resources, what are the resources which we are working for that particular application or project. Training plans, configuration management, test deliverables, test environment, risk and mitigation plan, and last one is approval of the test plan. So these are the different things as part of test plan, guys. So let's talk about them one by one in detail. So introduction, so specify the purpose requirement of the project is nothing but the introduction. Like there we'll discuss talk about what is the client name, what are the requirement of the project. So that is part of introduction. Features to be tested, specify the requirements which need to be tested, which are in scope. Features not to be tested, specify the requirement which is out of the scope for testing. We do not need to test. There is a spelling mistake over here. We do not need to test. Pass fail criteria. So I'll provide the notes in my blog, guys, automationtestinginsider.com. Do not worry about that, all these notes. So pass fail criteria. So what is the pass fail criteria? So there is a section called pass fail criteria, or you can say suspension criteria in test plan. So if the below criteria is satisfied, then we can suspend the build from testing. If the build is not deployed, so we cannot test the application, the sanity test is failed, so we cannot go for the further testing. If the build is unstable, this is another criteria which we cannot go for the further testing. Wrong build is given, and there is a note here. If the build is suspended, the developer have to immediately resolve the issue and give the modified build. So these are the pass fail criteria. So until unless if these criteria is satisfied, then we cannot go for the further testing. So this is another section in test plan document, guys, pass fail criteria or suspension criteria. Entry and exit criteria. So specify the condition to start and stop the testing. For every level of testing, there is an entry and exit criteria. For example, so we have different levels of testing. We have unit level of testing, integration, system level, and acceptance level. Now here I have given an example of system level, system testing entry criteria. So integration testing should be completed. All the major defect found in the integration testing test should be fixed. The test environment should be ready, required access should be provided. The development should be completed. All coding should be done at this point of time. So whenever we get the build for system testing, so all these criteria should be satisfied. So this is another section in test plan, entry and exit criteria. Now let's talk about, this is entry criteria. Now let's talk about exit criteria. All the functionalities are tested. No new defects are found. No risk in the project. All the defects are fixed. The testing schedule are completed. So these are the exit criteria. So once these are satisfied, then we can go for the further testing, right? Once all these criteria are satisfied. So this is exit criteria in system testing. Now approach, specify the process followed in the project, like what is the approach which we are going to follow for particular project as part of testing activities, like what is the plan, design, execution, and reporting. So this is the approach of testing should be defined in the test plan. Schedule, specify the testing scheduled are prepared based on development schedule, right? So it should be based on the development schedule, because testing is the part of development activities. We have requirement analysis, design, coding, testing, release, and maintenance. So ultimately testing is the part of development schedule. So when we talk about schedule, so if we talk about the test plan schedule, so we have planning, KT session, design test, execution, UAT, reviews. So these are the different tasks, correct? All the testing life cycle should be listed down here, like what are the activities which we are going to perform, what are the tasks which we are going to perform, like planning of the testing, the KT session to the resources, design the test, execution, UAT, reviews. So these are the plan dates. What is the plan date, what is the end date, and what is the actual start date and end date, action date. You can say action date or actual date. And if you have remarks, we should put some remarks over here as well. So this is important part of test plan schedule. Now let's talk about another one, test factors. So identify the test factors required for the project. Resources, this is an important part of test plan. Resources, specify the list of team resources and Their responsibilities like testing team, development team, project managers, who is the project manager, who is the test lead, who are the team members, who is the senior team members. So all these resources should be defined in the test plan. So this is another section, guys, important section of test plan. Training plan. So specify any training plan is required for the resources. Okay, what are the trainings, what are the further skills required for the resources? So that should be carried out as part of training plan, training plan section in the test plan. Configuration management. So specify to manage all the project related documents, coding, codes, testing documents, etc. So these documents are accessible to all the team members. So there should be a repository where we can access all the documents or codes. In case of automation testing, we should get the codes from GitHub. GitHub is another one kind of repository where we keep all the documents. We have SharePoint. Nowadays we are using SharePoint, and to keep the codes we have GitHub. So these are some configuration management tools, guys. And there are long back we used to have VSS, Visual Source Safe. We have concurrent version system. So the tool provides security version control. So what do you mean by version control? So each time the documents are updated, a new version is created. So if you remember, we have version control. Whenever we update the update our document, so there should be version created. Let's say this is version 1, there should be version 1.1, 1.2, 1.3, like this. So we can access any of the version anytime. That is the main important point of configuration management. Test deliverables. So this is another important section of test plan, guys. So specify the list of documents to be submitted to the customer during testing phase or after the testing. Documents are like test plan, test case documents, test cases, test execution results, defect report, a review report, test summary reports, etc. And yeah, so this is another section of test plan. We have one more, test environment. Specify the hardware and software configuration details over here. Hardware configuration details, the additional software required in the test environment to access the application and conduct the testing. So test environment should be specified, and this is another section of test plan. What are the risk and mitigation plans? So specify the challenges in the project and the solution to resolve the challenges. So the different risks are: required documents are not available, estimations are not correct. Let's say if we don't have requirement like BRD documents, so that is risk. We don't have requirement document from the customer, right, or from the BA team, so we cannot author the test cases properly. Estimations are not correct, delay in project deliverables, lack of skilled resources, lack of team coordinations, etc. So these are the different risks involved in the project. So that should be carried out as part of section called risk and mitigation plan in the test plan document. Mitigation plan is like how to resolve those risks. What is the mitigation plan we have prepared for the different risks involved in the project. And the final thing is approval, sign off of the test plan document. So after preparation of the test plan, the project manager and customer have the review and approve the test plan. And there is a note, guys. So during the planning phase, it is responsibility of a test lead to recruit the tester based on their skills required for the project. So this is very important. So whenever we start the project, so we should hire the proper the skilled resources for the particular testing activities or particular project. So these are the different sections of test plan, guys. So hope you understand what do you mean by test plan and what are the different sections of test plan. So still, if you have any doubts, then please write in the comment box, and please like this video, share it, and if you are new to channel, then please subscribe it. Thank you so much for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what is test strategy and what is test strategy document, and later on we'll talk about the difference between test plan and test strategy. So guys, I have already spoken about test plan in the previous video. So if you haven't watched that video, then please go and watch that video and then come back to this video. so that you can understand the difference between test plan and test strategy. So let's talk about first, like, what we mean by test strategy and what is test strategy document, and later on we'll discuss about the difference between test plan and test strategy. So what is test strategy document, guys? So it is an outline that describes the complete approach of testing. So if you remember, while talking about test plan, mainly we discuss about when to test the application and what to test and who will test. So these are the things which we consider while preparing the test plan: when to test the application, what to test, and who will test. Now if we talk about test strategy, mainly we'll discuss like how we are going to test the application, how to test the application. How to test the application means what is the approach, what is our approach to test the application. Take an example like how our templates, testing templates would be like test cases, or what are the design techniques which we are going to use. So the complete approach is comes under test strategy document. So let's talk more about what we mean by test strategy. So a test strategy is an outline that describes the testing approach of the software development lifecycle. And test strategy is a set of guidelines that explains test design. This is what we have discussed, test design, and determines how testing needs to be done. So basically this is the basic difference between test plan and test strategy, guys. So here we'll talk about when to test the application, what to test, and who will test the application, and here how the testing should be carried out, what is the approach. That comes under test strategy. Okay, test strategy document. The creation and documentation of test strategy should be done in systematic way to ensure that all objectives are fully covered and understood by all. So this is an important point. It should also frequently be reviewed, challenged, and updated as the organization and the product evolve over time. So basically test plan varies from project to project, and test strategy we will prepare at organization level. So we'll see in the like when we talk about the differences between test plan and test strategy in the next slide. A test plan for software project can be defined as a document that defines the scope, objective, approach, and emphasis on a software testing effort. So mainly it talks about the scope, objective, approach. Anyway, I'll talk about this one, and testing effort. So these are the main things about the test plan, like scope, objective, and testing effort. Approach is nothing but whenever we have smaller projects, so test strategy is the part of test plan. So that's why we have written I have written over here approach as well. Whereas if we talk about test strategy is a set of guidelines that explains test design, like what are the techniques which we are going to use to design the test cases, and determines how testing needs to be done. This is test strategy. Test plan include introduction, features to be tested, test techniques, testing tasks, features, pass or fail criteria, test deliverables, responsibilities, and schedule. So these are the different points, guys, which we have already talked about when we have spoken about test plan. Whereas test strategy includes objective and scope, documentation formats, test processes, team reporting structure, client communication strategy, etc. So this is at higher level, like test strategy. So this is at company level. This is a document which we can use in various projects. Whereas test plan depends on project to project. We may use the same test plan, or we may change according to the projects. So like here you can see documentation formats, test processes, team reporting structure, what should be the structure of the team, client communication, how we are going to communicate with the client. So all these will be considered as part of test strategy. Test plan is carried out by a testing manager or lead that describes how to test when to test and who will test and what to test. So this is developed. This is test plan is carried out by testing manager or test lead. A test strategy is carried out by the project manager. And it says what type of technique to follow and which module to test. Now let's talk about some other differences. Test plan narrates about the specification, whereas test strategy narrates about the general approaches, what should be the approach to perform the testing. It is done to identify possible inconsistencies in the final product and mitigate them through the testing process. So generally it talks about the general process, how we are going to follow for particular project, and if you get any inconsistencies in the product, then we may change our test plan accordingly. But if you talk about test strategy, it is plan of action of the testing process on a long term basis. So that's why I told you that it is developed based on like at company level, right? It is used on a project level only. It is used on an organization level. It is used by one project only and is very rarely repeated It is used by multiple projects and can be repeated a lot of times. So this is mainly for the particular project, and this is at organization level, so it will be repeated based on the based on the approach, and it can be used in various projects as well. Test plan can change, test strategy cannot be changed. Hardly we change the test strategy, so it cannot be changed. Once it is defined for any particular project, so it will not be rarely it will be changed. So test planning is done to determine possible issues and dependencies in order to identify the risk. It is long-term plan of action. You can abstract information that is not project specific and put into test approach. So these are the differences between test plan and test strategy document, guys. If you have any questions, then write in the comment box, and please like and share this video. And if you are new to my channel, then please subscribe this channel, and thank you so much for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what is test cases, and or you can say what is test case design. So this video is all about test cases, guys, where we'll discuss about what is test scenario, what is test case, how to write good test cases, and what is the format of test cases, what are the different sections in test case format, what are the different parameters. And so this video is very important for if you are a beginner in software testing, or if you want to learn software testing. So guys, we have already spoken about software testing lifecycle, where we have discussed about requirement analysis, project planning, test design, test execution, defect reporting, and test closure. So these are the different stages in software testing lifecycle, where we have already discussed about the requirement analysis and project planning. So project planning we have discussed in the previous videos, where we talked about what is project plan, and later on we have discussed about test strategy and the difference between test plan and test strategy. Now today we'll focus on test case design, guys, test design or test case design, where we'll discuss about what is test scenario, test cases, what is test cases, and how to write good test cases, and we'll discuss about the format of test cases. So let's get started. So what is test scenario? Let's talk about test scenario first, and then later we'll move towards test cases. So what is test case, test scenario or test case scenario? So let me take an example. We have this Facebook application where we have login page. So let's say this is login page, where we have username field, password field, and we have sign in button or submit button, and we have sign up button as well. So this is for existing user who wants to sign in, put the username and password field and password, and click on sign in button. So user should able to log in into the application, this Facebook application. and for new user we have this sign up button for new for user registration, right? So what is the functionality here? So we have this login functionality, correct? So this is nothing but one scenario, one test scenario. So what is test scenario, guys? So basically test scenario is any functionality that can be tested is called test scenario. So here this is login functionality which we need to test. So this is one scenario. Okay, another scenario could be this is sign up page, correct? So this is user registration is another scenario. So we have two scenarios over here. One is login functionality scenario and another one is user registration. Now if we talk about test cases, right? So test cases is nothing but set of actions executed to verify a particular feature or functionality is called test cases. Now we derive the test cases from test scenario. Here we have login functionality. So what are the possible test cases of login functionality? So let's talk about it. So first is valid user and invalid password. So this is one set of test cases, right? One set of test case of login functionality, like we'll enter valid user and invalid password, and for this test case we'll write the complete steps, guys, like navigate to Facebook page, and user should be able to see the login page and enter valid user and invalid password. Okay, so user should not be able to log in for this case. So that is a test case, set of actions, right? Another test case could be invalid user and valid password. That is another test case. What is the third test cases, right? We have, let's say if we have already registered user, so valid user and invalid valid user and valid password. So this is positive scenario. Okay, positive test case. So these two are negative one, and these two are negative one, and this is positive test cases, right? So we derive the test cases from test scenario. Now let's talk about the relationship between test scenario and test cases. Hope you understand, guys, what is test scenario. So any functionality that can be tested is called test scenario. Here we have login functionality and user registration, and test cases is nothing but the set of actions executed to verify any particular feature or functionality. Now let's talk about the relationship between test scenario and test cases. Okay, so we have already spoken about the requirement analysis. So BA provides business requirement document and software requirement specification, functional requirement specification. So these are the different requirement documents we have. So how to derive the test scenario? Okay, so we should have some documents, or if you have application knowledge, then we can derive the test scenario. So we may derive the test scenario from different documents as well, like BRD, SRS or FRS. So test scenario is derived from these documents, test scenario, and test cases will be derived from test scenarios, test cases. So let's say we are testing this Facebook application, and here we have 10 number of scenarios we have identified for particular feature. We have identified 10 scenarios, and there could be 10 test cases or more number of test cases. So let's say each scenario has 5 test cases. So 50 test cases will write for this functionality for this number of test scenarios. So this is the relationship between test scenario and test cases, guys. So many people are getting confused, like what is test scenario and what is test cases. So this is how you can relate easily, and you can explain in interview as well if this question will be asked in interview. Now let's talk more about like what happens if we don't write the test cases. One question. Okay, so if we don't write the test cases, so what happens? So we are not able to test the 100% functionality of the application if we don't write the test cases. Why? Because we just randomly executing the application based on our experience, and we have not documented the test cases. So we may not achieve the 100% coverage. So we may miss some functionalities as well. Now another point is, if you don't write the test cases, so what happens is, let's say we are executing in multiple cycles. So in first cycle, let's say we have executed 80 test cases. Next cycle we have executed 90 test cases. In third cycle we have executed 100 test cases. So we may miss the functionalities or some test cases if you don't document it, right? So this is the biggest drawback of not writing the test cases. Now the question arises here is, what are the importance of test cases, or why do we need to write the test cases? Okay, so what are the points, guys? So better coverage. So the first thing is better coverage. First point is better coverage of the application. So we'll derive the test scenarios from different documents and we'll write the test cases, so we'll get the very good coverage of the application. And the second thing is we can improve the quality of this application, so we do the better, we'll write better, like better coverage of the application, and we'll write, if we write good test cases, then we improve the quality of the application as well, because we will get good amount of defects and good defects. So definitely the quality of application will be improved. Another thing is for tracking purpose, when we write the test cases, so we have proper tracking of the test scenario. We have traceability matrix, where we have tracking of everything, like what are the number of scenarios we have and what are the number of test cases we have, what are the defects aligned to the failed test cases. So we have for tracking purpose we need to write the test cases. So this is about test cases, guys. So let me just move on to the next slide, where we'll discuss more about the test cases, some theoretical stuff. So test case design refers to how to set up your test cases. It is important that your tests are designed well, or you could fail to identify bugs and defects in your software testing life cycle. Okay, so test case design refers to how to set up your test cases. So it is the complete process of writing the test cases. It is responsibility of a tester to design the test cases. To design the test cases, tester should understand the requirement, identify the scenario, design the test case, review the test cases, and update the test cases based on review. So these are the important points while writing the test cases. And in a team, if we work in a team, so one person may think about it's testing is all about analytical skills, guys. So one person may derive 5 test cases, another person for the same functionality will derive 10 test cases. So this happens in testing. So it is collective team effort when we write the test cases. So we should understand the requirement properly, identify the scenario and design the test cases, review the test cases. So this is also very important for the coverage perspective. So maybe let's say we have written the test cases, and when we get it reviewed from our peer or from our test lead, so they may have some more number of scenarios where we need to write test cases, or we may change some of the test cases as well. So review is very important when we write the test cases. Let's move on to the next slide. How to create good test cases, right? So test cases need to be simple steps, transparent and easy to understand, and each and every test case should be traceable, and it should be linked to requirement ID in traceability matrix. So I'll discuss, already I have spoken a little bit about traceability matrix, so we will discuss more about, I'll create a separate video on traceability matrix as well going forward. Test cases should have only necessary and valid steps, brief and short. So it should be very brief and short as well, so that everyone can understand. Implement testing techniques like positive and negative test cases in your when you write test cases. Test cases should be written in such a way that it should be easy to maintain, and test cases should cover the usability aspect in terms of ease of use. So you need to write the test cases in a such a way that you are the end user. Okay, you are the navigation and everything you need to consider while writing the test cases. So you should, the steps should be very much clear, guys. So like you are using the application like end user. Different set of test cases should be prepared for basic performance testing like multi-user operations and capacity testing as well. and test cases for security aspect should be covered, for example user permission, session management, and logging methods as well. So even we have separate tools for security testing or performance testing, but while doing the manual testing also we should consider these points as well, like performance and security aspects, okay, while writing the manual test cases. So what is the test case design format, right? So this is the test case design format, guys. It depends on companies to companies also. Some of the columns may not necessary over here, but this is the standard test cases design format. Probably I'll create a separate video also where I'll show you real-time test case design as well, some test cases as well. So this is the format where we the first one is we write the project name over here and module name. Let's say our project is Facebook and we'll testing the login functionality, so login module. Reference document, let's say we are referring BRD document, FRS, whatever documents we are referring, so we need to just mention over here. Who is the author of the test case, so we need to write the tester name over here. Date of creation and date of review, who is reviewing the test case, and date of review as well. Now test case ID. So how to write the test case ID? So let's say we are writing for login functionality, so test case underscore, we will write the project name, so this is FB underscore login functionality, so login. So it will be like this, guys, test case underscore project name underscore login. So it should be very much meaningful, and then we have number like 001. This is test case 1. So this should be the format of test case. Let's say user registration, so here test case TC underscore FB underscore user registration underscore 002, like this. So this is the format of test case ID and scenario. So we'll write like login scenario here, and test case. So what is the test case? So let's say valid user or invalid user, like that we will write over here. The summary of test case, what we are going to achieve as part of this test case, right? So we want to test like test the login functionality with valid user and invalid password, like that. And what is the precondition? So precondition is nothing but the requirement should meet, the application requirement should meet before we are executing the test case, right? So what are the precondition for this one? So the site is up and running, right? FB page is up and running, and user should be user should have username and password, okay? Or we can say like it is connected to Wi-Fi, like testing Wi-Fi. We may have different like Wi-Fi when we work in application, like for different application we have different Wi-Fi connectivity as well. So these are the precondition, like application should be connected, and we have proper Wi-Fi connectivity. And what about the priority? So priority is important, like how important our test case is. So we may assign some priority to our test case, and based on that, when we get the defect, we may assign the priority to we will assign the priority to our defects as well. So we'll give the priority. Test steps. Now here we'll write the test steps. So what are the steps of this login functionality to test the login functionality? Okay, so first one is navigate to FB page, and the second one is enter username and password, and third one is click on sign in button. So these are some of the steps of writing the test cases. Test data. So here we'll provide the username and password which we are using for this particular test case, and expected result. Expected result is nothing but what should be our expected result for this particular test case. So in this case we have invalid valid user and invalid password. So what should be the expected result? We should get invalid password error message. So that is expected result. And post condition, what happens after executing this test case? So we should get error message, right? What is the post condition? What happens after executing this test case? That is nothing but the post condition. Actual result is user should not able to log in. That is the actual result. and status fail in pass. So if these two are matches, expected and actual, so we'll write if they are matching, then it is pass. If they are not matching, then it will be failed, right? So this is the format of test case design, guys. So let's move on to the next, where we'll discuss, just recap what we have discussed so far. So follow below steps to create test cases. So test case ID, it is unique number to represent its test cases. It's good practice to follow some naming convention for better understanding and discrimination purpose. Like this is the proper naming convention of writing any test case. Test scenario. A test scenario is defined as any functionality that can be tested, which we have discussed earlier. It is a collective set of test cases which helps the testing team to determine the positive and negative characteristics of the project. Test scenarios are derived from test documents such as BRS and SRS. What is test case? Test case is a set of actions executed to verify a particular feature or functionality of your application. Test cases are focused on what to test and how to test, and test case is mostly derived from test scenarios. What is precondition? The condition to be satisfied to test the requirement, right? So that is precondition. Conditions that need to meet before executing the test case, so that is precondition. Priority. The importance of the test case is called priority. It is parameter to decide the order in which defect should be fixed. Priority means how fast defect has to be fixed is called priority. So we'll prioritize our test cases as well, and whenever we get the defects, we'll prioritize our defects as well. We'll discuss about priority and severity of defects in defect life cycle. So test step describe. Now let's talk about test steps. Test steps describe the execution steps. To execute test cases, you need to perform some actions. Each step is marked pass or fail based on comparison results between the expected and actual outcome. Test data. It is data created or selected to satisfy the execution preconditions and inputs to execute one or more test cases. We need to have proper test data to execute the test steps. Expected result. The output result as per requirement, as per SRS or FRS, the result which we expect once test cases were executed is called expected result. We have post conditions that need to achieve when test cases was successfully executed. Actual result. The output result in the application once test cases was executed, and capture the result after the execution. Based on the result, the expected result, we set the status of the test cases. If they are same, expected and actual result, so that means the test case is passed. Status. The status as pass or fail based on expected result against the actual result. Okay guys, so if the actual and expected results are same, mention it as passed, which we have discussed. Else make it as failed. And if test fails, it has to go through the bug life cycle to be fixed, which we'll discuss in coming videos. Other important fields of test case template. So we have project name, which we have seen in the test case format. We have module name. Reference document, mention the path of the reference documents if you have any, like requirement document, test plan, test scenarios. Author, created by the name of the test author, name of the tester who created the test cases. Date of creation, when the test cases were created. Date of review as well, when the test cases were reviewed. So these are some different other points which we need to mention as part of test case document. Maybe there will be a separate worksheet as well. Generally we used to make in Excel document, and there is a separate section called revision history, where we'll mention who is reviewed, what is the review date, and all those things as well. And reviewed by name of the tester who created the test cases, who reviewed the test cases. There is a spelling mistake over here. Executed by name of the tester who executed the test cases. And the date of execution, when the test cases was executed. Comments include value information which helps the team. If you have any comments about particular test case, the execution comments, or if you're while writing the test cases as well. And once we write the test cases, guys, so it's very important to review the test cases. So after preparation of the test cases, review are conducted to ensure the completeness and correctness of the test case. So completeness is nothing but, let's say one team member written the test cases and it is getting reviewed by the another team member. So he or she may have some more number of may come up with more number of scenarios. So that is nothing but the completeness, whether it is the written by the first tester completed or not, right? So it is it will be checked in the review process checks the completeness of the test cases, and correctness, whether those steps are correct or not, that will be taken care based on this review process. So this is all about today, guys. So if you have anything if you have any questions, then please comment it, and please like this video, share it, and subscribe the channel if you are new to my channel. Then this is all about today, guys. So thank you for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to showcase you the test case template, the real-time test case template, guys, which you can see right now in my screen. So in the last video we have spoken about test case design, what is test scenario, what is test case, and how to write test cases. Also we have seen the format of the test case. So today I'm going to showcase you the real-time test case template which we are using while working in any company. So this is the standard template, guys, which we are following in any company when we work for any company. So format might be different here and there, but mostly this is kind of a standard template, so you can refer this. So this video is very important for beginners who working as a manual tester in any company as a beginner, and this is very important who wants to learn software testing. So as part of this template, I have captured a couple of test cases for Facebook application, guys. So which we are going to talk about it, like what are the test cases I have captured over here, couple of test cases. And this template has 4 tabs, 4 worksheets. We have summary of the test cases, what are the details about the project and testing. We have summary tab, we have functional testing tab where we have written the test cases. We have defect tab as well, defects, where in case if you don't have any defect tool in your company, then you can utilize this worksheet for to raise the defects. And we have regression testing tab as well, where you can capture your regression suite and execute your regression cases as well. So let's talk about one by one all the tabs which we have captured over here. So we have summary as part of this template, okay, and here we have written couple of test cases of Facebook application. Okay, so here we have project name. In summary tab we have project name or number. So since we are using Facebook application, so simply you need to mention project name or project number. So let's say we have project Facebook, this is project name. Let's say we have given some number, so project Facebook 01 is my project number. Test case authoring date, so what is the date which you have started authoring the test cases. What is the application, again you need to mention over here Facebook application. And authoring effort, what is the effort you put while writing the test cases, so you need to mention over here like 30 minutes. And execution effort, once test cases have been written, now you are executing the test cases, so what is the execution effort over here. So this is kind of summary of all the testing effort, testing fees, right. Plan author, who written the test cases, you need to mention the tester name over here. So let's say tester 1 written this test cases. Now test case execution date, what is the execution date, what is the version, what is the environment you are performing on, test environment or dev, you need to mention over here. And execution time, again actual time, what is the execution time over here, so you can put it over here, what is the execution time over here. And executed date is done. Executed by, who executed the test cases, so let's say tester 2 executed these test cases, so you need to mention in this particular section about the who executed the test cases. Now what next? We have test status as well. So you need to put the status like it is in progress or completed or pending, whatever status of your testing you need to put over here. Scope of the testing, again you need to put in this particular section. Test purpose or objective, what is the objective of your testing, you need to mention. Set of requirements or considerations, so if you have some considerations or requirements you need to put it over here. Notes or special instruction while testing, so again you need to mention here. Database changes, hard work or network specification, you need to mention over here. Items not included in the test, whatever the requirements which are out of scope, you need to mention over here. Which are in scope, you need to mention over here. Out of scope, right? Assumptions while testing, you need to mention here. So worksheets in test plans, what are the, so you can say this is kind of mini test plan as well, guys, because we are putting all the testing details over here. So you can say this is mini test plan as well, this template particularly. And all the projects should have functional testing, regression testing, worksheet. So we have functional testing and regression testing, and new worksheet can be added in case of multiple modules. So if you have multiple modules to test, so you can add extra worksheet as well. Defect list, so we have defects tab. Now let's talk about the next worksheet, which is functional testing. So we have seen what is the naming convention of our test. Okay, so we put all the test cases over in this particular worksheet. So the first column is test script. So we have seen in the last video, guys, what is the naming convention. So test case TC and name of the project, and what is the functionality which we are going to test, login functionality, and 001 is the number, test case number. The second column is requirement. So let's say we are referring business requirement document where we have different business requirement points. So it belongs to 1.1. So you need to mention business, what is the BR number, and script description, what is the script description of your test. So verify login functionality of Facebook login page with valid user and password. So this is the summary of like script description about your test case. Systems, so FB login page. Prerequisite or precondition, so system should be connected to internet, that is the first criteria. And second thing is FB site should be reachable, up and running. And now we have next column as step number. So we have written all the steps over here. So the first step is open the FB site, which this is the site, guys. So we need to open this FB site, and as part of test data we have just provided the URL, whatever URL like username, password. Here we have provided username, password, and here we have URL as test data, right? We need to provide the staging environment URL, or wherever we are executing our test cases, like dev environment or testing environment or staging environment, we need to provide the URL. So what is the expected result against this one? Step description. User should be able to open the URL when we follow these steps. Open the FB site, so user should be able to open the URL. Next is actual results. So this is expected results, we are expecting this behavior, and actual results, URL is opened successfully. And last column is status. So if expected result is matching with actual results, then status should be passed. It should be passed, right? So if both are same, then it should be passed. In case if it is not matching, if actual result is not matching with expected, then we need to mention it as fail. Now let's talk about the next step. Verify the login page. So let me just open the Facebook login page, facebook.com. So this is the Facebook login page, guys, where we need to enter email address or phone number and password, and we have login button, and we have create new account as well, forgotten password as well. So this is the login page of Facebook, and here you can see verify the login page in step number 2. What are the expected result we should get when we login when we navigate to login page? So the email address or phone number text box should be displayed, password text box field should be present, login button should be present. So these are the expected results on login page, right? And corresponding we should have actual results. So email address or phone number text box are displayed, and corresponding we need to write for every actual results, guys. So here you can see the email address or phone number text box should be displayed. So in the this is for the first point, actual result corresponding to the expected result. For the second one, password text field should be present. So password text box is present. Third one is login button is present. So these are the actual results, and all are matching with the expected result. So we'll make it as pass. Third one is enter valid username and password. So we need to enter valid username and password as part of our test case. So this is the test data, username and password, and user should be able to enter user should be able to enter username and password. What is the actual result? Username and password entered successfully, and status is pass. What is the last step? Click on login button. After entering the username and password, we need to click on login button. So here we have written user should be able to log in into the FB application, and user is logged in successfully. That is pass, because expected result is matching with actual results. And this is part of first case test case, guys. Now if you talk about the next test case, we have new account creation. So test case underscore FB underscore new account creation 002. So here you can see, after entering username and password, click on login button. Okay, for new user, this is for existing user, and suppose you don't have account, so you need to create the account. So you need to click on this create new account button. So sign up page should be displayed. This pop-up window should be displayed when you click on this create new account. So here I have written verify new account creation in FB application, FB sign up page as part of this column. Now what are the prerequisites? System should be connected to internet, FB site should be reachable, up and running, and user should have valid email address or mobile number. So then only you should be able to sign up. When you have valid email address or valid mobile number, then only you should be able to sign into, then you can sign into Facebook page or Facebook application, right? Until unless if you don't have a valid email address or mobile number, because it will send you some OTP for verification on your mobile number and email address or email address. Okay, so these are the steps as part of these test cases, guys. The second test case, so you can just go through it, which I have written over here. User should be like first couple of points are same, I guess. Verify create new account button on login page. So here we have, and corresponding we have actual results and status of our test cases. So this is all about test case template, guys. So if you have any questions, you can ask me in the comment box if you have any doubts. So this is all about today. Thank you for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to cover an important topic, that is test design testing techniques, and this is an important interview question as well. So guys, earlier we have covered what you mean by test scenario, what is test case, and how to write the test cases, and I have shown you the format as well. We discussed about real-time test template as well. Now today we'll focus on what are the different test design testing techniques available. Now if you see the process, guys, whenever we get the requirement from the customer, like business requirement document or FRS, so we have different requirement points, right? Business requirement points. Then we need to convert them into test scenarios. We derive the test scenarios. From test scenarios we write the test cases, right? Different test cases. So this is the simple process which we used to follow. Then the question arises here is why we go for test design testing techniques, correct? If you write the simple, if you cover all the BR points, business requirement documents, and when we cover them to test, when we cover all the scenarios and written the test cases, then why we go for test design testing techniques? So there are a couple of points, guys, which and that is the reason we go for test design testing techniques. So what are those points? Those are important points. The first one is better coverage of your testing, better coverage of all the scenarios, right? So using these techniques we can cover maximum number of scenarios and we can derive the maximum number of test cases, like all the permutation and combination. So our test cases will have the better coverage. So that is one of the reasons. And the second reason is to write effective test cases. So to write effective test cases, we need test design testing techniques. So what do you mean by effective test cases, guys? So using these techniques, we can write some test cases in such a way that it will find maximum number of defects or good defects. So that is nothing but the effective test cases. So these are the two important points, and because of that we go for test design testing techniques, and that these 2 points are very, very important in testing. So let's talk about what are the testing techniques available, guys. Test design testing techniques. So we have boundary value analysis. So this is the first one, boundary value analysis. We have equivalence class partitioning. Third is decision table testing, state transition, and fifth one is error guessing testing. So these are the 5 types of test design testing techniques, guys. So let's talk about each one of them in detail from coming slides, from the next slides. So let's talk about boundary value analysis. So the technique is specified to validate the boundary validations, correct? So the name itself says boundary value analysis. So we test the application on for particular field, we test on boundaries, right? So that is nothing but boundary value analysis. It is based on testing at the boundaries. We will be testing both the valid and invalid input values in the boundary value analysis. Now conditions are like maximum, minimum and maximum, minimum -1, maximum -1, minimum +1, maximum +1. So these are the 6 conditions. So let me give you an example so that you can understand better. So let's say, guys, you are applying for a job in any company's portal. You are applying for a job and you are entering your details, all the information there in the form, like first name, last name, and we have some email address. So similarly, we have one age field as well, age input box. There you need to specify the age as well. And for this particular job, we have age criteria. So like from 20 to 35. If you have falling in this category, like 20 years to 35 years, then you can apply for this job. So it should throw an error if you enter like if you are 19 years old or if you are 36-year-old, correct? So this is the basic application, like basic criteria for this particular form. Now how you derive the test cases, boundary value analysis, how do you do that, right? So minimum point is, let's say minimum is, our minimum value is 20 and maximum is 30, correct? And we have condition minimum -1. So what is minimum -1? 20 minus 1, 19. 20 plus 1, minimum plus 1, 21. How about the at maximum side? Maximum -1, 34. Maximum plus 1, 36. So these are the 6 test cases, guys. From here we derive the 6 test cases. So no need to test each and every value like 20, 21, 22, 23, 24, 25 like that. So we derive the test cases based on boundary value, like based on these minimum and maximum values. So these are the conditions like minimum plus 1, minimum -1, minimum plus 1, maximum -1, maximum plus 1. And you can consider like this is x, this is y. So this is x minus 1, this is x plus 1, and this is y plus 1, and this is y minus 1. So what are the invalid conditions over here, right? So 19, it should not take 19, correct? And 36, all are positive test cases. All, it should accept all the values like 20, 21, 34 and 35, because this is under this criteria 20 to 35 range. And why we go for this boundary value analysis? Why do we need? So what happens is developer generally make a mistake while developing the application. So let's say for this particular scenario, let's say while putting the criteria, while putting the condition, like if else, if they have mentioned like if age is greater than 20. So let's say if developer put the criteria like this, if age is greater than 20, so it should accept above 81 only, right, based on this condition. So we should specify like age is greater than or equal to, so it should take 20 as well. So that is the reason we generally do boundary value analysis. Using these testing techniques, we write the test cases based on boundary values. So this is an example of boundary value analysis, guys. So let's move on to the next slide where I'll talk about another example of boundary value analysis. So password field accepts 6 to 32 characters, then we only test for minimum 6, maximum 32, minimum -1 5, minimum +1 7. Similarly we have maximum side, so it should take 6 to 32. So what are the invalid values here? So minimum -1, this is invalid, and maximum +1, this is invalid values. All it should take all the characters like 6 characters, 6 digit, 7, 32 and 31, correct. And the next one is these 6 conditions are enough for password field testing. So we derived 6 test cases for this password to validate this password field. Now let's talk about the next, guys. So next one is equivalence class partition. What do you mean by that? So the technique is specified to test the valid and invalid combination. So what do you mean by that? The idea behind this technique to divide a set of test conditions into groups or sets that can be considered the same. So let's say we have range of values, we have different sets of or different range of values. So we divide them into different partitions. So that is part of this equivalence class partitioning. Now each partition we take one value and we will test the our application. So I'll take an example as well. I'll give you an example. It is a black box testing technique or a specification based testing technique in which we group the input data into logical partitions called equivalence classes. So now let me give you an example, guys. So suppose you have an input field which takes the values from 0 to 500. Now you cannot test each and every values, right? Let's say 1 to 500. Just take an example like 1 to 500. Now you cannot test each and every values like 1 2 3 4 5 up to 500. So how you divide into different equivalence class partition, right? How you do the partitioning over here. So let's say we have like 500 minus 500 to 0, 1 to 100, 100 to or 101, 101 to 200, 201 to 300, 301 to 400, and 401 to 500, and 501 to 600. So these are the possible scenarios, and we can take, these are the different partitions, guys. So minus 500 to 0. So we'll take one value from minus 500 to 0. So let's say we'll test for minus 200. This is one value. 1 200 will take only one value. So let's say we are going to take 50 from here. 101 to 200 will take let's say 151. 200 to 300 will take 210. 301 to 400 will take 350. Similarly, we'll take between 401 to 500 and 501 to 600. So these are the different partitions, and we'll take only one values. So how many number of test cases we derived? 1 2 3 4 5 6 and 7. Only 7 test cases. We'll test only for 7 values. Now let's see like what are the positive test cases and what are negative here. So minus 500 to 0 is this, it should not accept this one, right? Because the range is from 1 to 500. So this is invalid, or this is invalid value for this particular testing, right? 1 to 100 it should accept, 100 to 200, 201 to 300, this is also good test data. 301 to 400, 401 to 500, that is also, and this is again kind of negative scenarios, 501 to 600. So out of 7, 5 is positive test cases and 2 is negative. So this is how you can derive the test cases based on equivalence class partitioning. Let's talk about another example in the next slide, guys. Any mail ID fields accepts alphanumeric data, correct? So what are the valid data here? A to Z. A to Z is valid data. All special characters are invalid data. A to Z uppercase and A to Z smaller case, and 0 to 9 alphanumeric, since it is alpha and numeric, right, alphabetical and numeric values. So all these are valid data and this is invalid data, all special characters. If a text field accepts 1000 to 500, the partition should be, what are the partitions, different partitions over here. So valid data we have 1000 to 1500, and invalid if you see A to Z, because this is numeric only, and A to Z in uppercase, number less than 1000 and number greater than 1500, and all special characters. So these are the different partitions, like here we have 2 and 3, 5 and 6 partitions we have divided, and only which this is the valid data. So this is another example of equivalence class partitioning, guys. This is another couple of examples. Now let's talk about decision table testing. This is an important test design technique, guys. Decision table testing is software testing technique used to test the system behavior for different input combinations. So generally what happens is we test for different input combinations, and one side we have different input combinations, another side we have different rules based on those combinations, right? So I'll talk about that in detail in the next slide. In this methodology, the various input combinations and the accompanying system behavior are tabulated. So based on combinations, different input combinations, and what is the behavior, right? System behavior are tabulated. So in tabular format we write we design the test cases. We'll derive test cases from that tabular format, from that table, right? So this is systematic approach, and decision table testing is black box test design technique, guys. Behavioral, or you can say behavior based testing technique. When a system has complex business rules, then the decision table testing technique helps in identifying the correct test cases. When we have complex business rules, then we go for decision table testing. We have different input combinations, and based on that we have different rules. Then we derive in this tabular format, will derive different test cases from that tabular format, from that table. Let's take an example of this decision table, guys. So how to create a login screen decision based table. Let's make a login screen with decision table. So a login screen with user ID and password input boxes and submit button. So whenever we see the login screen, so we have a username field, password, and then we have submit button. The condition is simple. If the user provides correct username and password, then user will be redirected to home page. If any of the input is wrong, like username or password, an error message will be displayed. So this is an example of decision table testing. So how do we derive the test cases? Based on decision table, right? So we have conditions over here. In this first column we have conditions. So we have username, T is nothing but true and false. Here we have true and false, password true and false, and output error or home page. Now let's talk about rule 1, what it says. So username we have true, password we have true, then we should get to the home page. When we enter correct username, correct password, then we should get home page, right? When we click on submit button after entering correct username and correct password. What about rule 2, what it says? If username is correct but password field is wrong, password is wrong, then we should get error message. What rule 3 says? If username is false and password is correct, username is false and password is correct, then we should get error message again. And if both are wrong, right, username and password both are incorrect, then we should get error message. So these are the different rules, guys, and from here we can derive 4 number of test cases. This is first, second, third and fourth test cases, right? So this is about decision table testing. So what we have learned from here, what is our interpretation, what are the different test cases? Username and password both were correct. User navigated to home page. Username was correct but the password was wrong. The user shown an error message. Third is username was wrong but password is correct. Then user shown the error message. And last one is if both are incorrect, then we should get the error message. So while converting these two test cases, we can create 2 scenarios. First one. So to create these four test cases, right? So there are basically, if you see, there are two scenarios generally. So one is enter username and password correct, and click on submit button. So that is positive test cases, and negative we have three scenarios, username and incorrect password. So these two are two scenarios. One is correct username and password, and another one is either one of them is wrong. So this is how we derive 4 test cases using decision table. Now let's talk about state transition. So state transition helps to analyze behavior of an application for different input conditions, guys. So in this state test, outputs are triggered by changes to the input condition or changes to the state of the system. In other words, tests are designed to execute valid and invalid state transitions. So basically we test on different like valid and invalid states of any system. So this is when we have any application which has sequence rules, right? I mean sequence. When we have some sequence, then this test design techniques is very useful. So take an example. It is black box testing, which is used for real time system with various states and transition involved. So what happens? Let me give you an example so that you can understand whatever we have discussed here in theoretical, right? So let's say you are going to ATM and you insert your card. You want to withdraw the money. So what happens if you insert the card and enter the wrong password? So it will ask you to enter the password again. Your password is incorrect, so it will ask you to enter the password again. And from here, if you enter the correct password, then you will navigate to the you will be able to withdraw the amount. And in this second attempt, again you will if you are not able to enter the correct password, then it will go for the third. Again, if you enter the wrong password, then again it will go for the next attempt. So I think maximum it will be allowed 3 attempts to enter your password. So these are the different states, guys. So this is like here, from here, if you in the first attempt we have tried, right? So it goes to the next attempt, and there are a couple of states over here. One is valid, where when we enter the correct password, then we should be able to get our money, and if you enter the wrong password, then it will try for the next attempt. So this is an example of state transition. Let's understand this in the next slide in detail. Yeah, so when to use state transition? So this can be used when a tester testing the application for finite set of input values. So this is the one of the criteria for state transition, like we should have some finite set of input values when we have sequence of events that occur in associated conditions that apply to those events. So take an example of that which I have given you of ATM machine. So there we have finite set of input values, right? We know like 3 times it will allow, and the 4th attempt it will block my card, correct? This will allow the tester to test the application behavior for a sequence of input values. When to not rely on state transition? So when the testing is not done for sequential input combination. So when we don't have any sequence, in particular sequence, then we cannot go for this state transition, because in sequence, like when we withdraw the money, so this is in particular sequence, right? When we enter the correct password or incorrect password, there are certain stages or certain state. So this is kind of particular sequence. So when testing is not done for sequential input combination, then we cannot go for this state transition. If the testing is to be done for different functionalities like exploratory testing, then we cannot go for this state transition. So take an example for this state transition, guys. So let's consider a login page function where if user enters invalid password 3 times, the account will be logged. Correct? Take an example of that, the previous example which I have given, ATM machine, or if you are logging any screen. So it will also allow like 3 times to enter the correct password if you are entering the wrong password multiple times. So in this system, if user enters a valid password in any of the first 3 attempts, the user will be logged in successfully. If the user enters the invalid password the first or second try, the user will be asked to re-enter the password. And finally, if the user enters incorrect password 3rd time, the account will be blocked. So how we derive this state transition table, guys? So we have different states over here. Start S1 start, S2 first attempt, S3 second attempt, S4 third attempt, like that. S5 granted, access granted, and S6 account blocked. So how you can let me just explain it better. So let's say we have different states over here, S1, S2, S3, S4, S5 and S6. So these are the different states, guys. So the first one is start. When we start, so when we enter the correct password in S1 and in S1 state, so it will go to S5 state directly. S5 is nothing but granted, access granted. So we should be able to access the application. If we enter the wrong password, so there are two conditions in each and every state. So in this first state, if we enter the correct password, then we go to S5. If we enter the wrong password, then we go to S2. S2 is first attempt, correct? First attempt. Now again here two conditions. If we enter the correct password, we'll go to S5, otherwise we'll move to S3. S3 again we have two conditions. If we enter the correct password, we'll go to S5, otherwise S4. Now what happens at S4? S4 we have third attempt. If we enter the correct password, S4 will go to S5, obviously, correct? And if we enter the incorrect password, so we'll go to S6. What is S6? Account blocked. Your account will be blocked based on multiple times you have tried with incorrect password. So this is state transition, guys. Now let's talk about the next one. So in this table, when we enter the user enters the incorrect pin, enter the correct pin, state is transition to S5, which is access granted. And if user enters a wrong password, he moves to the next state. If he does not, if he or she does the same third time, it will reach the account blocked state. So these are the different state, right? We have access granted state and we have account blocked, and it gives previous different states as well, like S2, S3, S4, which we have discussed. Now let's talk about error guessing testing, guys. So already I have covered a video on this one, so you can go to the playlist and you can watch that particular video on error guessing testing technique. So what it says, let me just give a brief about error guessing testing. So testing is conducted by performing invalid operations and validate the error message is displaying or not. So this is kind of experience based testing, guys. So if you have very good knowledge on application, or if you are experienced tester, or if you have very good analytical skills, so that then you can use this testing technique. Like you will assume in any application, like what is invalid operation when I perform, so what the error message I should get, right? So it's based on error guessing. You are guessing the error, like if I performing this action, so I should get particular message. So the error message should be meaningful to understand. So when we perform some operations like valid or invalid operations, generally invalid operations when we perform based on this testing technique, so we should get a proper error message. So it is a type of testing method in which prior experience in testing is used to uncover the defects in software testing, right? In the software. It is an experience-based testing technique in which the tester uses his or her past experience or intuition to gauge the problematic areas of software application. So this is the main purpose, like when you have good experience or you use your past experience, then you can gauge more number of like problematic areas of the application. Let's take an example of this error guessing testing, guys. So we need to test a program which reads a file. So what happens if the program gets a file which is empty or the file does not exist? So whenever we test, let's say we are uploading a file in the system, and simply we'll upload a file and we'll verify whether it is working or not, whether it is taking that file or not. But we should also think about, like, if we upload empty file, then what will happen if the file does not exist, and if you try to upload it, what will happen, something like that, right? So this is an example of error guessing testing. Another one is enter blank space into text field. Let's say this is the text field, and suppose I'm entering my name Hitendra underscore, like I'm giving a space and Verma. So what will happen, right? Sometimes developer develop the application in such a way that there should not be any space in the text field. So we should consider we should test these kind of scenarios as well as part of error guessing.
And if you enter like this, then what should be the error message, like the name is not proper or incorrect name, something like that, we should get the error. Use maximum limits of files to be uploaded. This is another example of error guessing testing, guys. So these are the different testing design techniques, guys. 5 testing design techniques we talked about. So if you have any doubts or if you have any comments, then please write your queries in the comment box of this video, and please like, share this video, and if you are new to this channel, then please subscribe this channel as well and click the bell icon to get the notification for upcoming videos. Thank you guys for watching, and please visit my website as well, automationtestinginsider.com. we have different notes over here about all kind of testing. So thank you guys for watching. Have a nice day. Bye bye.
Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to cover an important topic, that is test case review process. So this is an important phase in testing life cycle, guys, important process in testing life cycle. So today we are going to talk about what do you mean by test case review process, and why do we do test case review process, and what are the different types of reviews, and at last we'll talk about like what are the problems which we can find while doing the review process, or what are the mistakes which we can find during review process, and how to rectify them, and how we can improve our testing process. So let's get started. So test case review process is an important process to follow in software testing. Test case should be effective and also follow the standards to write the test cases. So whenever we write the test cases, guys, it should be effective. It should be effective enough to find more number of defects, and also we should follow the standards. Standards is nothing but we should follow the proper naming convention while writing the test cases. We should follow the templates provided by the company, and the steps should be very much clear so that anyone can understand that. After preparation of the test cases, a review are conducted to ensure the completeness and correctness of the test cases, proper flow and maximum test coverage. So these are the points which are taken care while doing the review process. So it should be the test cases should be completed properly, and correctness. So we should write the correct test cases, right? So we need to check whether it is correct or not, like steps are properly written or not. Of the test cases, proper flow. So let's say we are testing any functionality, and we need to check the proper workflow of that particular functionality. So that is written or not, we need to check while doing the test case review process. And maximum test coverage, so whether we have covered all the functionalities or not as part of test case review process. So these are the points which are taken care while doing the test case review process. The test lead or project manager have to approve the test cases. Once review is done, then test lead or project manager approves the test cases. During this review process, if the reviewer find any mistakes, he or she writes in a separate document which is known as review document, and send it back to the author. So guys, we have a separate review document as well, where we'll write what are the review points, or in some templates in the test case itself, remarks column is there or comments column is there, review comments column. So we'll put our comments there, whoever reviewing the test cases, and we will send it back to the author of the test cases, who will again work on whatever points we have mentioned in the review document. Now let's talk about test case review techniques, or what are the different types of test case review process, right? So the first one is self review. This is carried out by the tester who wrote the test cases by looking at the SRS or FRD, software requirement specification or functional requirement document. He or she can see if all the requirements are met or not. So self review, whenever we return the test cases, guys, even we do the review process. So that is nothing but self review process. Who return the test cases will do the self review, whether we have covered all the points from BRD or not, whether we have covered all the scenarios and we have properly converted them into the test cases. So that is nothing but the self review process. Another one is peer review. So before a test,
Before test lead, the test case is reviewed by another team member who is not familiar with the system, is called peer review. Maker and checker are other names of the same thing. So let's say tester, we have couple of tester A and tester B, and this is working on module X and this is working on module Y. So A is not aware of module Y, and tester B is not aware of module X. But whenever we write the test cases, if tester A writes the test cases, it will be reviewed by tester B, and tester B whatever test cases he has written, it will be reviewed by tester A. So like that is nothing but because these two guys are at the same level, so that is what we call it as peer review. And later on it will be reviewed by the test lead or test manager. Maker, we used to call it as maker, and checker are the other two names for the same thing like peer review. And third one is supervisory review. This is done by a team lead or project manager who is higher in rank than the tester who wrote the test cases and has an extensive understanding of the requirements and system. So generally what happens, guys, most of the cases we follow these two process like self review and peer review. These are the mandatory process which we used to follow. Like always we used to do self review and later on peer review, and sometimes it is reviewed by test lead or test manager as well in some cases. So that is not mandatory, but in some cases it is reviewed by the lead as well. So this is about test case review techniques, guys. Now what are the common mistakes which are checked during test case review process? Okay, so incomplete test case, missing negative test cases, no test data, inappropriate or incorrect test data. So these are the points which we review while doing the test case review process. Incomplete test cases, if test cases are not written properly, missing negative scenarios or negative test cases, if test data are not provided, or inappropriate test data or incorrect test data, right? So these are the different points which are taken care during the test case review process. Spelling errors can sometimes cause a lot of confusion or make a statement difficult to grasp. So this is another point which can be checked during the test case review process. Spelling errors can sometimes cause a lot of confusions, right? While review process, it is very important to check whether all the standards and guidelines are properly followed or not. So what do you mean by standards? Whether we have written with the proper naming convention, whether we have used the right template or not, the right version of the template, and some guidelines, the testing test case written guidelines, whether we have followed all those or not. So that is done during the review process. If proper template is followed, then it becomes easy to add modified test cases in future, and test case plan looks organized. Correct? This is what I have talked about. If the grammar is incorrect, the test case can be misinterpreted, right, leading to incorrect findings. And another thing is test cases should have a very simple language which is easy to understand. So which should be very much easy to understand by another tester who doesn't know the functionality of these test cases, right, or this functionality whatever we have written the test cases. So it should be very much clear, the step by step you should write the test cases. Replication, it refers to the duplicate test cases removal. It is possible that two or more test cases test the same thing and can be merged into one. This would save time and space. So we should always check whether in case of any duplication in the test cases. So this is also done while doing the review process. This can be also checked while doing the review process. Test case which are uselessness due to change in requirements or some modifications, such test cases must be removed. If some test cases are useless or change in requirements, if it is not updated as per the requirements, so those test cases should be modified or can be removed from the test cases template. So these are the different points guys about the review process, and it's very important whenever we write the test cases it should be properly reviewed by our peer or a test lead. So these are the points you should take care while writing the test cases. And still if you have any doubts or if you want to put any points, then please write in the comment box, and please like this video, share it, and comment as I have discussed if you have any points, and subscribe to this channel as well. Thank you guys for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So guys, as a tester, when we write the test cases, once authoring of the test cases is completed, then we do self review, and once self review is done, then we go for peer review of our test cases. Once peer review is done, then we go for supervisory review, which is usually done by test lead or test manager. And once that review process is done, they will approve the test cases. Test lead or test manager will approve the test cases. Now we got the final version of our test cases, correct, which is approved version. Now that should be stored or placed, or you can say that can be uploaded to a repository, that is nothing but test case repository. That is called test case repository. It could be your SharePoint, which is provided by a company which you have access, or it could be SVN, or it could be any share folder. Okay, so any kind of configuration management tools, or it could be a project management tool like Jira. So today we'll discuss about what do you mean by test case repository guys. So let's get started. So a test case repository is a centralized location, centralized so that all the team members can access, whoever has access can get the test cases from that repository, where all the baseline test cases, baseline is nothing but whatever test cases are approved. It's not about just test cases, all the approved documents should be placed in repository or centralized location. Test repository comprises test cases that encompass all key possibilities of permutations and combinations in workflow, execution and transaction, ensuring that all variations in system and user interactions are covered. So basically the meaning of this line is, this point is, all the functionalities whatever we have covered, whatever test cases we have written, should be placed in a repository called test case repository. A test case repository is used to store approved test cases only. This is what we have discussed at the beginning. Any test engineer wants to test the application, then he or she needs to access the test cases only from that test case repository. So let's say if tester A has written the test cases and B is going to execute the test cases, so he will access the repository and get the test cases from there, which are approved ones. Okay, and then he can execute the test cases. If we do not require any test cases, we can drop them from the test case repository. If some test cases are useless or that is not in use, then we can drop from the repositories. Each version have a separate test cases repository. So we should properly maintain in repository guys all the versions of the test cases. So this is about test case repository guys. So if you have any comments, then please write in the comment box. Thank you for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is traceability matrix. So what do you mean by traceability matrix? So it is the mapping of requirement to the test cases. So let me just further explain. So whenever we get the requirement and whenever we start the testing process, so it is a document where we map requirement to the scenarios, from scenarios to test cases, and from test cases we map the defects. So this is the complete mapping. This document talks about the complete mapping of requirement to the scenarios, to the test cases and defects. And there are couple of things or couple of advantages of having traceability matrix guys. So the first thing is complete coverage of the testing. Complete coverage of the testing How we do the complete coverage? Because we make sure that each requirement has at least one test case, one or more than one test case. Okay guys, so this ensures the complete coverage of the testing. Another point is it helps us to find the root cause of the defect. How we get the root cause of the defect? Because it is mapping to the defects as well. So from defect we will find out like which test case it belongs to. From test case we'll find out what is the scenario, and from scenario what is the requirement. So this is how we can get the root cause of the defect. So this is a very important document guys as far as testing is concerned. So let's talk more about traceability matrix. In this document the test cases are mapped to the corresponding requirement to ensure the coverage of the test cases, to find any gap between requirement and test cases. It is also known as requirement traceability matrix, RTM, or cross reference matrix, RTM or CRM. These are the other names guys. It is prepared before the test execution process. So basically we have three types of traceability matrix. We have forward traceability matrix, that is done before the execution process. So usually we do the traceability before the execution process, but there is another traceability matrix we have backward, which is done after the execution guys, and another we have bidirectional. So these are the three types of traceability matrix which we'll discuss in coming slides. This document is designed to make sure that each requirement has a test case. The test engineer will prepare traceability matrix for their respective assigned modules, and then it will be sent to the test lead. Later test lead will consolidate all the traceability matrix, all the documents, and prepare one traceability matrix for the project. So this is how usually we used to do that. So what are the goals of traceability matrix? It allows you to see if a requirement is fully documented or not. A requirement traceability matrix can even call attention to missing requirements. So this is we used to call attention to missing requirement. It ensures that the software completely meets the customer requirements. A traceability matrix can help in effort to provide proper and consistent documentation for your team. In the effort to provide, so it helps us to estimate the effort as well. It helps in detecting the root cause of any bug, so which we have discussed at the beginning of this video. So this is the simple sample of traceability matrix guys. So here I have taken an example of Gmail application. So here we have different columns. So we have serial number, and the second one is requirement ID. So here we have business requirement 1, BR1 1.0. So this is how we used to write the requirement ID. And the next one is requirement description. What is the requirement description? Summary of the requirement description. So here we have inbox, to test the inbox of Gmail. Another column we have is scenario. So what are the scenarios for this particular requirement, like for inbox? So we have mails, we have to mails sending the compose the emails, or the second one is reply, and then we have forward emails. So these are the three scenarios, and we have corresponding test cases to the scenarios. So here we have 5 test cases about this mail scenario, right? So here we have written like test case underscore Gmail, the project, and then mail, the scenario, and 01. So 01, 02, these are the test case ID guys. Now test case description. So summary of the test cases, like check the mail in the inbox, verify the open email, verify the read email, verify the downloads and attachment. So these are the 5 test cases we map to this particular scenario. 5 test cases, right? Similarly we have reply, so couple of test cases for this reply emails. Now here we have test results. What is the result of the of our test cases? Like, so out of 5 we have 1 pass, this is also pass, the second one is failed, correct, and there is another one is failed. And we have corresponding, we are mapping to the defect ID as well. So here we map with the defects as well. So here I have given the defect ID, another column, and what is the defect status. So this is in open state, so if it is closed, so we can make it as closed as well. And here we have defect 2, corresponding we have status. So this is how we map to the requirement, from the requirement to the scenario to the test cases and test results and defect ID, guys. So this is the complete tracking of our testing activities, correct? Complete mapping of our requirements. So this is traceability matrix. So in the next video I'll show you the real-time template of traceability matrix as well, guys. Now let's move forward to the next slide. What are the types of traceability matrix? So the traceability matrix can be classified into 3 types, which are as follows, which we have discussed at the beginning of this video, which is forward traceability matrix, the first one. This is also called horizontal traceability matrix as well. Another one is backward or reverse traceability, or this is also called vertical traceability matrix. Another one is bidirectional traceability. Now let's talk about each one of them in detail. So what is forward traceability matrix, guys? So forward traceability is used to map the requirements to the test cases, right? So how we do that? So whenever we get the requirement from the customer, when we start writing the test cases, so this is done before the execution. This is done before the execution, test case execution process. So we'll write all the requirements in the document, and then we'll map to each whatever test cases we have authored. So this helps to trace all the activities, right? All the requirements, whether we have captured the required test cases or not. In case of this forward traceability, so not only this will establish that every requirement is being tested from top to bottom, but it will also assist in confirming that project's trajectory is sound. The main objective of this to verify whether the product developments are going in the right direction or not. So whenever we have any change in the requirement, so we'll update the requirement from requirement got it will update by the BA, and then further we'll update our test cases as well, and then we'll map to the right test cases. So this is how it is happening when we follow this forward traceability matrix. So this goes in forward direction, correct? So later on we'll execute the test cases based on whatever test cases we have written, correct? And then we'll map to the whether what is the result of the test cases and then defects as well. This is forward traceability matrix. Now if you talk about backward or reverse traceability matrix, or this is also called vertical traceability matrix. So you can make a backward traceability matrix by mapping test cases with the requirements. So this is just reverse, guys. From the test cases we map to the requirements. So this is usually done after the execution. So once our execution is done, once we got the requirement from the customer, so we have written the test cases, now execution is done. Now from the execution we'll map to the requirements, correct? And this is usually done when there is no scope of changing the requirement in the application. So the reverse or backward traceability is used to check that we are not increasing the space of the product by enhancing the design elements, code, test, other things which are not mentioned in the business needs. So this is the main important point of the backward traceability matrix. So basically we use these when the scope of development is not changing frequently or not changing, right? So the main objective of this, that existing project remains in the correct direction. Another one we have bidirectional traceability. So what do you mean by bidirectional traceability matrix? So bidirectional traceability essentially combines forward and backward traceability into one document. So this is the combination of both, like forward and backward, guys. So and usually done before the execution and after the execution. So from the requirement to the test cases and from test cases to the requirement. This type is useful because it establishes that each requirement has relating test cases. It also evaluates the modification in the requirement which is occurring due to the bugs in the application. Let's say if any particular requirement is not correct and we got the defect, or if any requirement is missing, so this evaluates the modification of the requirement which is occurring due to the bugs in the application. So these are the 3 types of traceability matrix, guys. So if you have any questions related to any of the traceability matrix, then please let me know. Please write your queries in the comment box, and if you are new to this channel, then please subscribe this channel and click the bell icon to get the notification for upcoming videos. So probably in the next video I'll showcase you the real-time traceability matrix template. So thank you guys for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to showcase you the real-time test requirement traceability matrix template. So guys, in the last video we talked about what you mean by traceability matrix and what are the different types of traceability matrix. If you haven't watched that video, then please go and watch that video first and then come back to this video so that you can understand better. So as part of this video, we'll talk about this test requirement traceability matrix template and what are the different fields we have in detail. So guys, if you really need this template, then please mention your email ID in the comment box of this video so that I can send this template to your email ID. So let's talk about this requirement traceability matrix in detail about this particular template. So as part of this template, guys, we have different fields over here like project name. So we need to mention the project name over here, project ID, project manager, project type. What is the type of project we have? So all the details we need to fill before we start to use this template. And we have create date and last updated on and client name. So these are the different details we need to fill before we start using this template. And whenever we update the template, we need to mention the last updated date over here. Create date will be the start date when we start using this template. Now the next thing is what are the different columns we have. Correct. So we have serial number, first one, serial number, and requirement ID. What is the requirement ID? So we got the business requirement document from the customer, or which is prepared by the business analyst. So we have different points over there, right? Business requirement points. So here we need to mention all the requirements point so that we can map to the corresponding test cases. So here we have business requirement 1.0. So if you remember last time I have taken an example of Gmail application. So based on the different scenarios or test cases, I have used this template for now. So here we can see BR 1.0. So we have corresponding what is the requirement description inbox, okay, and source of requirement. So there are two types of source of requirements. Either it could be new requirement or change request. So this particular, let's say this is just an example, okay. So this particular requirement is new requirement. And what are the different scenarios we have? So we have three scenarios: mails, reply, and forward emails for this new requirement, and we have corresponding 5 test cases. So this is how we map from the requirement, right? So 5 test cases we have written for this particular requirement, which is BR 1.0. And here we have in this column, so this is the test case ID column, and here we have test case description, summary of the test cases here. So for 5 test cases we have mentioned like what is the description of each ID, each test case ID. So check the mail in the inbox, verify the open email, whether we can open the email or not, verify the unread email, verify the downloads and attachment in the email, verify to navigate to different pages. Now we have corresponding test results, another column. What are the results of the test cases? So we have pass, fail, like that. And we will map to the defects as well. So here we have mentioned defect 01, and what is the status of the defect at last column. So here we have open defect, or if it is closed then we need to mention like closed. So this is how we we can map different requirements to the scenarios and the test cases and the results and defects. So this is kind of mapping, guys, for the like all the testing activities. So this is called test requirement traceability matrix. And if we have, let's say, if for any project we have different requirements, right? So as part of business requirement document, so we have, this is BR 1.1. So here this is BR 1.0, and here we have 1.1. So similarly we need to list down all the BR points over here, all the business requirement document, business requirement ID. Now if you see this template, so the first sheet is summary. So this is summary of requirement traceability matrix. So how many what are the total number of requirements. So here we have 16. What are the new requirements? So 9 are the new requirements. What are the change requests? So 7 are the change requests. Requirements approved, so 5 of them are approved, 4 are not approved. Requirements deferred, so 4 of them are deferred. Deferred means we will make into the next release. Okay. Requirements rejected, so 3 requirements are rejected due to various reasons. Okay, if that is not feasible, or if any requirement is not clear, or maybe it is not I would say like it is not feasible with the application, so we can reject those requirements. That is part of business analyst. So this is summary of requirement traceability matrix, guys. Now the last one is, so the first tab is summary, second one is requirement traceability matrix, and third one is revision history. So here we need to mention the serial number and date of the date whenever we update this requirement traceability matrix. What is the version number? So initially we will give like version 1, and date will give, and prepared by who is the tester who is going to prepare this traceability matrix, and it should be approved by the higher authority. Like if tester is preparing this traceability matrix, then test lead should review it and approve it, and if you have any remarks, then we need to mention in the remarks column. So this is about this traceability matrix, guys. So if you really need this, then please send out please mention your email ID in the comment box of this video, so that I can send you this traceability matrix. So this is all for today, guys, and if you are new to my channel, then please subscribe this channel and click the bell icon to get the notification for upcoming videos. Thank you for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about test execution. So as part of testing lifecycle, we have covered so far requirement analysis, test planning, test design, test execution. So far we have covered till test design. Now today we are going to talk about test execution. Later on we'll discuss about defect reporting and test closure. So these are the different stages in software testing lifecycle. So far we have requirement analysis, test planning, test design, where we have written the test cases. So if you haven't watched those videos, guys, please go and watch those videos first and come back to test execution. So once our test cases are ready, and once environment is set up and build is ready for testing, so what developer does is, once development is done for any particular product, so they will release the software to the testing team for execution purpose, and then we'll execute our test cases as part of test execution process. So there are some preconditions, and we have to set up the environment as well. So let's talk more about what do you mean by test execution and how we are going to test the application in as part of test execution. So in simple terms, test execution is the process of executing the test cases and comparing the expected and actual results. So if you remember, guys, while writing the test cases, we have written expected results, like what will happen when we log in the application, when we enter the username and password and click on sign in button, when we enter the valid username and valid password and click on sign in button. So what should be the expected result? So we should see the home page, right? So that is expected result. So as part of test execution, we execute our test cases to make sure that and compare the expected with actual results, whether we are able to get the home page or not. So that is just an example. So that is nothing but the execution. So we'll execute the test cases once we get the build from the developer. After developer finish the coding and give the build to the tester, tester will conduct the testing and validate the application as per the requirement. So as per the requirement, we have written the test cases. Now it's time to execute our test cases because build is ready, right? The developers will prepare the below document and give the testing team during the build release. So there are a couple of documents they used to prepare. One is SRN, software release note, and another one is DD, deployment document, like how a particular build should be deployed. So one is software release note and one is deployment document. Software release note is nothing but they will give the version and the build name and the product name, all these details related to the particular software they will put in SRN document, and deployment instruction in deployment document. Tester deploy the build in test environment as per the instruction in the release document note. The build is deployed in test environment either by tester or developer. So build is deployed either by tester, developer, or by network team. So once we get the software from development team, guys, so they will send the build, and a tester, either tester, developer, or network team will deploy the build on particular server. I have already spoken about what do you mean by build and release, so probably you can watch that video. I'll provide the link in the description box of this video so that you can understand better. So as we know that after build release, the first test should be performed is sanity testing, right? After sanity test is passed, we will continue test execution and validate all other functionalities. So sanity test, you will check like whether this build is capable enough of further testing or not. So that is the purpose of sanity testing. So once sanity testing is passed, then we go for the further testing. Test execution can be done either manual or automation. Testing performed by tester without using any tool is called manual testing, and when we use any automation tool, that is automation testing. During execution, validate all the test cases and specify actual result and status. So I have already shown you in the test case document, we have expected result and actual result, and we have a status column where we mention like fail or pass based on the whether our test cases is matching with the expected result or not. If the status is failed, we can report that as defect to the developer. Okay guys, so we are going to use the defect report template or any defect tool as well. So there we report our defect if it is not matching with the expected result. So we'll report the defect to the developer. So let's talk about what is software release note. So a release note refers to the technical documentation produced and distributed alongside the launch of new software product or product update. So they will give the release note. So generally we use the release note when we deploy the software into the production. So we'll give the release note. In testing environment also, in some companies we used to get, for some products we used to get the release note as well. And it briefly describes a new product or a specific detail level changes included in a product update. So whether it is a new product or any changes in the product, so it describes in the form of release note. A software release note template is simple document that companies use to document any changes to their product. Elements of release notes template are like build version. So this is what I have discussed: build version, build location, requirement in the build, precondition, environment, deployment steps, known issues, defect files, prepared by who is going to prepare that release note. So these are some of the fields which are there in the release notes. So this is about execution, guys, how we are going to do the execution as part of testing lifecycle. Now in the next video we'll discuss about defect report, and later on we'll talk about defect lifecycle as well. So once we get any defect, so we'll talk about the defect report, how we are going to report the defect, what is the format of the defect report, and what are the different fields which we need to mention as part of defect report. So this is all about today, guys. Thank you for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about defect report in testing lifecycle. So as we all know that we have different stages in software testing lifecycle, like we have requirement analysis, test planning, test design, test execution, defect reporting, and test closure. So these are the various stages in software testing lifecycle. So we have already covered requirement analysis, test planning, test design, test execution, and today we are going to talk about defect reporting. So guys, if you haven't watched the previous videos, then please go and watch those videos first and come back to this video. So as part of this video, I'm going to talk about what is a defect, what is defect report or defect reporting, and we'll discuss about what are the various reasons for which we used to get the defect in the application, and what are the various fields are there in defect report template, and at last I'll show you the real-time template of defect report as well. So let's get started. So let's talk about first what is a defect. So whenever we test any application, guys, and if any functionality is not working as expected, so that means there is a defect in the application. So let's say we are testing any application where we have let's say we are testing the login functionality where we have username, password field, and we have sign in button, and while entering the user ID, correct password, and click on sign in button, we are not able to log in into the application. So that means there is a defect in the application, correct? So there is a defect in the application because our expectation is we should get the login page, we should get the home page, or we should get the successfully we should be able to log in into the application, correct? Now we got the defect. Now that defect has to be reported to the development team. So how we are going to report to the development team, correct? So there are two ways we used to report to the development team. So the first way is, like some of the companies are using the Excel sheet. So there are various fields in Excel sheet, or you can say in defect report template. So these are the different fields available in defect report template, which talks about the details about the defect when we raise a defect. Like we have defect ID, we have summary of the defect, we have status, and we have priority, severity. Like that, we have various fields in defect report template, guys, which we are going to discuss in coming slides. So this is one of the way to report the defect to the development team. Another way is using bug tracking tool. Like we have Jira, Bugzilla, PR tracking. So we have various tools available in the market using which we are going to assign the defect to the development team. So this complete process is called defect reporting, and this template is called defect report template. And we have the same fields in bug tracking tool as well. Like it generates the unique ID, which is defect ID. We have summary of the defect we have to mention over there. We have steps to reproduce. Like that, we have various fields in bug tracking tool as well, which we are going to discuss in coming slides. Now question arises here is why we are getting the defect in the application. So there could be various reasons. So first reason could be missing requirement in the application. So let's say we are developing a website, and that website should have home page, dashboard, admin page. Let's say home dashboard page is there, admin page is there, some other pages should be there, and along with that we should also have about us and contact us page should also be there as per the requirement. But while developing the this website, developer misses this contact us page. So that means there is a defect. We can raise that as a defect. We have to raise that as a defect in the defect tracking tool or defect report template. So this is one of the reasons, guys. Another reason could be wrong implementation of the requirement. So let me give you an example. Let's say we are developing a website. The website name is abc.com, and while launching this URL, we should get two buttons over here. One is sign in page, which is for the registered user. When we click on this sign in, we should get the user ID, the login page, user ID, password field, and sign in button. We should get the sign in page. And while clicking on this sign up, right, and this is sign in. So sign up is for the new user, so this is complete user registration page, guys. So what happens here is, let's say while clicking on this sign up, we are getting this login page only, correct? So this is wrong implementation of the requirement. Another reason could be while getting the why used to get the defect is misunderstanding of the requirement, misunderstanding or misunderstood the requirement by the developer. So let's say as per the requirement in the application, the logo of the application should be displayed, the logo of the company or website should be displayed at the right side of the page on every page of the application. But what happens is while testing the application, we got that the logo is displayed at the left side. So that means this requirement is misunderstood by the developer. While developing the software, they developed this logo at right side of the pages, right? So we have to raise that as a defect. So these are the various reasons, guys, we used to get the defect in the application. Now let's talk more about the defect report, like what are the various fields are there in defect report template, and at last I'll show you also like the real-time template as well. First, let's just recap like what we have discussed so far. So if application is not working as expected, we can report that as a defect in the defect report. And what is defect report? A defect report is a document that has concise details about the defects are identified, what action steps make the defect show up, like reproducible steps, and what are the expected results instead of the application showing error while taking particular step-by-step actions. So basically a defect report is a document where we talk about different details about the defect. We have to mention like defect ID, summary of the defect, status of the defect, and what is the reproducible steps, like what are the actions which we are going to perform to get that defect, correct? Defect reporting, defect tracking, and status tracking is called defect management. So the complete process is called defect management. Some companies use manual process like Excel worksheet, which we have discussed, and some companies use tool based process for defect management. So some of the defect management tools like Bugzilla, Issue Tracker, PR Tracker, and Jira as well. Jira basically is a project management tool, but we can raise the defects over there. So it's kind of complete project management tool. So this is the defect report template, guys. We have various fields in defect report templates, like we have defect ID, summary, detected by the tester who found the defect, detected date, assigned to, severity, priority, status, build version. So let's talk about, let me just show you the real-time template. So we'll discuss about various fields in defect report template as well. So this is the defect report template, guys. So here you can see we have various fields like defect ID. Defect ID is the unique ID which we need to make while logging the defect. Okay, so here you can see defect _01. So this is the unique ID. For defect 2 we have defect 02, defect _02. So this is the unique ID. While logging the defect in the defect tracking tool, also it generates the automatic defect ID when we log any defect in the defect tracking tool, like Jira. When we log in the defect, we used to get the defect ID. Now the second column is login summary of the defect, like what is the description of the defect or summary of the defect, like login functionality is not working. Here I have mentioned like login functionality is not working. And third column is detected by. So who is raising this defect, who raised this defect? So here I have mentioned tester _A. Tester A found this defect, and the date on which we got the defect, and assigned to. So assigned to, initially when we raise the defect, when the status is new, so it is assigned to that particular tester, and when we open that defect, so it should be assigned to any developer. So here I have assigned it to developer _A. Developer A is assigned to this particular defect. And severity and priority. So here we have high severity and high priority, correct? So what do you mean by severity? Anyway, I'm going to talk about them in detail in separate video, but let me just talk brief about what is severity and what is priority. So when we talk about the seriousness of the defect, so that means it is severe defect. Okay, so like we have to give some severity to the defect. Like we have different ranges, like high, medium, low. So if it impacts the functionality of the application, so that means severe defect, correct? And we have to assign some values like high, medium, low. So in this case we have login functionality. So login functionality itself is not working, so that means it impacts the impact of this defect is very high because it impacts the functionality. So here we have given high priority because we cannot move further for the testing. What is priority? So this is importance of any defect. So this defect is very important. Login functionality is not working, so this is very important to fix by the development team, correct? So this is prior defect. we should assign this as a high priority defect, because until unless if we don't fix this, then we cannot move ahead for the testing, right? And the next column is status. We have open state over here, like this is current state of the defect is open state. Now it is assigned to any developer. Now once developer is fixed this defect, they will make it as fixed, correct? Now later on they will make it as retest. Retest means they will assign to particular tester, so we need to retest that defect, and later on once we retest, we have to make it as closed. If it is working fine, closed. If it is not working, then we have to make it as reopen. So there are various states are there, guys, for a defect, which we are going to discuss in defect life cycle. Probably in the next video I am going to talk about defect life cycle. Next video I am going to talk about priority and severity, and later on we'll discuss about defect life cycle, so that you can understand better. And the next column is build version. So here this is the build on which we have tested this application, and we got the defect version 1.5. Module is login module. Next one is what is the environment. So we have various environments, like we have test, development environment, UAT environment. So for this particular defect we got on test environment. So here I have mentioned as test. Functional defect type, what is the type of the defect. So here we have, let's say we have functional type or non-functional or performance. So we have various defect types as well. So here I have mentioned functional type because this is related to the functionality. Reproducible, whether we are able to reproduce this defect or not. So here I have mentioned there are two values, yes or no. So here I have mentioned as yes, because this issue is reproducible. Sometimes it is kind of incident, we are not able to reproduce that defect, so we have to mention it as no, but we have to take the screenshot in that case as well to give the evidence to the development team for further investigation. Reproducible steps. So here we have given the complete steps, like how we got this defect. So like launch URL abc.com, enter valid username, enter password, and click on sign in. And what should be the expected result? User should be able to log in, correct, after following these steps. But what happens is user is not able to log in. Nothing happened when clicked on sign in button. So in some of the defect report templates, expected and actual results are not there, but in some of the templates the actual and expected results are there in the defect report template as well. So after clicking on sign in button, we should get the login page. We should get the home page, right? User should be able to log in into the application. And we have at last comment column as well. So if you have any remarks or comments, so we have to mention in this particular column. Now let's talk about the next defect. So here I have given defect _02. Logo of the company is not correct. So the summary of the defect is logo of the company is not working, which is detected by tester 2 and on this particular date and assigned to developer C. And this is the priority and severity. So here we have low priority and high severity, guys. So why it is low severity and high priority? So why it is low severity? Because it does not impact the application functionality, correct? So that's the reason I have given as it as low. And high priority, because logo is very important, right? That represents the company, that logo. So if it is not correct, so that means that is high priority defect. That has to be fixed as soon as possible. And this particular defect, the status of the defect is closed. So like that we have to mention the status as well. This defect has been fixed and closed. And we have build version, we have module. Here you can see the environment on we got in UAT environment, and defect type is functional, like this. So this is what about the defect report template, guys. We have various fields in defect report template. So if you have any questions related to defect report, please let me know in the comment box, and in the next video we are going to talk about priority and severity of a defect. So thank you guys for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is defect priority and defect severity. And this is an important interview question as well, guys. So in the last video I talked about what do you mean by defect, what is defect report, what is defect reporting, and I have shown you the real-time defect report template as well, where we talked about what are the various fields in defect report template. So let me just recap what we have discussed so far. So whenever we test any application, guys, so let's say this is my application under test. Whenever we test any application and if any functionality is not working as expected, so that means there is a defect in the application, right? If any functionality is not working as expected, so that is a defect, and that defect has to be reported to the development team to get it fixed by the developer, correct? So how we are going to assign it to the developer, how we are going to report it to the development team? So there are two ways which we have spoken about in the last video. So the first one is some of the companies are using Excel worksheet to report the defect, to raise the defect and report it to the development team. So we have various fields which represents the defect, correct? We have various fields in defect report template. And the second way is using bug tracking tool. Using that we can raise the defect and assign it to particular developer. So these are the two ways, guys, and we have spoken about various fields in defect report template. So we have ID of the defect, we have summary of the defect, the date on which we raise the defect, steps to reproduce, status of the defect. Similarly, we have two more columns, we have priority and severity. While raising the defect, we have to assign these two values as well. We have to give values of what is the priority of the defect and what is the severity of the defect, correct? And the similar way, while assigning the defect, while tracking the defect using bug tracking tool, while raising the defect, we have to give these two values as well, priority and severity. And there are three ranges of values. Generally we have high, medium and low for both priority and severity. So this is the topic for today, guys. So basically, what do you mean by priority? Whenever we you might have heard like high priority defect or high severity defect. So what do you mean by that, correct? Which we are going to discuss, and I'm going to give you different examples like high priority, high severity, low priority, low severity, medium priority, like that. So we are going to discuss about different examples as well. So let's talk about what do you mean by severity first. So basically, severity defines the impact of the defect, like how severe the defect and how it impactful, right, to the application which we are going to test. Basically, it talks about the seriousness of the defect, like how seriously it impacts to the application, correct? So that is nothing but the severity. And as we have discussed, we have three ranges: high, medium and low. If you say like high severity defect, so that means it has high impact on the application. If you say like high priority, so that means we cannot go further for testing, like it has a lot of impact on the application, kind of a blocker issue, correct? So that's how we are going to assign like high, medium and low. Low has low priority, which has low priority, and medium has the medium priority, correct? As we it indicates like high, medium, low. If we talk about priority, what do you mean by priority? So basically, priority indicates the importance of the defect, like how soon the defect should get fixed, how soon the defect should be fixed, correct? So again, we have three ranges in priority: high, medium and low. If you say like high priority, so the impact of the defect might not be that serious, okay, it might not be a serious issue if you see the functionality wise, but the priority of the defect is very high, and it could be like high severe bugs as well, high severe defect as well. So priority means if you assign like, if you say like high priority defect, so that defect should be fixed as early as possible. Similarly, we have medium and low based on the priority. So priority defines the, basically it defines the timeline of to fix the defect, and severity talks about the impact of the defect on the application. Now let's talk more about priority and severity, guys. So let me just recap what we have discussed so far. So severity defines how impactful a bug can be to the system. It can values either high or medium or low, specifies the seriousness of the defect. If you talk about priority, so priority indicates how soon the bug should be fixed. it can values either high, medium or low. It specifies the importance of the defect, which we have discussed guys, or the functionality. Okay, so the defect are fixed based on priorities. So whenever we say like high priority defect, so that should be fixed earlier. If you say like medium, so it depends on like how soon it should be fixed, correct? So we have three ranges for priority and severity. Now let's talk about the different examples of priority and severity guys. So let me just draw a table. So let's say here we have severity, we have defect priority, and here I'll give some examples. So let's talk about high severity and high priority defect. High severity and high priority. So what are the examples guys? So let's say we are not unable to log in into the application. Unable to log in. So let's say we are testing a website and we are able to launch the URL, and while entering the username, password and click on sign in button, we are not able to get the home page. We are not able to sign in into the application, correct? So that is an example of high priority. Why it is high priority? Because this is the importance of defect is very high, correct? This has to be fixed because this is kind of blocker issue. We cannot move further. So that's the reason we have assigned it to high priority. And high severity, the impact is more, correct? The impact is lot because we are not able to log in into the application, so we cannot test further. So this is an example of high severity and high priority. Another example you can say high priority, high severity is, let's say while launching any website, and we are getting 500 internal server error or 404 page not found. So these are the examples of high priority and high severity. Again, why it is high severity? Because the impact of the defect is very high, because we cannot launch the application itself, because we are getting 500 internal server error or 404 page not found, correct? So severity is very high. And why priority is very high? Because this defect is very important to get it fixed as early as possible, because until unless if it is not fixed, then we cannot move further for testing, correct? So these are the example of high priority and high severity. Now let's talk about low severity and low priority defect guys. So any spelling mistakes on the web page. So let's say we have a website, and at the end of the page, end of the website or end of the page, we have at bottom we have some spelling mistakes. So that could be an example of low priority, because low priority means it is the spelling mistakes at the end of the page, right, at last page, and that too at the bottom of the page. So that it does not have that much importance, correct? And why it is low severity? Because it does not have any impact to the application. There is no impact if you talk about the functionality wise, correct? So that is an example of low priority and low severity, any spelling mistake. And let's say spelling mistake is on front page, on maybe login page, we have at bottom we have some spelling mistake. So that could be an example of medium priority, but still it will be low severity because it does not have any impact to the application guys. So this is an example of low severity and low priority, and low severity and medium priority. Any UI defects also, that could be an example of low severity, any UI examples, but priority may vary from low to high, any UI defects. Now let's talk about medium severity and high priority. So let's say we are testing inbox of Gmail page. Okay, so we have different emails over here in inbox. Okay, and at a time we are able to delete only one email. We are able to delete one email at a time, but while selecting all the emails we are not able to delete that. So this is an example of medium severity. Why it is medium severity? Because we are able to test the delete functionality. However, we are able to delete only one email at a time. So that's the reason it is medium severity. But why high priority? Because we might need to delete all the emails together, right? All the emails at one time. So that is an example of high. So that's the reason we have assign it as high severity, high priority defect, correct? So this is an example of medium severity and high priority. Now let's talk about low severity and high priority defect, guys. High priority. So logo of the company is incorrect. If logo of the company is incorrect, so that means that is high priority defect, because logo represents the company. So that is high priority defect. Low severity because it does not have any impact on the application. Another example could be for this, like high priority, low severity. Let's say logo is as per our expectation, like as per business requirement, it should be at right side, but developer developed at left side. Okay, so that is another example, because as per the requirement it should be at right place. So that is an example of high priority and low severity defect. So these are the various examples of priority and severity, guys. So if you are not able to get it, then please let me know through your queries. You can comment it in the comment box, and like this video, share it, and if you're new to my channel, then please subscribe this channel and click the bell icon to get the notification for upcoming videos. Thank you so much for watching, and in the next video we are going to talk about defect lifecycle. So thank you guys for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is defect lifecycle, and this is an important interview question as well, guys. So whether you are doing manual testing or automation testing, you should know what is a defect lifecycle. So basically you should understand what are the various stages of a defect. So guys, earlier we have spoken about what do you mean by defect, what is defect report template, and in the last video we have spoken about what is defect priority and defect severity. So today we'll focus on what do you mean by defect life cycle. So let's get started. So defect life cycle, also known as bug life cycle, is the journey of a defect cycle which a defect goes through during its lifetime. So this is also known as bug life cycle. So defect life cycle or bug life cycle is the journey of a defect basically. So it goes through various status, correct? So while talking about defect report template, guys, we have spoken about status column. So when we raise the defect, we have various stages of a defect, various status of a defect, right? So when we raise for the first time, so the status of the defect would be new, and then when it is assigned to any particular developer, so the status of the defect would be open, and then they will work on the defect. So they will make the status to fixed, and they will assign it back to the testing team, and the status of the defect would be retest. So these are the various stages of a defect, guys, various status of a defect. Whether we are logging the defect in the manual using manual process, using Excel sheet, we have a status column. There we'll change the status of the defect every time when we work on the defect. Any team when they work on the defect sheet, right? Or using any bug tracking tool also, so we have to change the status accordingly. So this is nothing but the various stages of a defect, guys. So this is defect life cycle. So defect life cycle is cyclic process which describes how a defect or bug passes through different stages, from the identification of defect stage to the fixing of the defect stage, correct, to the fixing stage. It begins when a tester finds or logs a bug, and it ends when bug is fixed. So this is nothing but the defect life cycle, guys. So it goes through various stages of the cyclic in the cyclic process. from the identification of the defect to the fixing of the defect. Now let's talk about defect lifecycle in detail, like what are the various status of a defect. So whenever we test any application, and if any functionality is not working as expected, so that means that is a defect, right? So we have to raise that defect in the Excel worksheet if you are following the manual process or using bug tracking tool. So what is the first status of the defect? So the first status of the defect would be new. Now we have raised the defect. Now we have to assign it to the development team, right? So it will be fixed by the development team using any particular developer, right? It will be fixed by any particular developer. So the status of the defect would be open when we assign it to any particular developer. So the next status is open. Now they will work on the fixes, they will work on the defect, and they will fix the defect. So the status of the defect would be fixed, and they will assign it back to the testing team. Now it is our responsibility as a tester. We have to rework on the defect, we have to retest the defect. So what is the status of the defect this time? At this stage, retest. Now while retesting the defect, if we find that if defect is not working as expected, if it is not working as expected, so we will reopen the defect. We will reopen the defect and assign it to development team. So the next status is reopen, and we will assign it to development team. So they have to rework on their fixes, and once again they will fix the defect, they will make the changes to their code, and then they will assign it back to testing team. Again we have to retest the defect, and if it is working this time, if it is working as expected, so what is the last status of the defect, guys? If it is working fine, then we will close the defect, which is the last status of the defect. So this is the complete defect life cycle, guys. Apart from this, we have some other status of the defect, other statuses as well. Like if they are not accepting the defect, if developer is not accepting the defect, so they may reject the defect as well. If they say that defect is, if they not accept the defect, so they will reject the defect. So the status of the defect would be rejected. And then again we have to like follow whether it is really a valid defect or not. We have to assess that, right? Whether we have logged the correct defect or not. In case if you find that if it is a valid defect, then we have to showcase them to the steps to reproduce, and they will make it as again open, right? We'll assign it to any particular developer. But in case if they find that if a defect is not valid defect, so they may reject the defect as well. Another status of the defect would be duplicate. If any defect is matching with any previous defect, if any defect is matching with any previous defect, so the developer will make it as duplicate defect. And we have one more status, deferred status. So if any defect is not that much important to fix in this particular cycle, so we may fix that into the next cycle. So that's why we have another status called deferred state. Now one more status we have, guys, not a bug. So if any defect does not impact the functionality much, right? So we have another status, not a bug. We have another status called not a bug. So these are the various stages of a defect life cycle, guys. So this is complete defect life cycle. Now let me just recap what we have discussed so far. So new what are the various status we have discussed so far. So what is new status? So new defect is reported is called new status. We have open state, right? Open status of a defect. So the developer is currently working on the defect, that is open state. What is fixed? The code changes are completed and the defect is resolved, that is fixed status. Deferred, developers will fix the defect later in the next cycle. So that is deferred status. Duplicate, the defect is same like one of the previous defect. When previous defect is fixed, it is also fixed. So that is duplicate defect. Retest, the tester starts the task of retesting the defect to verify if the defect is fixed or not. So that is retest. Rejected, developers did not accept the defect, is rejected defect. Close, after retest, if defect is working correctly, so that means that is the status of the status of the defect would be close. Reopen, after retest, if defect is still exists, then we reopen the defect. And at last we have not a bug. If defect does not have an impact on the functionality of the application, then the status of the defect gets changed to not a bug. So this is complete discussion about the defect lifecycle, guys. If you still have some doubts or questions, then please write your questions in the comment box of this video, and please like and share this video. And if you are new to this channel, then please subscribe this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is defect leakage. So let's get it started. So what do you mean by defect leakage? So some of the defects are escaped from one level to the next level of testing is called defect leakage. So what happens is, while doing the testing, as a tester, when we perform testing, so some of the defects are missed by the testing team and found during the UAT testing, which is nothing but the user acceptance testing by the end user. If some defects are missed by the testing team and caught during the UAT testing or in production, if those defects are found during UAT testing or in production, so that is nothing but the defect leakage, because those are missed from one level and found in the next level, right, which are missed during during software testing by the testing team and found in UAT or in production. So that is nothing but the defect leakage. In other words, a defect which exists during testing yet unfound by the tester, which is eventually found by the end user, is also called bug leakage. So this is also called bug leakage, guys. Bug leakage, or you can say simply defect leakage. Defect leakage is the metric which is used to identify the efficiency of the QA testing, that is how many defects are missed, slipped during QA testing. So this is one of the metrics, guys, we used to use this to measure the efficiency of the QA testing. Defect leakage formula. So what is the formula of the defect leakage? How we calculate the defect leakage? So we have formula CD divided by DR minus ID. So what is CD? So CD is nothing but the defects found during UAT testing or in production, divided by defect raised by the testing team minus invalid defect. So defects found during UAT testing or in production, defects found in production, divided by DR, defect raised by the testing team minus invalid defects, multiplied by 100. So let me give you an example. So let's say we found 10 defects in production, or maybe we found during UAT testing 10 defects found by the end user, divided by, let's say, 200 defects raised by the testing team minus 20 defects are invalid in those 200. So that means 10 divided by 180, so it will come around 5.5%. Correct guys. So that is nothing but the defect leakage percentage. So 5.5% defects are slipped from one level to the another level, from QA testing to the UAT level, to which is caught by the end user. Correct. So ideally, if you have like 5 to 10%, that is kind of acceptable, but if it is beyond that, like 15 or 20%, so we need to really think about our QA testing process. We need to improve the process to minimize the defect leakage. So let's talk about like what are the various reasons we used to get the defect leakage and how we can minimize the defect leakage. So what are the various reasons, guys, we used to get the defect which are missed during software testing, which are missed by the tester and found during UAT testing or in production. So absence of proper review process. So this is one of the important point, guys. So when we are unable to do the proper review process, then we miss some functionality. Like we need to do the proper review process while reviewing the test cases or reviewing the complete testing process. So we should do the proper review process, right? In case if you are unable to do so, then we miss some functionality, and the defects will be found in production or in UAT. Another reason could be environmental differences. So sometimes what happens is when we do testing in our testing environment, so some of the functionalities we are unable to test properly, right? And during the UAT testing, the environment is different, so they are able to reproduce the defect, or defect is caught during the production environment. Okay, so that is one of the one more reason. Another reason could be missed test cases. So this is important point, guys. Missed test cases. If we are unable to write the test cases for any particular functionalities, and then obviously if you are unable to test that, then definitely the chances of getting the defect in the UAT environment or production environment will be more. Another reason could be poor design test cases. Poor design test cases. Poor design test cases because of misunderstanding of the requirement by the testing team. So that is one of the reasons. Another reason could be incorrect deployment. Incorrect deployment into production or in UAT environment. In UAT environment or in production environment. So that is another reason for defect leakage. Another reason could be, that is also important, which is incorrect data. Incorrect data. So if we are not able to use proper test data, so definitely the chances of defect leakage is more, right? So we should do the proper testing, and also you should use the proper test data, correct, to test any particular functionality. So these are the various reasons, guys. Now let me just talk about some of the prevention techniques or prevention points which we can using which we can minimize the defect leakage. So the first point is we should do the proper review process. Proper review process of our testing, or proper review of our test cases. Another point is design proper test cases, or we can say the coverage of the testing should be proper. Proper coverage of the requirements, right? So we should understand the requirement well and then write the test cases accordingly, and then coverage should also be 100%. Another point is we can focus on some of the functionalities where the defect leakage chances is more. So that is another point, guys. So focus on modules where chances of defects is more, and we should do the proper regression testing, guys. Proper regression testing to make sure the impact of the functionality in other modules. Okay, so these are the various points, guys, which we should take care while doing the testing process. Okay, while doing the testing. So if you follow this process, then definitely will minimize the defect leakage percentage, right? So guys, if you have more techniques or if you have more points, then you can write in the comment box. And still, if you have any questions, then please write your questions in the comment box of this video. Thank you for watching this video. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is defect clustering, and this is one of the testing principles, guys. So let's get started with defect clustering. So what do you mean by defect clustering? So when defects are found in a group while testing any particular module in any application is called defect clustering, or in other words, when we found group of defects on any particular module is called defect clustering. So basically clustering is nothing but group, right? So let me just explain further. So while testing any application, let me just represent with two axes. Let's say this side represent defects and this side represents modules. So in this application, let's say we have different modules, module A, module B, module C, D and E. We have five modules in this particular application. Let's say we are getting the number of defects like these many defects for module A, these many defects for module B, these many defects for module C, and more number of defects in module D, and these many defects for module E. So you can see the defects are varying, right, from module to module. Okay guys, and we are getting more number of defects on this particular module, module D, more number of defects or group of defects in module D. So this is nothing but defect clustering, and it is based on Pareto principle, guys. Pareto principle. So what it says, or in other words you can say 80-20 rule. 80-20 rule. This is also called 80-20 rule. So what does it means? 80% of the defects are found in 20% of the module. 20% of the module. So here in this case we have 5 modules. So let's say the size wise the module we have divided, each is 20%. This is also 20%. So the size wise all the modules are same, correct? So we are getting 80% of the defects in 20% of the module. In this case we are getting 80% of the defects in module D. Okay, so this is Pareto principle, or in other words what you can say is we have written the test cases and 20% of the test cases are effective to get 80% of the defects in the application. So this is how you can understand, in other words, okay, 20% of the test cases are effective to get the 80% of the defects in the application. So this is Pareto principle. Now what is the reason we are getting most number of defects in this particular module, right? So the reason could be the complexity of the application, complexity of this particular module. So developer make a mistake while writing the logic or writing the code. So that's the reason we are getting more number of defects in this particular module. Now what we should do as a tester, right? So we should concentrate more on this particular module, and write more number of test cases using different scenarios for this particular module. But we should not forget at the same time other modules as well, guys. We are concentrating on this particular module because this is more error prone module, but we should also test the other modules at the same time. We should also concentrate on other modules as well. So this is about defect clustering. So this is the definition of defect clustering. So when a small number of modules contains most of the bugs detected or show the most operational failures is called defect clustering, or in other words when defects are found in group in any module is called defect clustering. When the defects are not distributed uniformly across the entire application, rather defects are concentrated or centralized across 2 or 3 functionalities. So that is nothing but the defect clustering. So this is about defect clustering, guys. If you have any doubts, then please write in the comment box of this video. Thank you for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about defect age. So let's get started. What is a defect age? So the time difference from defect found date to defect close date is called defect age. So let's say 20th of this month we found the defect, and in the next month 5th of the next month it got closed. So what is the difference? So here we have 15 days. So 15 days is nothing but the defect age. So this is calculated in days or in hours. when the testing team identified the defect and when the defect is fixed. So the difference between when we identified the defect and when defect is fixed. To know how much time it take to fix the defect by developer. So what is the use of this defect age matrix, right? So to know how much time it take to fix the defects by the developer. So this is nothing but the defect age. The defect fixed date may be the past date on which defect is fixed, or the current date if it is still open or unresolved. Okay guys, so it is not mandatory like when we fix the defect then we can calculate this defect age. If defect is still open state or it is in unresolved state, so till that date what is the difference? So that is again we can say defect age. We can calculate that particular day, the difference between those days, right? The defect age is calculated based on the two factors parameters. So there are two factors guys. One we can calculate based on the time, and another one is using phase, software development phases. Okay, I'll explain. So defect age in time, so how we can calculate? So defect age in time is the difference between the time of the defect detection and defect fixing. Means when the testing team identified the defect and when the defect is fixed. Mainly this defect age is calculated in days or in hours, as I have discussed earlier. So how to calculate defect age in time? So this is the formula guys. Defect age in time, defect fix solve date or current date if it is open state, defect detection date or identification date, the date when we got the defect, correct? So defect fixed date, or it is the open state of the defect, the day on which still it is open, right? Minus defect detection date or identification date, the day on which we got the defect. Defect age in phase. So how we can calculate defect age in phase? Defect age in phase is the difference between the phases of defect injection phase and defect detection phase. Here the phase refers to the different phases of SDLC. How to calculate defect age in phase? So this is the formula. Defect age in phase, defect detection identification phase minus defect injection origination phase, right? So let me just give you an example. So we have different phases in software development life cycle guys. We have requirement analysis, we have design, then coding, then unit testing, integration testing, system testing, acceptance testing, and maintenance finally, right? So let's say we found the defect in coding phase and it is detected in integration testing. Okay, it is detected in, the defect is originated in coding phase, but it is detected in integration testing phase. So here is the formula: defect detection identification phase. So it is identified in integration phase, and defect injection or origination phase, so it is originated in coding phase. So what is the difference? 2, right? So there is a difference of 2 phases, so the defect age should be will be 2 here. So this is how we calculate defect age in phases. So this is all about today guys. So if you have any doubts, then write your question in the comment box of this video. Please like and share this video, and if you are new to my channel, then please subscribe it. Thank you for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is defect masking. So what is defect masking in software testing, or what do you mean by mask defect? So we'll discuss about different examples of defect masking. So let's understand first what do you mean by mask defect. So mask defect, commonly known as a defect that hides other defect in the application, is called mask defect. So let me just explain. So let's say we are testing any application and there is a functionality A which we are testing right now, and there is a related functionality called B. So functionality B is related with the functionality A, and there is a defect we found while testing functionality A. So there is a defect in the functionality A, and there is a defect in functionality 2 as well, functionality B. So since we cannot execute functionality B without functionality A, so since we got defect over here, we cannot execute functionality B. So defect 2 is mask defect. So this part will be unnoticed because we cannot execute this part, right? So defect here in functionality B is called mask defect. Let me give some other examples, guys. Usually we used to get defect masking or mask defect in page navigation. In page navigation. So let's say we are testing any application, and in this particular application, let's say this is employee website where we have add employee functionality, add employee, and there is inside, so this is one page, page 1, add employee, and there is another page called add task. So we cannot go to this page, add task, until unless if we don't execute this page, right? If we don't navigate to this add employee page. So we found defect over here, add employee. We find that we are not able to navigate to this page, add employee. So we cannot go to add task page. So this part will be unnoticed, right? So whatever defect we'll get on this particular page, add task, whatever defects are there, which will be unexecuted, or we cannot execute this functional related functionality of add task page. So this is another example of defect masking or mask defect. Let me give one more example. So let's say we are testing any application, and we are printing some page on this particular application, and we have two printers. We have laser printer, and we have dot matrix printer. Now take an example. This is default printer, laser printer. So let's say we are printing any page, and this default printer is, we are not able to find this laser printer. Okay, take an example. There is no issue, but we are not able to find this because of connectivity. We are not able to find this laser printer. So what system will do? It will search for another printer, which is dot matrix printer. So there could be there are two functionalities over here. First one is search functionality, search for dot matrix printer, and second one is print the page, correct? So until unless we don't find the dot matrix printer, we cannot print the page. So defect on this print functionality is called the defect or mask defect here, over here, defect, right? So this is mask defect over here. So this part will be never be executed until unless we don't execute this search functionality. So there is a defect while searching the dot matrix printer. Okay, so this defect will be unnoticed forever, this print functionality of this dot matrix printer. So these are the different examples of defect masking or mask defect, guys. So let's talk about some theoretical stuff, like just recap what we have discussed so far. So when defects are hidden, like one defect may be hiding in the another defect in the application, is called defect masking. Mask defect is type of defect that is hidden in the software and hasn't caused a failure because another defect has prevented that part of the code from being executed. So there won't be that won't cause a failure because another defect has prevented that part of the code from being executed. It is only uncovered when the defect hiding it is uncovered by the user by performing a specific operation. Mask defects are the defects covered by or marked by another defect and can't be identified until the later is detected. So we talked about different examples of defect masking. So guys, this is all about this video. If you have any questions, please write in the comment box. So thank you for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic in software testing, that is defect triage. So you might have heard the term defect triage meeting many a times. So in this particular video I'm going to talk about what do you mean by defect triage, what is defect triage meeting, why do we need defect triage, and what is the process of defect triage, and who are all the participants of defect triage meeting, and at last I'll talk about the outcome of defect triage. So let's get started. So let's talk about the definition of defect triage first. What do you mean by defect triage? But before I start the definition of defect triage, let's understand the meaning of this word called triage. What is the meaning of this word triage? So in simple words, I would say to decide something, to decide the order is called triage, or I would say to sort it out something, or sorting is nothing but triage. So this is the simple definition or simple meaning of the word triage. Now what is the definition of defect triage? Defect triage is the process to prioritize the defects based on its severity, its priority, risk involvement in the defect with the defect, and last one is frequency. So these are the four factors, guys. Defect triage is the process to prioritize. Basically in defect triage we prioritize the defects based on its severity, like how bad the defect is. We have already spoken about severity and priority in previous video, so please go and watch that video if you haven't watched the related to severity and priority. So basically it talks about the severity of the defect, like to decide the priority, to prioritize the defects, we used to talk about its severity, because we used to decide the severity while logging the defect, right? So we used to talk about in defect triage what is the how severe it is, like how bad the defect is called the severity, like how does it impacts to the functionality, right? So that is severity. How important, what is the importance of the defect is called the priority, like how soon it should be fixed is called the priority. Risk involvement is nothing but the what are the project risk, or what are the business related risk involvement with the particular defect, and frequency is nothing but the occurrence. So these are the four factors we used to discuss to decide to prioritize the defect, prioritize the defects during the defect triage. And why do we need defect triage, right? And what is defect triage meeting? So to evaluate the process, to go about the defect triage process, we used to conduct a meeting called defect triage meeting. Now one question comes in your mind: why do we need defect triage? Why do we need defect triage or defect triage meeting? So the first thing is to prioritize the defect. That is simple thing, right? We used to decide we have to decide the prioritize of the defect. So that's why we used to go about this defect triage meeting. Another point is sometimes we have very less time to fix the defects before the release, and we have more number of open defects. So that's the reason we used to conduct this defect triage meeting. So this is the reason, guys, we used to go for a defect triage meeting. Now let's talk about what is the process of defect triage, or what is the process of defect triage meeting. So basically there are three stages in defect triage. We firstly we decide, we review the defect review, and the second thing is defect assessment, and at last defect assignment. So what do you mean by defect review? So first of all, we review all those defects, all those open defects, and then assess the defects based on we'll discuss about the root cause of the defect. So there are few things like root cause of the defect. Second thing is the complexity complexity, like how complex it is, like technicalities of the defect we used to discuss. And the third thing is business impact. How does it impacts to the business of the to the business, right? So these are the three things which we discussed during the assessment of the defect to decide the prioritize, right? So we have to discuss about all these points, like root cause of the defect, the complexity, whether we can fix on time or not, and then business impact, how does it impacts to the business. If it is very important, then we have to give higher priority to the defect. And last thing is defect assignment. We have to assign the defect to particular developer, particular team or particular developer to fix that defect. So these are the three stages of defect triage: defect review, defect assessment, and defect assignment. Now let's talk about who are all the participants of defect triage meeting. So in defect triage, generally we have project manager, and then we have technical team lead, development team lead, we can say team lead, TL, development team lead, and then we have test manager or test lead. So these are the participants, guys, and some optional, and one more business analyst. So these are the participants of defect triage meeting. Or optional are development team and testing team. So in many companies, they used to conduct defect triage with development team and testing team. They involve these members as well, but generally it should conduct like in general process. We have project manager and the development manager, development lead, test lead, and business analyst. So these are the participants of defect triage meeting. Now let's talk about what is the outcome of defect triage meeting. Outcome of defect triage meeting. So basically, when we have gone through the defect triage, so we used to have the following information. The outcome, I would say, defects are identified, right? All the open defects are identified. Second thing is severity and priority are decided. Third thing is assignment or assigned to particular developer. And status, what is the current status of the defect, and what is the resolution date. That is important. Date of resolution is important. And then time taken to resolve the defect, or how much time it will take, right? So time for fixing the defects, and last, time taken to fix the defect. So these are the outcome of defect triage meeting, guys. So this is all about defect triage. So let's talk about, I have written some of the other points as well, like some simple definition, like I would say the recap of defect triage. Defect triage is the process to prioritize the defects based on severity, risk, frequency of occurrence, which we have discussed about. If more number of open defects and less time for fixing, a meeting is conducted by project manager, developers, tester, and business user to identify the defect which are possible to fix and which are not. Okay, so this is the main idea behind a defect triage meeting. During the defect triage meeting, each defect is analyzed to see whether right priority and severity are assigned to it. Priorities are rearranged if needed. So generally, right, when we log the defect, then we used to decide the severity and priority, but it should be correctly assigned during the defect triage meeting. So these are the different points I wanted to discuss about defect triage meeting, guys. So let me know if you have any questions, comment your questions if you have any, and please like and share this video, and if you are new to this channel then please subscribe to this channel. Thank you so much. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is use case. So in this particular video I'm going to talk about what do you mean by use case, what is the need of use case, what are the different types of use cases, and at last we'll discuss about what is the difference between use case and test case. So let's get started with the definition of use case. What do you mean by use case? So it describes the system behavior or system functionality as per end user, or you can say end user perspective. So use case is nothing but the system behavior, how the system behaves as per the end user. So basically it describes the system behavior as per end user perspective. Now the question arises here is, why do we need use cases, right? So whenever we work on any project, so whenever we get the project, so what is the first criteria? So the first thing is get the requirement from the client. Get the requirement from the client whenever we start the project, and those requirements will be converted into different business requirement documents. Let's say we have business requirement document, we have BRS, business requirement specification, or FRS. So these are the different documents prepared by business users or business analyst, right? So we'll write down all the requirements over here. Now the use cases will be derived from these documents. So these are the detailed documentation, right? All the requirements are captured in these documents, but the system behavior is not described over here. So what business users will do, they will create the use cases, how the system behaves exactly as per end user, how they are going to use how our client is going to use the system. So they prepare the use cases, which is derived from these documents, and this is prepared by business user or business analyst, or you can say business analyst, right? And from here use cases are delivered to or transferred to development team. Use cases will be given to development team and testing team. So developer will uses those use cases and design their system and implemented the changes or implemented the requirements. So this is how they will do based on the use cases, because the system behaviors are defined or given in the use cases. Similarly, testers will use those use cases to derive the test cases, detail level test cases from those use cases, business use cases. So this is the flow, guys, and let's talk more about use cases. So it explains the functionality or requirement. The customer requirement or project requirement can be specified in the use cases. Use case is representation of actions which describes the behavior of the system to do a particular task and accomplish the goal. So what is the need of use case? To get the certain goal, right? To perform some task and to achieve the goal. So that is the purpose of use cases. It is a technique that helps to identify the test cases, and as I have explained earlier, from use cases we can derive our test cases. It is a description of particular use of the system by a user, and there are few things which are important in use cases. So the first thing is actor. Who is going to use the system? Actor. The second thing is system. So actor will use the system to derive the use cases, and third is use cases. So these are the three I would say the participants: actor, system, and use cases. So actor will participate in the system to derive the use cases, business use cases. So let's talk about what are the different types of use cases. So we have two types of use cases: diagrammatic use cases. The functionality is explained in the diagrammatic format. And the second one is technical use cases. It explains the functionality or requirement in technical way. Let's talk about them in detail. So what is diagrammatic use cases? So a use case diagram is graphical depiction of users' possible interaction with the system, and the use cases are represented by either circles or ovals. There are different use cases. So actor can be represented like this, and if you remember guys, probably you might have aware of UML, that is a unified modeling technique, unified modeling language in fact. So using that we create the flow diagram for the use cases. So there are different use cases like sequence diagram. It explains the flow or path. We have activity diagram. It explains the task performance, how we are going to perform using the activity diagram. And state transaction diagram, it shows the functionality or a state changing from one state to another state. So these are the different ways to create the use cases using diagrammatic use cases. Let me give you an example of diagrammatic use cases. So let's say let's talk about student management system. Student management system. So here we have an actor which is student, and here we have another actor called teacher. Now what are the different use cases in this student management system? So the first use case we can represent using oval. So check attendance. Check attendance is one use case. Another use case could be check timetable. This is another use case. Another could be check timetable, attendance, or we can say score, test score. What is your test score? So this is another use case. Another use case could be update attendance. Another use case, update score. This is another use case. So we have different use cases in this student management system. Check attendance, which is which will be used by both student and teacher, right guys? And check timetable, which will be used by both student and teacher. Check timetable. We have check test score, so which will be used by both student and teacher again. Now we have another use case which is update attendance. So who is going to update the attendance? Which is done by teacher. And the last one is update score, which will be done by again teacher. So these are the different use cases, and we have two actors, student and teacher, and this is the whole student management system, which will be represented using rectangle, right? So this is complete student management system, guys, an example of use cases. So these are the different use cases we have represented using oval shape. Now let's move on another thing, technical use cases. So for the technical use cases, below are the details. So we should have some details. We used to create some format of the technical use cases. So use case ID should be there, a unique number of every case. Use case name should be given. Goal of the use case, objective requirement, importance. So certain levels we give, like importance level, high, medium, low. Frequency of use, how frequently the requirement is used. actors, the user who has permission to access the requirement, and we have precondition, condition to be satisfied to work with the requirement, just like we used to give in test cases. Description, business functionality. Post condition, output or result. Assumption, if any assumption or implicit requirement is given, and approval of use cases. So this is, and another one is changes in requirement. Again, one more, if any changes are there in the requirement. So this is detail level use cases, which is nothing but the technical use case. Now let's talk about the difference between use case and test case. So use case is a representation of actions which describes the behavior of a system to do a particular task, to achieve a goal, or to perform certain tasks to achieve desired output, is nothing but the use case, which we have discussed earlier. Test case contains the test data, set of instructions to follow, and results of the following instructions. So already we have spoken about many a times about the test cases earlier. I have created the test case template as well, like what are the, we have expected result, actual result, fail pass criteria, test data, everything we have in everything we have as part of test cases. The second difference is use cases are prepared on requirements from BRS, as we have discussed. Test cases are prepared on use cases. So ideally, if you see the process, so use cases should be prepared from the business requirement documents like BRS or FRD or FRS, and test cases are prepared on use cases. The use cases cannot be implemented, which implies that it is only designed, whereas the test cases is designed and later we implemented them. Later we will execute the test cases as well. So basically use cases are executed by business users only, and test cases are executed by testers. So generally, if you see the use cases just for design purpose, right, for designing purpose, to later we use those use cases to implement, to design the system as per the development perspective, and design the test cases as per testers perspective. The objective of use case is to get a certain output after the set of operations. The objective of test case is to ensure the system is working fine for each given instruction and yields the required result. The use case is graphic representation of client requirements. This is another simple definition of use case. The use case is graphic representation of client requirements. The test case is only documented in an Excel sheet. It is working as following the step-by-step function ability of the software. It is working with the help of testers to validate the software. Business user executes the use cases. Testers executes the test cases. End result is important in all steps are to be executed together in use case. All steps are important and may have a separate result. So this is the difference between use case and test case, guys. And still, if you have any questions related to use cases, please write down your questions in the comment box of this video. Please subscribe this channel, like and share this video, and comment as I have explained earlier if you have any doubts. And thank you so much for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about the difference between test scenario and test case. But before I move forward and talk about the differences between test scenario and test case, let's talk about what exactly a test scenario and a test case. So let's get started with test scenario. So what do you mean by test scenario? So test scenario describes the end-to-end functionality to be tested in any application. So what do you mean by that? So let me just talk about some more features about the test scenario. So test scenario focuses on what to test in any application, what to test, and it is high level documentation, or we can say it has one-liner information. Mostly it has one-liner information. So it is high level documentation, guys, and test scenario derived from business requirement document or functional requirement specification. So it is derived from business requirement document or functional requirement document. So these are the different characteristics about the test scenario. Let me just give some examples about the test scenario. Some examples. So let's say we are testing e-commerce website. This is e-commerce website. Now what are the different test scenarios of this e-commerce website? So the first page is login page. So we are at login page. So we can say the login functionality. Login functionality is one test scenario, and there could be multiple test cases inside this login functionality. So this login functionality is one test scenario. Another test scenario could be home page scenarios. Another scenario could be in e-commerce website we are searching the product. So searching product itself is a scenario. Searching product, this is another scenario. And another scenario could be adding the product into cart. So that is another scenario. Making the payment or payment is another scenario. So these are the different scenarios. So it covers the end-to-end functionality of any in any application, right? And you can see it has one liner information, only login functionality. If you talk about the login functionality, so it doesn't contain all the information about the login functionality. So we have only high level information in test scenario. So these are the different points about the test scenario. Now if we talk about test case, right? So test case, what are the different information we have? So we have step by step procedure, right? Step by step. Let's say if we talk about the login functionality, so there could be multiple test cases in login functionality. So here we write different steps in test case, and it focuses on two things. First thing, what to test, and second thing is how to test. This is important. How to test. What are the different steps to test any functionality, and what is the test data? So it contains the test data as well. Test data and expected result. So already we have spoken many times about the test cases. So these are the information a test case contains. So it focuses on two things: what to test and how to test. Whereas test scenario only talks about what to test. So this is about test scenario and test case. Now let's talk about what are the other differences between test scenario and test case in detail. So this is high level documentation. If you talk about test scenario, which describes an end-to-end functionality to be tested, whereas test case contains test steps, data, expected results for testing all the features of an application. Easy to create and maintain. So since it is high level documentation, so it's very easy to create and maintain, whereas test case is hard to maintain and it's time consuming. We need some time to write the test cases for any functionality. And guys, anybody can execute the test cases if you write the test cases properly in step by step. So anybody can execute the test cases, even the user who doesn't know the application very well. Okay, but whereas if you talk about the test scenario, until unless if you don't know the functionality, you cannot execute the test scenario, right? So this is another difference. Test cases are derived from test scenario. Here test scenarios are derived from test artifacts such as BRS and SRS, software requirement specification and business requirement specification, whereas test cases are derived from test scenarios. It focuses on more what to test than how to test. So it focuses on what to test rather than how to test. And test case, a complete emphasis on what to test and how to test. It helps in an agile way of testing the end-to-end functionality. So agile way of testing means whenever we don't have much time going live of any product, right? So we don't have much time. So in that case, what we can do, we can just write the test scenario and we can execute for that particular sprint. So that is what it is written over here. It helps in an agile way of testing the end-to-end functionality. It helps in exhaustive testing of an application. So if you want detail level testing, so we will follow the test cases, right? Test scenarios are high level actions, test cases are low level actions. Example, checking the login functionality of the software, and here we have checking the login functionality when entering an incorrect password. So there could be different test cases for login functionality, right? Valid password and entering invalid password, valid username and invalid password, invalid username and valid password, and providing both invalid user and invalid password. So these are the different test cases of login functionality, right? So this is how we write test scenario and test cases, and these are difference between test scenario and test case. So guys, thank you for watching this video, and please like, share and comment if you have any questions, and subscribe to this channel if you are new to this channel. Thank you so much for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about the end phase of testing lifecycle, which is test closure. So earlier we have spoken about different phases of testing lifecycle, starting from requirement analysis, then we have test planning, test design, then we have test execution, defect reporting, and at last we have test closure. So once testing phase is done, then here we go for test closure activities. So this is test closure activities, which is the end phase of testing life cycle, which we are going to discuss today. So test cycle closure phase is completion of test execution, which involves several activities like test completion reporting, collection of test completion metrics and test results. So once testing phase is done, then we have to provide some deliverables to the client, right? Once testing is done, then we have to provide the results to the client. So the deliverables includes test results. Before that we have test completion report, or you can say test summary report, different metrics like how many test cases, what is the test coverage, how many test cases we have authored, how many we have executed, how many passed, fail, and how many defects we have reported, what is the defect rejected percent, what is the accepted, what are the different accepted defects, and test results basically. Okay, so these are the different documents which we used to prepare before signing off our testing activities. Test closure is a document that gives a summary of all the tests conducted during software development life cycle. So testing life cycle is part of software development life cycle. So these documents, what are the documents which we prepared in test closure activities? So these are documents includes objective met in our test closure activity document or test completion report. So whether objectives are met or not, time taken, what is the testing duration, total cost of testing, test coverage, and any defects found, basically the test results. In other words, test closure is a memo that is prepared prior to formally completing the testing process. So this is test closure, and testing team members meet, discuss and analyze testing artifacts to identify strategies that have to be implemented in future. So once testing phase is done, then testing team meets together and they'll discuss and analyze the testing results, like their artifacts, like what went wrong and what we can improve going forward. taking lessons from current test cycle, the idea is to remove process bottlenecks, the problems which we faced during the current test cycle for future test cycles. The entry criteria. So what are the entry criteria and exit criteria for test closure activities? So let's talk about entry criteria first. The execution of the test case is complete. So we go for test closure activities once execution of the test case is complete, once execution is done. And the second thing is test results are available and defect report is ready. So execution is should be completed and we reports all the defects to the developer and it is fixed by them. So we have defect report is ready, like all the defects are fixed and closed by us. Okay, so that is entry criteria for test closure activities. Exit criteria. What is the exit criteria? So delivered and approved test closure report. So we should have the signed copy of all the approved test closure report. So once it is signed off from the client, so that means that is the exit criteria for test closure activities. Now what are the documents involved in the test closure process? So test completion report is the important which we have spoken about. So test report is document that contains a summary of all the activities and final test results of testing project. Test report is an assessment of how well the testing is performed. Based on the test report, stakeholders can evaluate the quality of the tested product and make a decision on the software release. So all the documents when we provide to the client at the end of the testing phase, friends, so those are very important to evaluate the quality of our testing. Another document is test completion matrix. So after completion of testing, various metrics are collected to prepare the test reports, which I have already spoken about. Different metrics like what are the number of test cases we have authored, what is the test coverage, how many tests, what is the execution percentage, and how many test cases we have executed, basically what is the fail, pass, how many defects we have raised, what is the defect rejection. So all these different metrics which we use to prepare during the testing life cycle. So those we need to provide at the end of the cycle. Test results. So this is very important. Test results should be saved and can be produced along with the test cycle closure documents to support the completion of testing execution. Completion of test execution document should have screenshots. So screenshots are very important for the evidence purpose. Let's say if you come across any production issue and we have tested in our testing life cycle successfully and we have evidence of that as well. So that might be the defect because of some other changes or some other activities or some other functionality, right? So at that point of time we can provide our evidence, the screenshots to the next team, because we have tested it successfully and we have covered that functionality during our testing. So that is the use of screenshots, database query, results, recording, log files, etc. So these are the different artifacts which we used to prepare as part of test results. So this is all about test closure activities. So if you have anything, then please comment, and please like, share and comment if you have any questions. And if you are new to this channel, then please subscribe this channel as well. So thank you for watching. Have a nice day. Bye bye.
Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by build and release, and what is the difference between build and release. So let's talk about build first. So build is a process when developer used to give a version of software to the testing team for testing purpose is called a build. So why they used to give the build the version of the software to the testing team? So there could be various reasons for that. So whenever testers find any defect in the software, so they will raise the defect to the development team, they will assign it to development team, they will fix the code in their source code, and they will release the new version of the software. So that is one of the reasons of delivering the new version of the software to the testing team. Another reason could be if they are integrating one module to another module, so they will release the new software. So that is another example. And another example could be if they are making any changes to the code based on the customer requirements. So that is another reason. So these are the various reasons developer releases new version of the software. So how it happens, like what do you mean by build basically? So basically what they do is they whenever they make any changes to the code, they will compile it, they will run it their end, and they'll compress the code and deploy it to QA server. So this is the basic process of build, like how they build the code. So this is about the build, guys. And the release is nothing but it's a formal process. Whenever once testing is done, testing is certified. Formal process is nothing but the once testing is certified, and when we release the software to the customer, when we release the software to the customer or deploy the software, so in that process we'll deploy the software to their production environment. It's called the release process. So nowadays we have been using different DevOps tool to build any software. Like we have Apache Maven, Apache Ant, we have Cruise Control, we have Gradle, we have Hudson. So these are the different tools, DevOps tools available. So to build any software becomes very easy nowadays. So automatically it builds, it compiles the code, it runs automatically at their end, and then package the code and deploy it to particular server automatically. So this is how it happens automatically. Like it converts source code into executable program and deploy it to particular server using these tools. I can give an example. Like I have created so many videos. I have built a framework in Selenium automation. So we have integrated Maven with Git and GitHub, and then Jenkins. So whenever I check in any code, and whenever I make any changes to my code, and whenever I check in the code, automatically it runs, it builds the software, it builds the new version in Jenkins automatically, and it runs the build automatically. So that's how it happens when we use DevOps tools. Okay, so this is about the how we build the software, and this is basically the difference between build and release process. And so nowadays it becomes very easy when you use DevOps tools. So like Amazon releasing the software in every 11.7 seconds. So with their cloud services and their DevOps tools, they are releasing the software in every 11.7 seconds. And Netflix, they are releasing the software like 23,000 in a day. So using DevOps tools, life becomes very easy. So I'll talk about DevOps different tools. However, I have discussed I have created so many videos on Selenium automation using DevOps tools like Maven, Git and GitHub, Jenkins related. But going forward, I'll create so many other videos as well in DevOps. So this is all about today, guys. So thank you for watching. Have a nice day. Bye bye.